Okay, do we have an acquisition of signal? YouTube chat, this is EJSA Control. Do we have an acquisition of signal? Welcome to part 16 on the YouTube side of things. This is part 16 of the Artemis 2 mission. We are entering flight day 7 here. Astronauts have been woken up, and we rage loud and clear. Roger that. Astronauts have just woken up. Mission elapsed time right now, guys, is 5 days, 17 hours, 52 minutes, 5 seconds here. We're on flight day 7, and astronauts are in the post-sleeping period, basically where you get up and nothing gets you down, except the Earth. The Earth is pulling them back in. The Earth is going to pull them back down. So currently, Orion integrity is 238,965 miles from the Earth, traveling at a speed of 1,287 miles an hour, or 384,577 kilometers, traveling a little over 2 kilometers. I was about to say 2 kilometers a second. No, not the same thing. 2,071 kilometers an hour. Hey, Silent Guardian, thanks for that Prime sub, dude. I appreciate it. Shadow Rage, what do you say? Like pineapple, strawberries, blueberries, apples, oranges, and peaches, by the way. Hey, don't mess with me, dude. Don't mess with me. I'll send you the biggest fruit basket you ever seen. And here's the thing. I'm not going to tell you when I'm doing it. It's just going to show up at your door. Your wife's going to be like, Miss Shadow Mage, what is this? Oh, yeah. That's the fruit basket.
Good morning and welcome to Artemis Mission Control here at Johnson Space Center in Houston.
If I can send you a fruit basket and make it an awkward conversation between you and your significant other, I will consider it a success. The mission will be succeeded. Or the mission will succeed. Yeah. Leah Cheshire Mustachio.
And is the only voice you'll hear communicating with the crew. Of course, there is an exception for that today, during which the science team will be conducting their post-lunar flyby conference. If you tuned in yesterday, you got a treat, and we got to see amazing views of the moon, as well as hear the crew's description of them. Now, while the crew was taking those photos, they were also recording private voice notes that they sent down to the science team overnight. This morning, the science team is going to talk about the observations that the crew made while those are all still fresh. We've also got some other exciting activities coming up today, including a ship-to-ship call. The Orion spacecraft and the 4 Artemis 2 astronauts, Reed Wiseman, Victor Glover, Christina Cook, and Jeremy Hansen, will be calling the International Space Station. We have 7 crew members living and working aboard the International Space Station, and we've just surpassed 25 years of continuous human presence living and working in space. This will be the first time that these 2 spacecraft have ever talked to each other.
Ship to ship, baby.
We are on flight day 7 with a mission elapsed time of 5 days, 17 hours, and 53 minutes. We're gearing up for a great shift today, and thanks for tuning in.
No, thank you, Leah. Dude, Leah's an excellent commentator. She's fantastic. Like, she's really good. Her, Sandra Jones, out of JSEPAO, Gary Jordan, they're all fantastic. Dan Hewitt was here too, but he went to SpaceX. Dan Hewitt is the main communications guy for SpaceX nowadays. Dan's amazing. All those people are freaking awesome. Someone send her a fruit basket. You gotta play hardball, chat. Send him a fruit basket.
The Artemis 2 astronauts woke up just after 10 a.m. Central Time, and the song you heard playing was Tokyo Drifting by Glass Animals and Denzel Curry.
Nani?
They are currently in their post-sleep period. This is an opportunity for them to get the cabin ready for the day by stowing any window shades that they put on Orion's windows over the night, or stow their sleeping bags that they hang up in the spacecraft to sleep in. They also get a chance to brush their teeth, complete any hygiene activities, and eat breakfast. On the menu today is Mexican scrambled eggs, granola and blueberries, a cinnamon bun, cashews, couscous with nuts, tortillas, and some coffee.
What was that first one?
Activities and eat breakfast. On the menu today is Mexican scrambled eggs, granola and blueberries, a cinnamon bun, cashews, couscous with nuts.
Oh, dude, I swear they're trying to break that thing. They're stress testing that damn toilet. Like, what are you doing? I mean, dude, that's gotta be on purpose. We know, like, jokes aside, we absolutely know that they're doing developmental flight test objectives with the food, because Reed was talking about it. He was talking about DFTO ops with the food. All right, dude, I swear they're trying to break that toilet. I swear. It's a test mission. Yeah, no, I mean, it makes sense, dude. Mexican scrambled eggs with chorizo. Absolutely trying to break that damn toilet. Yeah, that's what I'm saying, dude. No wonder the damn thing broke so much. Dinner tonight is cuttlefish and asparagus. Like, what the hell? Like, that poor toilet. Now I kind of feel bad for it. Like, no wonder it broke. Mexican scrambled eggs are basically eggs with onion and tomatoes. But see, they got hot sauce up there, Joshua. They got 5 hot sauces up there. So, you can't not put hot sauce on Mexican scrambled eggs. You just can't. You have to. Actually, I'm wondering if they have some salsa verde.
You're looking at a live view from Orion from one of the solar array wing cameras. There are 4 solar arrays with a camera mounted on each of them. Of course, we got great views during the flyby yesterday, but these are also used to check out the spacecraft. Orion is currently 38,210 miles away from the moon. At closest approach yesterday, they were about 4,067 miles from our lunar neighbor. They are 234,839 miles away from Earth. That number will continue to shrink as we prepare for splashdown, now about 3 days, 7 hours, and 20 minutes away.
It'll all be liquid waste. Yeah, I know, Rizik. That's Orion the problem. The liquid waste dump is not working.
Influence, or the time in which the moon's pull on the spacecraft, is greater than the Earth's at 12:21 p.m. Central Time today. Yesterday was an extremely busy day for the Artemis 2 crew, spending 6 hours, or approximately 6 hours, taking photos, making recordings, making annotations of everything they saw on the lunar surface, and sharing all of that with us on Earth. We've been able to share some of those images so far, and if you would like to find them, you can visit NASA or NASA Artemis on social media. And because of the crew's busy day yesterday, they have a little bit of time off this evening. They also have the opportunity to speak with their families today.
Family, 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 family. I did it because of family.
This afternoon, we're also expecting to see the RTC-1 burn. This is return trajectory correction burn. If you recall, on the way to the moon, we had outbound trajectory correction burns. We canceled 2 of those, they were deemed unnecessary ahead of our lunar flyby, and we executed 1 of them to just further refine the spacecraft's trajectory. We do have one of those scheduled for today. This, again, is a return trajectory correction burn. This is a smaller burn using the RCS, or Reaction Control System thrusters, on the service module. If you look closely in this image, you can see a large bell shape. That's the OMS engine, the Orion, or the Orbital Maneuvering Service engine. That's the engine that was used to perform the translunar injection burn.
She almost called it a shuttle engine.
That sent us beyond the moon, but also what committed us to coming back to Earth.
They're on the way back, Bmore.
Just ahead of that burn, Christina Cook said, "With this burn, we don't leave the Earth, we choose it." These return trajectory correction burns help further refine their path back to Earth.
I wonder if the crew watch your stream anytime during the free time. I don't know, man. Maybe, probably not. I don't think they have enough bandwidth to watch a live stream up there. Retrograde or prograde burn. So speed unit, the RTC burns are most likely just pulsing the RCS. They will announce, they do announce the readback on the RTC burn, and they say the delta V in all three axes, so I'll be able to tell you. It's most likely not a prograde or a retrograde. If I had to guess at this distance out from the moon, it's probably coplanar normal or anti-normal or radial in or radial out. It's one of those, or somewhere in between. They're basically setting up the maneuver node. They'll set up the maneuver node and they'll say all the adjustments to the maneuver node. And yeah, they'll yeah, we'll see. I'll be able to tell you when they announce it. Wonder if the ISS crew got to watch the A2 mission. Most likely. Like, do they go through the heat fire stuff? Oh, reentry. Be more funny. Yes. They're going to hit the atmosphere going 25,000 miles an hour. Actually, it's probably a little bit north of that. It's going to get a little spicy. KSP terms we like. I mean, Dallas, those aren't KSP terms. That coplanar normal, anti-normal, and radial in, radial out is orbital mechanics, right? But Kerbal terms though, that's just orbital mechanics, right? I would love to see that. That's happening on Friday morning. Be more. Yep, Friday morning. The ISS did watch the launch. That's right, Flavia. Yep. Isn't that the fastest humans have ever entered the atmosphere? Apollo 10 has the speed record. This will get close to it, Tweets. I'm not sure if it's going to break it. This is Artemis mission control here, Tuesday, April 7th, on flight day 7 of the Artemis 2 mission. Our crew members woke up at 10:35 a.m. Central Time. They are in their post-sleep period, so we won't hear from them probably for a little while. We will have the daily planning conference with them in about an hour and a half. Just before that daily planning conference, Flight Director Jeff Radigan will gather inputs from the teams here on the ground in Mission Control Houston. This could be anything about the astronaut's schedule for the day, vehicle system information, as well as answer questions from the crew. We'll see, Will. You're going straight into hibernation after this mission. Actually, guys, the sleep schedule on the first day sucked because of that the split sleep. That did screw me up, but I'm actually fine. I'm good. Yeah, I'm good. Jeff Radigan's he's a real one, JFK. Jeff Radigan's cool. I became a fan when they did an Artemis 2 press conference a little while back, and they had him, Judd Friedling, and the other guy's name is Rick. I forget his last name. Rick Henling, I think is his name. They had all the flight controllers up on a panel, and dude, just hearing them like talk about the mission and different phases of the mission. Oh my goodness, was it cool? I'm like, oh, these guys are. Oh, okay. They're cut from the same cloth as Gene Kranz. Okay, all right. Nah, you're cool. I like you. You're all right. Flight operations, baby. Are they facing the dark side of Earth right now? Etronix, let me show up. They're doing a poo dump. I saw it. They're doing the poo dump. Wastewater ejection. So we need NASA eyes. Where is Orion? Orion's coming back towards the moon. But just like before, they keep the heat shield facing the heat shield, the engines and the solar panels are facing directly towards the sun. This is called the biased XSI configuration. Yeah, they keep the back facing towards the sun to charge the solar panels and put the heat shield between the crew and the sun. So the moon is a little ways behind them, but here, let's zoom it out. You can see they've done their return trajectory, and now what they're going to do is come back and go over there. Here, I'll show you what the rest of this looks like. They're going to come down here and then whoop. That's it. Where are the antennas located? The antennas are on Orion proper. I'm not exactly sure where they are. They're probably behind a panel, like they were on the shuttle. But if I had to guess, they're probably right here. That's where it was on the shuttle. It was right above the flight deck. But I don't know for sure. I'd have to go look at Orion's user's guide. Give me one sec. Orion, okay, here we go. Orion uses a high-speed communication system employing 4 phased array antennas on the crew module. Oh. And 2 more phased array antennas on the service module. Phased array antennas allow signals to be controlled and directed without requiring any physical movement of the antenna. Oh, fancy. Wow. I did not know that. Wow, I like this capsule even more now. You don't need to position an antenna. There's phased array antennas all over. The crew will also have an emergency radio system to allow voice communications anytime during a mission if the main communication system were to fail. So there's a short band radio on it as well. Near 180-degree view per antenna. The Deadbringer, if they got 2 on the service module and 4 on the capsule, yeah, capsule can be in whatever orientation, and you don't have to worry about pointing, positioning an antenna. It'll just work because the phased array. That's really smart, actually. After landing, the crew has search and rescue radios as well as satellite phones for communications with recovery forces. There's also an audio system on board that allows astronauts to speak with each other and with the ground while they're wearing spacesuits. Yep. Can I get the NASA badge here? No, unfortunately. 10 years later. Huh. They should have given you drops. Next time. Yeah, OpNav. They also have optical navigation. They have 2 redundant star trackers. They got sun sensors on this thing. Dude, this thing, Orion's a monster. I didn't realize it. I knew it was pretty good, right? But I didn't realize how good this thing actually is. This thing is an absolute unit of a spacecraft. It's pretty good, man. Yeah, there's the solar panels. And see right there, that's the mount for the camera. There's the mount for the SAW cameras right there. Have you already seen pictures of it on images.nasa.gov? Yeah, you could say that we have seen these. This is my favorite picture from this mission. By a long shot. No one's ever photographed an eclipse from this angle ever. That's never been done. And look at the results, dude. Saturn, see the stars over there? See the three little things over there? That's Saturn, Mars, and Mercury. Hey, I memorized it. Yes. All right. Bro, that's a real picture. Can you believe that? Can you believe it? That, dude, where are you finding those docs you were reading? Oh, here, I'll link it to you. Where did I find it? It was linked to me by people who know things about things. I'll link it in both chats. So the Orion S-band communication system provides functionality of 4 radios in one, allowing communication with multiple space vehicles. So they're going to C2C it. Orion can split the signal. You can send multiple data over one frequency, which is, yeah, that's kind of the norm for like deep space communications, right? So they're going to be able, like, you can communicate with 2 different vehicles at once on top of the phased array system. That's pretty trick, man. NASA's near space, so it could use It could use near space direct to Earth. It could use TDRS. It can use DSN or any combination of anything above. That's what the C2C call is about today. It's testing that system. Glass cockpit provides fully redundant crew controls and displays with over 60 GUI formats and interactive electronic procedures. A first in spacecraft history. All right. Space shuttle had a glass cockpit. Whatever. Instead of relying on physical switches distributed across a vast flight deck, an astronaut will be able to control all the vehicle systems from a single operator station using virtual switches on display. Bro, you're flexing it that it has a touch screen? Compared to the Apollo single flight computer, Orion has 2 simultaneously operating redundant flight computers. Each of these includes 2 redundant computer models, giving it a total of 4 redundant systems. We landed on the moon back in the 1960s. So why are we going? What are you asking, Leroy? Why are we going back up to scope it out to see if we can land? Well, this time we're going to try to build a moon base there. Well, not try. This time we're building a we're going to try to build a moon base, Leroy. The reason why is the moon is a really good training ground for learning how to work on Mars.
This is Artemis Mission Control with a mission last time of 5 days.
It's in deep space. So unlike the space station, right? The space station is inside of the magnetic field. A moon base is outside of the magnetic field. A little bit of a different ball game there, right? And if you can figure out how to live off the land on the moon, you can figure out how to live off the land on Mars. Oh, dude, wait, hold up.
During that mission, should it have occurred, it was on display in the NASA headquarters building in Washington, D.C., making its way around the moon over 50 years since its originally intended flight. The other American flag aboard Orion is from a little more recent history. It was flown on STS-1, the first space shuttle flight, STS-135, the last space shuttle flight, and NASA SpaceX DM-2, or Demonstration Mission 2, which was the return of launching American astronauts from American soil on American rockets.
They have the flag.
This is a picture of that more recent flag that is stowed aboard Orion for this mission.
Oh, that's cool. So there was a flag, an American flag that flew on STS-1. And then on STS-135, they flew the last shuttle mission. They flew that same flag up to the space station and left it there for whoever could get it from the commercial crew program. SpaceX got it with the DM-2 mission. They went up, they brought the flag down on a Dragon, and then they put it in integrity and they launched it now. That's cool, dude. That's cool. That flag has been to space more times than pretty much like 99% of people.
To the world last year. They said the Artemis 2 test flight begins when a mighty team launches the first crew of the Artemis generation. This patch designates the mission as all, signifying not only the second major flight of the Artemis campaign, but also...
You know what? I'm going to rewind that real quick. Did I hear that? Yeah, we came in at the very end of that. I just want to see it real quick.
Official flight kit aboard Orion are on their way home, having flown by the moon yesterday. This is the first flight of humans aboard the Orion spacecraft, and in the official flight kit aboard Orion are some special flags. One of those is from Apollo 18. This is the American flag that would have been planted on the moon during that mission, should it have occurred. It was on display in the NASA headquarters building in Washington, D.C., making its way around the moon over 50 years since its originally intended flight. The other American flag aboard Orion is from a little more recent history. It was flown on STS-1, the first space shuttle flight, STS-135, the last space shuttle flight, and NASA SpaceX DM-2, or Demonstration Mission 2, which was the return of launching American astronauts from American soil on American rockets.
Come to think of it, I do like to brag, and I'm mighty proud of that ragged old flag.
This is a picture of that more recent flag that is stowed aboard Orion for this mission.
Something about New Glenn? New Glenn who? Ugh.
In this photo, you can see half of Earth is experiencing nighttime, or a little more than in this image. And that dark line across the Earth is the terminator. We heard that mentioned several times yesterday on the moon. That dark terminator line is the difference between day and night. Of course, in the foreground, our very beautiful moon. Yesterday, at closest approach, the astronauts were about 4,067 miles away from the lunar surface. We continue to get beautiful imagery from the crew, and you can follow NASA on all social media accounts at NASA and at NASA Artemis to make sure that you see it too.
Yeah, Bouncy,
if you're a new spaceflight fan, we also have a lot of other ways you can get connected. If you like podcasts, NASA has a handful of official podcasts, including the one produced here at Johnson Space Center called Houston, We Have a Podcast. Houston, We Have a Podcast now has over 400 episodes, including interviews with astronauts, scientists, engineers, and more. Most recently, we shared an interview with the Artemis 2 crew. You can find that and more at nasa.gov/podcasts.
Where are they now? They're coming back from the moon, Hazy. They're about 234,000 miles from Earth and 38,000, almost 39,000 miles from the moon. 1,300 miles an hour. As they get closer back to Earth, this is going to start, the speed's going to start going up.
If you're just tuning in, we are live from Artemis Mission Control in Houston, Texas. We are in the middle of the astronauts' post-sleep period, having woken up at 10:35 a.m. Central Time. They have another hour or so in this post-sleep period, so we may not hear from them very much, but we will during the daily planning conference when they will speak with the team here on the ground, specifically Capcom Stan Love and Flight Director Jeff Radigan.
Stan! How's the morning? Pretty sad that NASA can't make a working space toilet after 50 years. Lewis, it's a test flight, dude. They'll get it dialed in after this, man. And keep in mind, guys, the reason why the toilet working is just, the reason why it's not working is purely out of an abundance of caution. The heaters for the line dumping system, for the wastewater dumping system, started making a burning smell inside of the cabin. So they shut them off. They were working just fine. And there was no telemetry indications to suggest that anything was going wrong. They just made a burning smell. I don't know about you. I'll take peeing into a bag over a burning smell inside of the cabin. So, dude, it's a test flight. They'll figure out what made that happen with the waste dump system, and yeah, it'll be fine. I'm sure they'll have it fixed by the next time Orion flies. Why won't they be the same astronauts on Artemis 3? JFK Hero, you gotta have a crew rotation. right? I would want. So JFK, how I would do it is so we have Jeremy Hansen from the Canadian Space Agency. We have Christina Cook from NASA, Victor Glover from NASA, and Reed Wiseman from NASA. What I would do is the next 4 missions, I would have each one of them command it, right? The whole point here is to get experience with going out to the moon, right? So for the next 4 missions, I would have Victor command 1, Reed command a second one, right? Christina command 1, and Jeremy command 1. That's what I would do. That exponentially grows your experience of astronauts who've been beyond low Earth orbit, right? And they tell 2 friends, and they tell 2 friends, and so on, and so on, and so on, and so on. You know what I mean? That's what I would do. Because for the next mission, you're obviously going to want somebody with some lunar experience, right? And they tell 2 friends. You're going to want somebody with lunar experience. You're going to want the people that have been there already. They're not launching Charlie Duke into space. I mean, unless he wants to. I'm pretty sure, I don't think he wants to, but maybe, you know, who knows? Where should the next international not come from? Japan. Japan's sending PlayStations. The next mission is in low Earth orbit, though, no? Yeah, so? Are you not flying Orion, Big Pooh?
Discovery, go at throttle up.
Reed, Victor, Jeremy, and Christina is Jeb, Bill, Bob, and Val. Mother of God, you're right. And they are wearing orange suits. What's up, EOD? Hey, Galax, what's up, man? When is Splashdown? Friday morning, Anonymous. Flight day 10. Technically, it's flight day 10, but flight day 10 is, if you look, flight day 10 is basically get up and then re-enter. That's it. Once again, I am streaming until over here. Until we get confirmation that Jeremy, Reed, Christina, and Victor are back down on terra firma, I will not shut the stream off. Put the shades back on like it's 2015 again. Do you work for NASA? Elliot, no. This is a fan-run channel with permission, like run with permission from NASA. Like NASA was the NASA Twitch account was chilling in here yesterday. So yeah, no, that we're good. But yeah, I'm a fan-run channel. KSP has had its highest concurrent users since its launch. It's all coming together, dude. Hey, guess what? Hey, guess what we're playing next week? EJ's just 3 fans in a trench coat. No, 3 Kerbals in a trench coat. Factorio? Shut up.
This is Artemis Mission Control at Johnson Space Center in Houston, Texas. You're looking at a live view from Orion, a camera mounted on one of its solar arrays. The spacecraft now 234,311 miles from Earth.
Have they left?
And that distance
lunar
continuing
space?
to shrink. You can keep up with Orion's location and positioning at nasa.gov/track Artemis.
Yeah. They're pretty much
still in their post-sleep
They're pretty
period,
much out of
and we
lunar
expect
SOI.
to hear from them for the daily planning conference coming up in about an hour and 10 minutes.
See how their trajectory is pretty dang straight from here on out, it's going to go straight, and then it's going to
Orion will
turn
also
back
exit
just like
lunar
this.
sphere of influence
See?
today. That's coming up in just 21 minutes at 12:21 p.m.
See?
Central Time.
I know what I'm talking about, dude. Like,
The
I'm not
lunar
gonna sit and
sphere of
pretend like I
influence
don't.
is when the moon's gravity has a greater pull on the spacecraft than that of Earth's.
Can you explain the 3D visuals? Well, that is a 3D model of Orion. It was probably modeled in, I don't know, let's say AutoCAD, and then they put it on a screen. But that's not important right now. The Orion capsule is in a bias XSI configuration, meaning that they point the heat shield and the solar panels at the sun, so the crew doesn't get too hot. Actually, that's really kind of more the reason than anything. And charging the solar panels. So the view that you're seeing on the stream, you see the moon in the background. They're looking at Orion from this angle, which, I don't know, that's a little bit of a weird way to look at it. But yeah, it's going away from the moon. And it's going back towards, no, it's not going towards Jupiter. Where are you, Earth? Where'd you go? Earth would be over here. There it is. It's going back towards Earth. They're going to exit lunar SOI, lunar sphere of influence here very soon. Like I was saying, that is the point where the lunar gravity, where Earth's gravity pulls more than the moon's gravity. The moon doesn't have nearly as much gravitational pull as Earth. It's about 1/6 the pull, because it's about 1/6 the mass and density. So it's pulling them back. And then from there, the trajectory is going to go this way, and it's going to go back here. It kind of forms a figure 8 symbol. I am your density. What? It will accelerate as it gets closer to the Earth. Too hot? Yeah. The Earth's gravitational pull is going to pull you in. BF6 or Helldivers, Spitz. For after the mission's over, I might play some BF6 maybe to chill. But yeah, no, we're gonna be playing Kerbal for a little while. What's that red blob? It's just the lens flare from the sun. This is a solar array camera. On the solar array wings or saws for Orion. Orion has 4 solar panels, and they can move them back and forth to orient them to the sun. And the camera's on the end of the panel, so the panel's facing into the sun. So there's a lot of lens flares and stuff. The sun is like right over there. Can we see Artemis? Artemis is right there, dude. It is a free return trajectory, Yuki. Yeah, it's a free return trajectory for the nerds. They're going to have to do some return trajectory corrections. The RTC-1 burn is scheduled for today, but they should be leaving lunar SOI very soon. Let's recreate this in KSP. I have a pretty good Orion capsule to do that, dudes. I actually want to upgrade my Orion capsule now because mine doesn't have my capsule doesn't have movable saws. I can't move the solar array wings with mine. Now I want to do that. Now I want to make that. For longer distance missions, Mars, Venus, could they use these free returns and gravity assists to help slow down the reentry speeds? A free return really only works in a 2-body system where one thing is orbiting around the other. For Mars, Snibbles, because you're going planet to planet, no, not really. If Mars had a bigger moon, yes. But even then, it's really just going to change the direction. You're not going to really use it to slow down. The best way to get to Mars, to basically, like hit the brakes when you get there, is to hit Mars's atmosphere. Mars does have an atmosphere. It's not breathable, but there is trace amounts of CO2 and oxygen and a bunch of other stuff. It's just not a lot. It's definitely not enough for your lungs to work correctly. But you can use that to slow down and stop. Hey, Celtic, what's going on? Where's the antenna on Orion? So, Yoshi, we just actually figured this out. Orion has 4 phased array antennas on the capsule. They're at 12, 3, 6, and 9 around the capsule, if I had to guess. And then there's 2 more phased array on the service module. They have 2 more phased array antennas on the SM. I don't know where they are. If I had to guess, there's probably one on the back somewhere and maybe one on the side. But, yeah, phased arrays, dude. So, yeah, you don't see an antenna particularly. I mean, this with OpCom and OpNav, holy crap, dude. This capsule is fantastic. They really pulled out all the stops with this thing. It's pretty good. Have you played Reentry? Yeah, of course. Not on stream, though, Steve. Is rotating humans around Jupiter a possibility within the next 40 years? I mean, JFK, I don't mean to give you a vague answer, but that really depends on if we want to take spaceflight seriously as a country. I think we should. I've been saying that for the last 15 years. There's people out there that have been saying it way longer than me. Yeah, if we take this seriously and we really, get Orion working, and then, guys, the other thing is that Orion is designed to link up to bigger vehicles and then become basically the command bridge for larger vehicles. So you can use it to go places further, right? That's the whole idea with the Orion capsule. That's what it's designed to do. So you can use it to go further places with transfer vehicles. Oh God. All right. Give me a second. I'm sorry. I need more coffee. So yeah, if we want to take it seriously, I would start with making sure we have SLS and Orion missions past Artemis 5. If we take it seriously and start ramping up SLS and Orion production on top of Starship and what Blue Origin is doing, yeah, I think there's a good shot that happens. Down to my last cough drop. Sobering info, but I asked ChatGPT what's the earliest year we can send a crewed mission to Proxima, and it told me 2500 at the earliest, but also possibly never. Screw you, ChatGPT. Yeah, Dorian, yeah, that about covers what I was going to say. What's going on over there? I'm not sure what that is. I think it's just a glare from the sunlight because you see it down here too. The solar array wings are wobbling, which means somebody's working out. That when the solar array wings go back and forth in a rhythmic motion like this, that means someone's using the rowing machine. Proxima Centauri is a long way away. I mean, Proxima is the closest. No, Alpha Centauri's closer, isn't it? Oh, excuse me for a second. I have to ban slop from my chat. Thank you. Proxima is the closest, yeah. And then Alpha Centauri, and then Proxima orbits Alpha. Yeah. Guys, I don't think that's impossible. You could do it conventionally. It would take a long time to get there. Like, you could do it with chemical propulsion. Sure. It would definitely be a one-way trip.
This is Artemis Mission Control in Houston, Texas, with a mission elapsed time of 5 days, 18 hours, and 35 minutes into the
I don't
Artemis
think that's
2 mission.
impossible.
You're looking at a live view outside the Orion spacecraft from a camera on one of its solar array wings. Orion completed its flyby of the moon yesterday, its closest approach at about 4,067 miles. They are now 39,532 miles away from the moon.
What are they planning to accomplish with this mission? Datraven, this is really a shakedown for the Orion capsule. That's the big thing. This capsule is one of the building blocks that you need if you're going to explore the moon. You know, like, think about it like this. The moon is a campground, right? And you're not going to go to that campground without an RV. You need the RV, and it'd probably be a good idea to make sure the RV works before you go camping in it, right? That's what this is. This is a shakedown cruise for the Orion. This is testing it, making sure that it works. Making sure that it works correctly, making sure that that all systems on the capsule are working as intended, toilet notwithstanding. And yeah, they got those lunar pictures just kind of as a bonus. Yes, that's a real picture. They took it from the solar eclipse that happened when the sun transited the backside of the moon yesterday. That's also Saturn, Mars, and Mercury right there. Thank you for taking the time to explain. That's what I do, Eureclusis. That's my thing. I teach people about space and science here on Twitch. Like, I'm more of a engineering type of thing though. Like I like astronomy and stuff. Like I know that those planets are there. Like I know what the moon is there. Like I know the stars, etc., etc. I'm more spacecraft engineering. That's what I'm really into. But yeah, that doesn't mean I won't teach people that, you know, Saturn, Mars, and Mercury are right there. Right? These are some of the pictures that they got. There's Oriental. That's the Oriental Basin right there on the backside of the moon, because it's the backside of the moon because Earth is in front of us, right? So these pictures were all just a bonus. Look at freaking look at that. Holy crap. Do you know how fast they'll be moving at splashdown? Would it be possible to land on solid ground? Yeah, you could land it on solid ground, Jacob. It'd be a little bumpy, but yeah. I mean, ideally the capsule is designed to land in water. So if you design it to land in water, you probably should land in water. But it could do land if they absolutely needed to. It'd be a little rough, but you could. Picture the lunar South Pole. Where can I get these pictures? Images.nasa.gov. It was linked in the chat. So how many people we got to fit into a capsule that gets Proxima Centauri just using waste dump Delta V? Yes. Are they landing in the Gulf? No, Dorian. They're going to land in the Pacific Ocean off the coast of San Diego. Hopefully in 100 years that pole will look completely different. I hope so, Veljex. NASA did have plans to land Orion like CST-100 under the Constellation program. Yeah, Mini Elon, that's why I said I'm pretty sure Orion can do either, but for this particular mission, and I can't stress this enough for like people that don't understand how this stuff goes. NASA intends to land it in the water. They're only going to land it on land if something goes horribly wrong. That's not really how spaceflight works, right? Like, you don't want to just switch it up and land on land. It was designed on this mission to land in the water. And the closer you get to where you intended it to land, the better. No, Till, I'm not interested in astronomy. I know that astronomy is cool, and I know that it's a vital component to it. Like, believe me, I've looked through telescopes many times. That's just not what captures joy. Like, here's my thing about astronomy. Is it awesome? Do you see crazy stuff up there? Absolutely. Is it profound? Yes, absolutely. I want to send people there. We've been staring at the stars for too long. We did send people there. I want to send people there. Go. Telescopes, we got plenty of those. Send people there. I'm not saying we shouldn't make more. Right? We should make more telescopes. And then send people there. That's kind of where I'm at. Like, that's why I like spacecraft design. That's really where joy lies, the passion lies with me. Like, dude, like, I look at them and it's profound and it's awesome and I love it. And I'm not harping on anybody that's into it, right? Like, astronomy, like, how the heck do we know where to send stuff? You got to look through a telescope and figure it out. Absolutely. That's what I mean. We should build more of those. But also, I'm sick of looking through a telescope. We've done that for like the last 50 years. I've only been privy to 37 of those, right? Let's go. Do this. Do more of that. Green screen. Yeah, I do have a green screen. Yes. Here. Let me show you. See? It's green. You're right. Told you. What did you think? I'm just floating around in space? What are you, dumb? Hey, Sierra, it's $7 for flight day 7. $7 super chat. Probably be not as exciting as day 6, but boy, those are some amazing photos. We need more SLS launches. We do. Is that Jewel? Yeah. Bring back the orange screen. I don't even know where that bedsheet is anymore, Hazanku. Can we get a Rise plushie emote? I'll think about it. Guys, we got another person in Twitch chat making a fool of himself. Should I feed the trolls? Should I feed the trolls? I kind of want to. Nah, all right. Yeah, you're right. You're right. I see more no's than yes. All right. I'll just let him keep making a fool of himself in chat. That's fine. Nah, this mission's too cool. I don't feel like feeding the trolls today. When are we scheduled to land on the moon? Kibes, 2028 is the tentative schedule. There might be some flux in that schedule. I don't know when it's going to be in 2028. It might be earlier. It might be later. If I had to put my money on it, I'd say later in 2028. Yeah, be more. They kind of do. I kind of just... I mean, yesterday it got kind of bad, and I think my mods are doing it. But now chat's a little bit more chill, and I just kind of let them talk. I'm not gonna ban somebody for being like, oh, it's fake. Like, no, dude, I give you the rope. You keep talking, make a fool of yourself. That's fine. Block him? Nah, I don't like doing that. I like watching them. You know, I like giving them the rope. You know what I mean? Wait, they aren't landing there? No, Kibes, this was a flyby. They only went near the moon. They didn't come back. They didn't land. And they're on their way back. That's what I'm trying to say. Will you show us the KSP vehicle you will use to simulate this mission? I mean, if you want to see my Taurus capsule real quick, I guess I could show you. Give me a moment. Like, I'm not going to fly it or anything. I'll show you the capsule, though. Nice wallpaper. Thank you. What mission is that from? It's from STS-135. That was from the last shuttle mission. That was taken from the ISS as the shuttle was approaching. It's one of my favorite pictures from the shuttle program. Why is that background? You must change. No. No, I don't want to. You can't make me. Oh, look. The VOD got demonetized for the Tokyo drifting music. That's great. I have to mute that segment there. Lovely. Thank you for demonetizing a 12-hour VOD with a 30-second music segment. That's great. All right, cool. Trimmed it out. We're good. Why is this taking so long? Kerbal usually doesn't take this long to load. Maybe we should restart this computer. Hey, Bob, what's going on? One eternity later. It's taking as long as a waste dump. That photo is on the wall in Mission Control outside the Flight Dynamics office. Yeah. It will come with P fuel. No. Did you install new mods recently? No. It's just, yeah, Kerbal really doesn't usually take this long. Maybe it's because I got a bunch of windows open. Yeah, thanks, Drummer. I'd say that guy. I think that guy that was making a fool of himself might actually have been serious. So, good luck. Good luck out there, man. Yep. How to get the NASA badge? You got to watch NASA's stream, dude. Yeah, I think he actually may have been serious. In which case, like, good luck to you. Good luck. You're not going to get very far in life. That's a shame. Oh, well. Can't win them all. Hey, look, Kerbal finally loaded. Wait, is this the live Artemis coverage? This crew looks a little foggy. Yeah, froggy? No. They're little green men. Career mode 25 is where the Taurus capsule is. It's weird because, you know, like skeptics always go back to the same argument about truths and post-truths. And you know what that tells me? They know nothing about engineering, which, like I said, just here, have some rope. All right, so here's my Orion capsule. It is crew capsule prototype right here. It has the LAS on it, but yeah, there it is. Yeah, see, I have a jettisonable here. I'll show you. I jettisoned the LAS right there. And then I have the I built the ring out of fairings for it. I built the LAS to work like the real one. It separates just like the real one when we made this. And then if we take this and we move this back, right? There it is. So I engineered a slightly bigger service module for mine. And now that I'm looking at it, my RCS is not placed in the right positions. We should give that a detail pass. We should give it a detail pass and get it so the saws actually work so I can move the solar panels around. Is this modded? Nope. That's sick. Where does it eject the piss from? Well, Kerbals don't poop, so... Is that all stock? Is there... What kind of toilet did you install? A good one? No, this is all fairings, dudes. It's all fairings. There's no modded parts in this build. Nope. I use fairings to make fuselages for my crafts. Have you flown it yet? Yeah. Yeah, I did the checkouts for it. I did the manual pilot demonstration for it in Kerbal, and I did it just to shake down my capsule. Just check the rates, and I slewed the capsule around in space just like they did on the real mission. I did this like months ago. Yeah, to shake down the capsule to get it to work. Do you have Nutella on board? There are Kerbal snacks on board, of course. Yeah, we'll put this thing to work soon. Hey Radio, what's up, man? On the bright side, you gain a ton of subscriptions in this week. Monetary gains will soon flood in. I'm very happy for this channel. I hope so, Dan. That would be nice. I don't do this for the money, though. I do this because I love space. Could you change the SM to the silver fairings? It might look cool. Nah. Does the toilet work? Kerbals don't poop, dude. So do you have to know math to play Kerbal? It helps, but no. No, you don't have to.
This is Artemis Mission Control. Again, we do not hear calls to the crew at this time as they are in their post-sleep period and getting ready for the day. However, we do anticipate that Orion has departed the lunar sphere of influence. That's when the gravitational pull of the moon is stronger than the gravitational pull of Earth. We're now 5 days, 18 hours, and 52 minutes into the flight of Artemis 2, the first mission of humans aboard the Orion spacecraft.
And it comes all in one package. I have the rear shroud, and then I have the LAS, and the LAS works just like I said, the LAS works just like the real one. That took a little bit of time to get that thing right, but yeah, man, that's how she does. That's how she do. Yeah, Sam, that picture's crazy. This is Kerbal Space Program. Kerbal Space Program is a game where you can design and build your own crafts. You can build your own spacecraft, and then you go and fly them in space. Cool thing about Kerbal is that you need to, it's realistic. It's not like Star Wars. If you want to launch into space, you're going to learn to launch into space. Hey, Alex. Go Artemis 2. Go EJ. Thanks for the continued coverage. Absolutely, dude. Yeah, you have to design and build your own rockets. I have all kinds of cool stuff. Here's my Ares 7 rocket, which is a custom build. Ares 7 is, well, I'll bet you guys can't guess what Ares 7 is supposed to be. Or supposed to be an analog to. If you're a spaceflight fan, you probably recognize what's going on there. Can you drive the crawler out to the pad? You gotta build one. Does it also have Delta Force Fireball? You could do that if you mod it, sure. What other cool stuff do I have in here? Yeah, we gotta go to a different save file. I've been to every planet in Kerbal, yes. Off stream, though. Most of them I've been to on stream. We did it in KSP too, though, so I don't know if that counts, but whatever. Show the shuttle. Is KSP the bug infestation game? No. So what I'm currently working on, the big project that I was doing in KSP is building a shuttle launch pad. Now in Kerbal, you have a launch pad. You just put the vehicle out there and launch it. But I like GSE, and I like all the parts that the machine that launches the machine, so to speak. So my big project in KSP has been building a reusable shuttle launch pad. So I've been trying to figure out ways to assemble a shuttle stack outside of the editors in game. The reason why is because I want to land my shuttle and I want to fly it again. Prototype launch plate here. Yeah, see, there's me. I was prototyping out the stack. you know, the SRBs in the external tank, etc., etc., etc. I've just figured we just got to figure out a way to get the orbiter on there. All these things are cranes and stuff. I was building a gantry crane out of SRB casings because you don't have any launch pad parts in Kerbal. You just have spaceflight stuff. So I take SRBs, I empty them out, and I use them as I-beams, basically. What this crane is going to do here, right? And keep in mind the whole thing is sideways. What this crane is going to do is it's going to lift up the orbiter and then place it on the stack. Guys, how to get the Artemis 2 badge? You got to watch NASA's channel, not mine. Have you tried Juno New Horizons? It's like KSP. Juno doesn't do anything for me. It's a good game.
Go at throttle up.
It's cool. I like it. It just... Yeah, I don't know, man. It just feels like you're playing like Rocket Simulator. It's not Kerbal. Yeah, so that's what I'm working on right now. If you guys want to see the shuttle stack, I'll show you. That's my orbiter. I had to build it from scratch. You have shuttle parts, but you got to put the whole thing together. You got to figure out a way to get it to fly. You got to figure out how to put it together. Hey, Antares, what's up?
Tranquility Base here. The Eagle has landed.
Where do you house a well-balanced horse? A stable.
Thanks, Nathan. The wings and the strakes were some of the hardest parts to make on the orbiter. But my orbiter, and keep in mind, guys, this is stock KSP. This is stock KSP with the 2 DLCs, with making history and breaking ground. I have a robotic arm. It works exactly like the real one, at least in terms of movement. It's the same articulation. I have a payload bay, configurable payload bay. We have our communication system exactly where the shuttles is. All the lights in the payload bay are in the exact same spots. I have the shuttle's fuel cells down underneath the payload bay because that's where they were on the real shuttle. Shuttle used fuel cells on orbit to generate power. It could only stay up there for so long.
Discovery, go at
Random
throttle up.
question. How was the toilet on the shuttle? The toilet was actually right here. As soon as you go into the crew hatch on the shuttle, the toilet is immediately to your right against the aft payload wall on the mid deck. And it worked. The funny thing is that history repeats itself, dude. History repeats itself. They had the same problem on early shuttle missions. The toilet didn't work. Seriously. Same problems. And, yeah, they had to fix it.
We are coming up on 5 days and 19 hours into the flight of Artemis 2. This is a live view from the Orion spacecraft, now making its journey back home to Earth following a lunar flyby yesterday. This mission is built by people and companies in all states and with international partners. And with Artemis 2 flying, it's a testament to everyone's hard work and dedication. Let's learn a little bit about them.
What we're doing here is a collaborative effort of hundreds of thousands of people.
This is about the parts, the hardware, the software, the services, all coming together to make that mission possible.
My dream for this space program is that we would not just push the boundaries, but that we push them together.
And liftoff of Artemis 1. We rise together, back to the moon and beyond.
It takes a team to do great
Charlie.
things. And Artemis has an incredible team.
We have international partners. We have commercial partners and industry partners.
It takes unity to accomplish great things. And that's what this mission's all about.
Hey, baby.
We're not sending our money to the moon and lighting it on fire. We're putting that money right back into the economy in ways that benefit everybody. So every dollar that comes out of the Treasury that goes to support this mission goes back into the Treasury 3 times. What is very important to me is that we do it the right way, and that we do it with our values, that our industries grow, that our communities grow, that our families are healthy and safe and have amazing things to work on. Then we're going to build machines to go even further onto Mars.
That is our generation, the Artemis generation, that defines the starting point of our exploration future.
Which parts?
I just want to say thank you to all of the hands that have touched a part of this program and the hearts that have moved everyone to this goal, because we're going to the moon and we're going beyond.
One team. One team.
One team. One dream.
That's Jenny and Andre. That's the backup crew for Artemis 2.
It does take a team, and we are live here in the Artemis Flight Control Room at Johnson Space Center in Houston, Texas, where the Orbit 1 team continues monitoring the flight of Orion, the first flight of humans on this spacecraft. You've heard us mention a lot about the flight director or the capsule communicator, the person speaking with the crew, but there are a number of positions in this room that are monitoring all of the systems and the daily plans aboard Orion, making this mission happen. That includes INCO, the Integrated Communications Officer, CDH, Command and Data Handling, Prop, the Propulsion Officer, FIDO, the Flight Dynamics Officer, Booster and Control, who monitor the flight of the Space Launch System, IVA, or Intravehicular Activity, ECOM, Emergency, Environmental and Consumables Officer, GNC, the Guidance and Navigation Control Officer, FAO, the Flight Activities Officer, MPO, Mechanical and Power Officer, CDH, Command and Data Handling Officer, GC, Ground Control, Surgeon, BME, the Biomedical Engineer, and Science. We might get to share what's happening during the mission, but these are the team members, along with their backrooms, and everyone who has contributed to the flight of Artemis 2 that are making this mission happen.
Dude, in that B-roll, I saw Andre Douglas, the background, the backup crew for this mission, right? So I went and looked up his resume, and okay, yeah, overachiever is what comes to mind. Guy has he has a bachelor's in mechanical engineering and 4 postgraduate degrees. Master's in mechanical, master's in naval architecture and marine engineering from U of M, a master's degree in electrical and computer engineering from Johns Hopkins, and a doctorate in systems engineering from George Washington. Wow.
Tranquility Base here. The Eagle has landed.
Bro, what a unit.
NASA so busy it needed some space.
Yeah. So Andre Douglas was on the closeout crew. He was up there helping Reed, Jeremy, Christina, and Victor get into the capsule. And Jenny's Capcom 1. Jenny Gibbons is also on the backup crew too. Wow, that is okay. All right, dude. You know, I made my bed today. Like, all right. Dude just sleeps in the campus utility closet. Yeah. Yeah. Imagine his student loan balance. Yes. I hope he was Coast Guard too. So I don't know if that qualifies you for a GI Bill, but also
We are 5 days, 19 hours, and 5 minutes into the flight of Artemis 2, the first flight of humans aboard the Orion spacecraft. And you're looking at a live view from Orion, looking back at us here on Earth, the destination of the crew, headed for a splashdown in approximately 3 days, 6 hours, and 12 minutes. The translunar injection burn that occurred on flight day 2 is what committed the spacecraft to its splashdown. Yes, that sent us around the moon for yesterday's fantastic lunar flyby, but it's also the burn that helped us slingshot around the moon and target that splashdown in the Pacific Ocean. That was a 5-minute and 50 burn using the OMS engine, the Orbital Maneuvering Service engine. It's a great picture of the OMS right there on the left side of your screen.
It's the big nozzle, not the small nozzle, guys, just in case anybody's wondering.
The crew has also exited the lunar sphere of influence, meaning that the pull of the moon's gravity is less intense now as the pull of Earth's.
What are the windows made of? Glass? Glass with acrylics and a bunch of other things, dude, to make them super cool space windows. What's the difference between Orion and Integrity? Orion is the class of vessel, Annika. Integrity is the name of this vessel. So this is Orion Integrity. Like how, think about like if, you know, we want to transfer it over to like battleships, right? There's the 4 Iowa class battleships. Only one of them is named the USS Iowa, right? There's the Missouri, there's the Wisconsin. Why am I forgetting the other one?
The crew aboard Orion are currently in their post-sleep period, having woken up about 10:35 a.m. Central Time.
Thank you. Yeah, I don't know why I blanked on the New Jersey.
This post-sleep period is the time frame that they can get ready for the day, just like you would at home before leaving for work. They are putting up their sleeping bags, doing any hygiene, and eating breakfast. And we will talk to them in about 30 minutes for the daily planning conference.
I don't think so,
Flight Director Jeff Radigan here in Mission Control Houston has been gathering topics from the team about the spacecraft systems or the plans for the day that he will relay up to the crew.
So, yeah, Orion is the class of vessel. Integrity is the name of that Orion. Toilet status, they were dumping a little bit earlier. It must be working. When was the last time the OMS engine flew before Artemis 2? That OMS engine flew 17 shuttle flights over 3 missions. Over 3 orbiters, excuse me. I think it flew on STS-134. I think. I don't remember. It's been used 17 times prior, and now it's going to burn up in another couple of days. How many Orions are there? Hold on. I can get you that info. List of vehicles. So, there's the ground test article, the structural test article. There was just the straight Orion capsule that was used on Artemis 1. I think they're going to use it for ground testing. I know that the EFT-1 Orion is at Kennedy Space Center Visitor Complex. So, serial number 3 is Integrity, and then 4, and then 5. There's Orion 4. Orion number 4, which is Artemis 3. Hasn't been named yet, but there it is. If it looks complicated, well, that's the fun part. That's because it is. It's under construction, not made yet. Now, keep in mind, guys, Orion capsules are reusable. Warning, ordnance installed. Orion capsules are reusable. The capsule part and the pressure vessel can be reused. Artemis, so Integrity, guys, fun fact, Integrity is using a lot of the subsystems that flew on Artemis 1. Basically, the Artemis 1 capsule, they took that thing apart. They parted the entire thing out. The reason why they did it is because they wanted to see how all the components fared, right? And then they took the reused components out of number 2 and put them in number 3. So integrity is, parts of integrity have been out to the moon before. I'm not sure exactly what parts. I could probably go look it up. But yeah, integrity is flying with a lot of reused hardware. Some of it from the shuttle, some of it from a previous Orion mission. Pressure vessel completed at Michoud in August of 2021. Yeah, dude, we need more of these. We should build more. The avionics, that was one of the components, Matt. Yep. That'd be a very interesting dive at some point. Yeah, I want to refactor my Taurus capsule to be more like Orion, dudes. So that's integrity right there. That's the one that's flying right now. That's it in the ONC. That's at Kennedy Space Center. They build the capsules at KSC. All of this is in the operations and checkout building, the Neil A. Armstrong operations and checkout building. They renamed ONC after Neil Armstrong after he passed away. Yeah, gives you a better scale idea. Yeah, Orion's a unit, dude. That is a unit of a capsule. It's big. It's bigger than you think. It is. Yeah, that thing is no joke. I mean, you got to fit 4 people in there for a long duration mission. It's a big capsule. So there's 5. Yeah, that's very, very preliminary. They don't even have. There's not even a lot of the wiring is installed. Yeah, I don't know when this picture was taken. That was in 2023. Whoa. That was in 2023. I'm wondering if we have some more updated pictures. Here, let's mess around with this for a second. Images.nasa.gov. How about Artemis 4 Orion? Let's see what we got. And let's set this to current year. Update the results. Okay, let's set it to not current year. So the service module, that's the ESM. Artemis 3, ESM 3 nozzle install. Four is the landing, Sam. You can always ask Phil. He wouldn't. Yeah, Phil would know. You ain't wrong.
Houston?
Ow. Ow. Thank you, NASA. I really appreciate my ears getting blown out. Very cool, Houston. What just happened? That may have been... You know what that was? You know what that was? I know what that was. If there's a video and you hover your mouse over it, it plays it. So I hovered over one of these videos and it went, Houston? I thought that was the, Here, how about we uncheck videos and then we go from there. I thought that was them hot micing because they've been doing that a bunch of times. So no, that one was me, dudes. It was the podcast. Houston, we have a podcast. That's right. Was the toilet reused? This toilet's not reused. No, there wasn't a toilet on Artemis 1 because there was no people on board. Here, let's just try Orion. No. We don't want videos. Hold on. Get rid of the videos. Get rid of the audio. Just images. That's pictures of crew training right there. That's a pressure vessel welding jig. That was PV4. There's the heat shield. That's drop testing to test water splash in the hydro basin. These are distances from our. They need 1 Orion next year, 2 in 2028. They don't need 2 in 2028. Integrity is going to fly one of those flights, Akimi, I'm pretty sure. How do I know? Is that some official NASA thing? No. How else are you going to do it? Seriously. How else are you going to do that? The crew is already awake, Sanity. They are in post-sleep activities. They're basically getting up and getting ready to go for the day. The daily planning conference should be happening sometime soon. Yeah, they're getting up to the DPC, and then health checks. That's what Pulse Ox is. And then they're going to call the ISS, which is pretty sick. Anyway, I'm just going to snack on something real quick. Give me 1 second. The Artemis 1 capsule got parted out, Anonymous. It got parted out. Most of its components, flight components, are in integrity. So I highly doubt that thing is going to get used again. I mean, maybe. Who knows? Like I said, Jared moving up SLS's flight cadence, dude, really... yeah, that really... Yeah, you're going to have to reuse integrity. As long as we can get enough service modules, yeah, we should be good. Can I check a previous question? Regarding yesterday's eclipse, since it was the first time we saw it, does that mean that in the Apollo missions, the service module was always in sunlight, or was it low altitude enough to... It was low altitude, Orion, and it wasn't enough to get a good eclipse. They got a sunrise, not an eclipse. Anyway, give me 1 second.
You're looking at a live view from the Orion spacecraft at our home, planet Earth, now 233,138 miles away, and continuing to grow closer. The crew inside are getting closer to the end of their post-sleep period, and we expect to hear from them for the daily planning conference. That'll be in about 20 minutes.
Guys, that's Saturn, Mars, and Mercury. There's a moon and 3 planets in this picture. Just coincidence. They just happen to be in the right spot when you sent it to the moon. Pretty crazy, right? Here's one of Earth set. This is when they were right. This picture was taken right before they went out of signal communication on the backside of the moon. You can see a good side profile of the Oriental Basin right there. Venus was there. In that eclipse shot, Venus would be on one. It was out of frame. This is once again when they were moving into signal blackout, right before they went around the far side of the moon. Is it possible to build a base on the moon? That's why we're doing this, Zulu.
This is Artemis Mission Control in Houston, Texas. We are monitoring the flight of the Artemis 2 crew aboard the Orion spacecraft. This live view looking back at all of us on Earth, the destination of the spacecraft and the crew. We are now 233,031 miles away from Earth. Orion reached its farthest distance from Earth yesterday, approximately 252,756 statute miles away from our home planet. That surpassed the previously set record from Apollo 13. Until yesterday, the Apollo 13 crew were the humans who had traveled farthest from Earth. When that record was passed, Jeremy Hansen reported that he and the crew hoped that their new record would soon be broken.
The base is going down there. We're going to build at the lunar South Pole. The reason why they want to build at the lunar South Pole is because there's water down there. It's frozen, and it's in the craters at the South Pole that are in perpetual darkness. Like that. That's what they're looking for. That's why this mission was just a cruise for the Orion to make sure that Orion is working. Because Orion's got some work to do, dudes. What planet is that? So EMS, that was a moon. That's our moon. That's a photograph that was taken from the crew yesterday. I gotta fix this. That's annoying as hell. It was cool when they described the lunar surface as an rock. Yeah. Yeah, right? Guys, I'm snacking. I've been basically up since the crew's been up. I didn't eat breakfast, so this is my breakfast. I got some beef jerky.
The crew is wrapping up their post-sleep period, having woken up at 10:35 a.m. Central Time today. Their wake-up music was Tokyo Drifting by Glass Animals featuring Denzel Curry. Pretty good choice for their drift back to Earth. It's going to be a busy day for the crew. Aboard the Orion spacecraft, as we are looking forward to a ship-to-ship call when Orion and the International Space Station crew members get to speak to each other, both in flight.
Hashtag not sponsored.
While Orion was over 250,000 miles away from Earth, the International Space Station orbits Earth 16 and sees 16 sunrises and sunsets a day, 250 miles above our planet.
400 kilometers.
And if you've been enjoying hearing from the astronauts and seeing photos taken from this mission, you would also love to keep up with the International Space Station as the astronauts do amazing Earth photography there from the cupola, the window to the world looking down on Earth. You can follow the International Space Station on all social media platforms as well as NASA.
Crew to crew, Cardin. Yep.
Discovery, go at throttle up.
Lipzogger. Amaze, amaze, amaze. Why moon so cratery? Question.
Less than 10 minutes now until the daily planning conference for the crew, when the flight control team will call up.
Integrity, we're getting ready for DPC. Would you like the D5 streamed on the 4K encoder for DPC? We would enjoy that.
Integrity, we'd love that.
Daily planning conference is DPC. Micah, so
it worked.
You're saying...
Dan, good morning.
Dragon never communicated with the
Good
ISS.
morning to you.
Dragon was never in lunar orbit. Well, lunar free return. This thing's 200,000 miles away, dude. It's a little bit different, don't you think?
Our first morning messages from the crew aboard Orion. Again, they woke up about 10:35 a.m. Central Time today and are heading into that DPC, the Daily Planning Conference. You heard the crew call down that they were going to set up the D5 on the 4K encoder, meaning we anticipate getting views of the crew inside Orion soon.
Yes, Dio. Absolutely. I wouldn't panic being in the tin can, dude. Orion's pretty spacious. I'd be looking out the windows. Can I show you a link with NASA showing the 4 planets? You could just say go to NASA Eyes. Is that what you want to show me, Mikey? That's pretty cool. When is the ISS Orion conference? It's after the DPC, so it should be coming up here in a half hour, give or take.
Integrity, we are on board with the D5.
Hey, what up, Reed? What up,
views
Vic?
Of the crew. The first coming down on flight day 7. On the left, NASA astronaut Victor Glover, the pilot for Artemis 2, and on the right, NASA astronaut Reed Wiseman, the Artemis 2 commander. If you watched Lunar Flyby yesterday, you can tell that the cabin looks quite different. All the lights are back on. During the Lunar Flyby, the crew turned off all of the lights inside the spacecraft to allow them to better take photos outside of the windows. That helped prevent any reflections from inside the spacecraft bouncing up onto the windows, and if you haven't seen some of those photos already, you should absolutely check them out. You can find them on nasa.gov as well as NASA social media. That's at NASA and at NASA Artemis.
Oh, you hit your head.
It is going to be a little bit of a quieter day for the crew, at least in their afternoon. They will have the space station and Orion ship-to-ship call shortly, and after that they will have an opportunity to talk with the science team, discussing their lunar flyby observations. The science team will be able to ask questions about what the astronauts saw while their memory is still fresh for the event. Of course, we also got calls during the flyby yesterday, as well as they were recording some audio into their portable computing devices, or that tablet that you see right there. Those audio recordings have been downlinked to the science team. They will then review those and gather data from what the crew was able to observe during their flyby period. Later this evening, they will also have the RTC-1 burn, that's Return Trajectory Correction 1. Return trajectory correction burns are similar to outbound trajectory correction burns in the sense that they are small refinements of the spacecraft's flight path. The translunar injection burn is what really put us on the trajectory that we're on today. That occurred on flight day 2 and is what committed the crew to flying around the moon and to their splashdown in the Pacific Ocean on flight day 10.
Do they need to be seated for the correction burn? No. No. We won't even, I mean, you'll see it. It'll start moving stuff around.
Good morning, Houston. We are 202,306 nautical miles away. Earth is pulling us back, and we are happy about that. We're ready for morning DPC.
We're happy about that, too, and ready for DPC. We've got about a dozen quick items for you, the first of which is updated nominal burn plan and nominal RTC last star on board.
Return trajectory correction.
Next, for Victor, a reminder for your exercise, per the execute note at MET.
We'll be looking on the news. Christina's checking right now.
Oh, we're stepping on each other. Victor at MET, 22 hours, 20 minutes. Please stop your exercise in advance of the op-nav attitude maneuver. Over.
Yep.
Okay, Dan, if you could just give us a call and remind us, that would be great.
We will do it. Next, for Christina, for your exercise, we expect to be in a forward-link LOS at that time, so you will have the opportunity to park the arrays for exercise yourself. We have three items for the toilet. Last night, 14 hours of waste tank dumping has freed up 11% of room in the tank. So we would really like to treat tank volume as a consumable for entry today. We'll keep that vent going, but we're asking you not to use the toilet for urine until then. And we understand that you're down to support that with CCU use, but wanted to be certain. Over.
Yep.
We'd be happy to talk more about the Hail Mary option, but if this is the final answer, we can support this on board.
Okay. Roger. Thank you. For FecoCan R&R, we know of one full container. Are there others? Over.
That's a negative for now.
Roger that. Last item for the toilet, no Oxone R&R for today's toilet maintenance. Over.
Okay, I do love the smell of Oxone in the morning, but it sounds good. No R&R today.
Roger that. Next, PCD1 is not showing a micro SD card inserted. If there is a card there, would you please reseat it?
Yep, Stan, we will work on that.
Next, DU2 had today's flight plan pulled up when we updated that plan, so we'd like you to close and reopen the flight plan on DU2. And we see your thumbs up.
Okay, Christina's knocking that out right now.
Sweet. Jeremy, for docking cam install, can you please tell us about how long this takes?
I'd say probably 20 minutes, and it's much faster once you know what you're doing, but the big thing is we store it down here in F3 in the clamshell, and it's not as bad to unstow it. It's a little bit harder to stow it. The cables are a bit unwieldy, but other than that, once you know what you're doing, it's pretty quick.
Stand by. And can you give us an estimate of how long it takes from once the camera is out of the locker to installation complete?
For a first-time install, 20 minutes. For every other, if you're doing it by yourself, 5 minutes.
Thank you. That's very helpful. Jeremy, one more item for you. After this meeting, when you turn on the acoustic monitor, can you please give us a call? We're timing things here on the ground.
We will give you a call.
Thank you. Our last item. Science got your audio files from the first 5 hours of the flyby. We did not find any from the eclipse time frame. Are there any? And if so, where may we find them?
Yeah, right. Help us.
There's definitely going to be some on PCD2. I would look through all the PCDs. Jeremy was the primary commentator there, but we can also look and get back to you.
Roger, we'll check PCD2 first and the others, but if you can give us a clue later, that would be helpful. And that's it from MCC Houston. What you got for us?
Okay, sounds good. And we will just do a quick check on board as well. We have, from your notes in the mission summary, the bobs. We are working our way through bobs, but we are nowhere near completing all the food on board. For instance, I went through an inventory of my food today, and I expect to have 1.5 bobs remaining at the end of the flight, and all my bobs are in bag 16, but we will go and do a pretty good inventory. Overall, I'd say we're probably 40% through the total food allotment right now.
Oh, wow.
Copy, 40%.
I think the big thing we need for the food is when we start realizing we have uneaten food that we are not going to eat for the remainder of the mission, just tell us where you want us to stow that.
We will do that.
Okay, we have two more topics. First is just a quick one for Huntsville, but don't leave us, Houston. For Avatar, lights 15 and 16 are out, all others are on, and I'm going to hand the microphone to my esteemed colleague and fellow naval aviator.
He was going to say something. Esteemed colleague.
Pod copies, Avatar.
Actually, Stan, we want to knock out some questions from the mission summary.
And we're ready for questions from the mission summary.
Yes, for the volume in the contingency urine storage bag, I would estimate 300 to 500 mils. And I will continue to use it. And if you'd like me to report, I can.
Yeah.
Copy volume, and thanks for bearing with us.
For email sync, you can keep as scheduled. Sorry, we talked over each other, Stan. Can you please repeat?
Yeah, Christina, we copy volume in the contingency storage bag, and thank you for bearing with us. Also copy that we can keep the mail sync where it is.
And thank you for your answers. I think we are questions complete.
And nothing further here in the control room, so we'll call DPC complete. Have an excellent day.
I don't know, Flavia.
Actually, Stan, we have one more small and quick thing. We just wanted to take this moment to recognize the two newest members of the Association of Space Explorers, NASA astronaut Christina Cook and Canadian Space Agency astronaut Jeremy Hansen. Reed and I are both members, and we're proud to welcome the two of them to this international body of human space explorers. And also congratulations to Jack Hathaway, who recently joined aboard the International Space Station. Thank you.
Thank you for those words, and welcome to the club.
Oh, Velcro didn't stick. Okay. Yeah. Missed my bump. What a good crew. Jeremy?
And Houston, a question on acoustic monitor.
We're listening.
They have an acoustic monitor in the toilet to measure how loud the toilet is. At least that's where it was the last time they said something.
Given that we have the USB charger on board now, I was just going to plug it in instead of using batteries throughout the day. And I was also going to install it at the bottom of the docking tunnel, right behind the Nat Geo microphone. That's pretty central. So instead of putting it on the DUs, it'll be at the bottom of the docking tunnel, opposite the windows.
Copy, checking.
We are checking, over.
And Jeremy, we are good with plugging the acoustic monitor into the USB charger, and we're good with your install location.
Okay, perfect, thanks. And then at nighttime, if we're doing docking camera tonight, which I suspect we are, then I'll transition it to PCD power.
Thanks, player.
Checking. And Jeremy, we like your plan.
You think NASA will come up with better ways to talk around the delay? Kindar tones are definitely help with that. Dude, my so O-Force, they use the Kindar tones so much, and I'm just so, because I've been watching the entire mission, I'm so trained with just like shutting up that when the Kindar tone pops up on the tip message, Tranquility Base here, the Eagle, I hear that and I stop. Like, because I hear, like, dude, I've gotten into a habit of just shutting up when you hear the tone. Is this real? That's a telemetry-driven simulation, guys. We just had an onboard shot inside of the capsule a second ago. When are you moving out to the moon? Well, we got to make more Orion capsules and more SLSs if I'm going to do that, don't we? Probably do that. Would you send to the moon Samantha Cristoforetti or Luca Parmentano?
This is Artemis Mission Control in Houston, Texas. You just heard the conclusion of the DPC, the Daily Planning Conference, when the ground team here can relay up any status updates or daily planning for the crew aboard Orion. And the crew has an opportunity to ask some questions as well.
Samantha. Samantha has commanded a mission before.
Some of those reports may have sounded very simple or menial, but this is the first flight of humans aboard the Orion spacecraft, and so every single detail, even about normal daily tasks, is very important to this team as they prepare for future Artemis missions to the moon. This crew is truly learning and testing everything aboard the spacecraft to make sure we have good systems and good plans for our future explorers.
How are crew members selected? Crew members are selected by for a mission by the chief of the astronaut office. I can't pick one. I'd probably send Samantha, Flavia. Yeah, I would send Samantha. She has more experience commanding missions.
Coming up in about 15 minutes, we will have the ship-to-ship call when the Orion crew will be able to speak directly with the astronauts and cosmonauts living and working aboard the International Space Station.
Why are they called Kindar tones? I had to look this one up, full disclosure. The Kindar system is named after the manufacturer of the original system, Kindar Electronics. They used two tones, both being pure sine waves that were 250 milliseconds long. The intro tone was generated at 25 hertz and signaled the key press of the push to talk button and unmuted the audio. The outro tone was slightly lower at 2475 hertz and signaled the release of the PTT button and muted the audio. The two tones were generated by special equipment located at Mission Control, and they were decoded by detectors located at various tracking stations. There it is. That's it. Yep. Yeah, no problem, CS. Hey, Wolfman. Oh, you don't like it? Louder! Chat, do me a favor and shut the up. What? It's a beep noise. Ah! Mods, please ban the streamer. I didn't do nothing. It's actually super cool that they have the file there. But yeah, there you go. Kindar tones in a nutshell. You cannot ban the broadcaster. Oh, well.
Okay, Houston, the acoustic monitor is set up and it is recording, and I will take a photo of that for you. I think I'll just take the photo on the iPhone and put it on PCD3 for you, if that's okay, because we're using the D5 right now for the PAO event.
Copy all, Jeremy. We like it.
That's a bug, you think? You see if I can get that thing. Damn you! See my last good idea for Artemis 3. Do you know anything about the NASA Lunar Recycle Challenge? Doozy, I don't. For Artemis 3, they need 2 plastic cups and a long string for communications. You made me see your last just for that. Fala Portuguese? No. No. No, not really. Ah, yes. Butt cam. So that's what they were talking about in the DPC. They're setting up the docking port forward facing camera up there. Reed's setting it up. That's all that stuff up there is the mount for the camera. Oh, Vic, don't yawn. You're gonna... You dick. I wonder if Victor realizes he just made a bunch of people yawn. Patch check. You burp in space? Yeah, sure. Bodily functions don't really change up there, Wolfman, except for your kidneys. Kidneys need gravity to work, so they long-term stay. You know, you probably would want something that keeps you in acceleration. What do we got, Ryan? A Blorgen tweet. What are they up to? Melt, extract, breathe, repeat. From moon dust to fresh air. Huh. At our Space Research Center for Excellence in LA, we developed a reactor left that melts regolith simulant and passes a current through it to release oxygen and other gases.
You're looking at a live view inside the Orion spacecraft of the Artemis 2 astronauts. Closer to the camera is Commander Reed Wiseman.
Now, Power, you can burp in space. I don't know where you heard that. That's not right. You could burp. Dude, all bodily functions pretty much work correctly. The only real big difference is up there is, once again, that's your kidneys. Your kidneys need gravity to work. They need to be under... They need gravity. But that doesn't hurt you in the short term. That's more for long-term duration stuff. Other than that, you in space, what you really got to worry about is bone density and muscle atrophy. Those are the big ones. So you got to work out. You got to have guns like Victor over there, see? I don't know how they let him take guns into the spacecraft, but whatever.
And Integrity Houston, just a reminder for the upcoming ship-to-ship call, it's going to be the OE1 microphone, not the handheld.
Okay, they're not going to use the Sennheiser. They're going to use the ship's radio. So you gotta work out in space. You have to. The other thing that happens is fluids get redistributed in your body. Like more blood goes to your head because your heart doesn't have to work against the force of gravity. So if they kind of look like they got little fatter heads, that's why.
Again, you're looking at a live view inside the Orion spacecraft.
There can be some things on your eyes. You can get macular degeneration in space, if I'm remembering correctly. But yeah, and there's also space adaptation syndrome where you don't find your quote-unquote sea legs there. But you ain't got no legs, Lieutenant Dan. Like, point is, you just got to keep working out in space. But yeah, for the most part, you can burp, you can fart. That's a thing. You can go to the bathroom. Like, you have to do that.
Okay, Sam, thanks for that. We have restarted the stream with audio off, and hopefully you're getting a good image.
We copy the audio, and we see a great image.
What type of workouts do they do? They got a rowing machine up there, deep fried?
Again, the Expedition 74 crew currently living aboard the International Space Station. Roscosmos cosmonaut Sergei Kudzverchkov, NASA astronaut Chris Williams, Roscosmos cosmonaut Sergei Mikhaev, NASA astronaut Jessica Meir, NASA astronaut Jack Hathaway, ESA astronaut Sophie Adeno, and Roscosmos cosmonaut Andrei Fedyayev.
DSN question. Is it one dish to one mission at a time, or they can be bandwidth to track multiple missions? You can get multiple data streams from one mission from one dish at a time. Yeah, they got to be pointed in different directions, Limitless. They're parabolic antennas. They're not phased array. So, yeah, one dish is really... I mean, now, keep in mind, if there's two things that are kind of near each other, then they can talk to two things at once. Because once again, multiple data streams through a frequency. Like if you really want to know, the DSN uses phase modulation with frequency modulation on top of it. It's kind of like a super, super, super powerful version of Wi-Fi. Wi-Fi is pretty much not derived exactly from it, but it's the same idea. So, like I said, they can get multiple data channels through one frequency. Somebody figured out a way to do that with phasing, using phase modulation. And once again, RF is like black magic to me. It is very, very strange. So if something is in the same direction, like if they're looking to point at the Perseverance rover on Mars, they can talk to Perseverance and the Mars Reconnaissance Orbiter that's orbiting around Mars. If if it transits across, you can talk to both. Multiple data streams, right? You can do that, but they have to be. You gotta have to be pointed in the right direction, if that helps. But yeah, for the most part, it's one dish per. So that's actually, like I said, super good question. So. Once again, you can look at DSN now here, and you can see what missions. Like, look, check this out. Goldstone 24 has an uplink to Mars 2020 and the Reconnaissance Orbiter at the same time. See that? Because they're near each other. You got to point these dishes in the right direction. A parabolic antenna requires power modulation to get the right convergence distance. So you're not shotgun blasting a signal, so to speak, out into space. I mean, it's not an exact... You're still going to shotgun blast the signal out into space, but but yeah, that's the idea. See, they're talking to both of them. Oh, hold up. Kindar tone. No, Dio, I'm just an enthusiast. Everything that I know about radios, engineering, or anything is self-taught. Guys, you have the internet. You can find anything out there. I can find anything about anything. And I have a really awesome community of people that actually know this stuff that teach me about it.
This is Artemis Mission Control. We are preparing for the ship-to-ship call from Orion to the International Space Station. This will be an audio-only event broadcast at this time due to bandwidth, but we expect to download the video from each crew later and share that with you. Please follow NASA on social media at NASA and at NASA Artemis, as well as the International Space Station, to make sure you can see all of our crew members talking to each other while in space.
Canadian Double. I worked for Bell in Canada as a wireless tech. Modern cellular technology uses beamforming and frequency modulation, such as TDMA or FDMA, to combine multiple users on the same wave. Think of it like multiple users eating the same piece of pie, but the pie is sectioned into their respective pieces. Yeah, dude. Like, what this thing does
while the crew aboard the Orion spacecraft is coming
ridiculous.
back to
And the DSN
Earth
is ridiculous too. It's
passing
crazy
more than
stuff.
250,000 miles away from our home
like
planet.
It's black magic.
The crew
Like, I don't know
the International
who thought of
Space
this.
Station is about 250 miles above our planet.
No, that static noise, guys, is the link between the ISS and Orion. No, KRTX, you're not even kidding. Can you explain where the external camera is mounted? Yeah. So they have a lot of different cameras on Orion. There's some that are on this rim right here looking down. The 4 cameras... Oh, hold up. This is ISS Mission Control.
Integrity is ready for the event.
I'll tell you, Jack, remind me to answer you.
This is Mission Control Houston. Please call Integrity for a voice check.
The ISS is calling Integrity.
Integrity, this is the International Space Station. How do you hear?
That's awesome.
Hey, International Space Station and Jessica, we have you loud and clear. How about us?
Crew.
We have you loud and clear as well, and we have DME TV up, so we have a view of you right now, and it is making us so excited. We feel like you're here with us, and this is really just making our entire week right now.
Direct link, Buxo. Pretty sure.
We've been following along and have seen the incredible photos and heard some of your observations that you've been reporting.
We have been waiting for this like you can't imagine. Let me go check on our PFD. We are 201,726, now 25 nautical miles from planet Earth, which is just hard to believe. The scales are impossible to believe. And for the run of show this morning, I figured I'll say a quick hi, which I have done. I'll hand the microphone to fellow chump Jeremy. He can say a quick hi, and then we'll let you 3 8-balls just get on with it.
I can read, dude.
Yeah, thanks for giving me like a tiny bit of microphone time before the 8-balls get after it. But it's such a pleasure to be spending a little bit of time with our colleagues in space, and we talk so much up here, or we try to anyway, emphasize how important the work is that we're all doing in this program to do the types of things that get us ready to get back on the surface of the moon, and like the administrator was saying yesterday, onto Mars. And so we just appreciate you, and it's fun to be up in space with you at the same time.
We are so excited to be up here with you, and we had a couple of questions. We are wondering, we know how fortunate all of us are as humans to come up here and look down at the Earth from above. Every astronaut that comes to space remarks on that. and we really wanted to hear what that felt like, how different that felt now from your new perspective around the moon.
That makes sense.
Well, I'll start by saying we do miss the ISS. The views there are awesome, being able to see specific places, being able to see your home specifically. So y'all's views are absolutely incredible, and I miss them every day almost. The thing that changed for me looking back at Earth was that I found myself noticing not only the beauty of the Earth, but how much blackness there was around it, and how it just made it even more special. It truly emphasized how alike we are, how the same thing keeps every single person on planet Earth alive. We evolved on the same planet. We have some shared things about how we love and live that are just universal, and the specialness and preciousness of that really is emphasized when you notice how much else there is around it.
Really amazing to hear. It's been an incredible time getting to be here on station. I know you guys have had a lot of that same experience, and we were super curious. Like what you're carrying forward from your time training for and flying on ISS to the moon.
Well, the Navy pilots were carrying on, so I'm the only one that heard the question. I'll go ahead and respond. Actually, Chris, it was awesome to watch you and Jessica go out on a spacewalk. I was lucky enough to sit console for your suit up, and I was just filled with pride, but it also really reinstilled in me those flight operations principles that we live by in a real-time, high dynamic, and risky environment. So having that kind of impressed in my mind right before this flight was huge. And basically every single thing that we learned on ISS is up here. And then, of course, there's the funny and practical, how to eat, how to do silly things with water, how to flip around. We're bringing that with us, too.
And I just got to add, C-Dub, right before you launched, you said you can't wait to talk to us on the space to ground, and it is happening, brother. I cannot believe it.
Face to face, we said.
Yeah, I can't believe it. I mean, I remember having coffee and sitting with you guys just before I left to fly up here, and it's just so awesome being able to talk to you right now. It's such a special opportunity.
They might be going through space to ground, sir. I thought it was a direct...
And we had another question, because now you're in a little capsule that is your home, and although this is a test flight, and so everything is new, what surprised you in your journey so far? We know that we sit up there.
It's really great to hear your voice up here. I can't tell you how fun this event is for us. I hope you guys are enjoying this as much as we are.
Sophie, I don't know.
I don't mean to give you such a short answer, but I can truly say everything. From the core stage ignition, solids lighting, to getting into a new orbit, even right after 8 minutes of boosting on the core stage, to then the translunar injection, to flying by the moon. This entire journey has been interesting, but also applying some of the lessons from station in a much smaller volume, how we move around and eat. Those things have also been surprising, because the difference between ISS and here is we don't have another module to deconflict, and so everything we do essentially starts with a spatial conflict, and we have to take the time to work it out in every activity. And so we've been just having fun working through that.
Thank you so much, Victor. That was such a good answer. We laughed all here hearing your answer. Thank you so much.
All right, my turn, and I'm excited to talk to you guys. It's been awesome up here. Being rookie it's been such an awesome experience having a great crew. I know you guys have a tight bonded crew as well. Jessica dared me to grow a mustache all during training, and I came through on that. So I'm kind of curious what kind of fun you guys had in your training and on your flight here that's been keeping you guys smiling.
Jack, nice. That's Jack Hathaway with the mustache.
I just had a process escape on my water training up here, and I left the PWD valve open a little bit too long. Now, I will say, I'm not the only one to have done this, but I do have the record so far for the largest process escape on the water training failures.
That's a mess up. That means he screwed up.
We can tell that you guys are definitely experiencing moon joy, and I feel like even we are experiencing moon joy right now. I think this also sounds like a great band name, so we can't wait for you to drop your first album.
I got a question for you, but the quick story I wanted to tell you is you were asking what it's like here compared to International Space Station, and I'm just going to relate a very quick funny story. Heading into our translunar injection burn, we're coming out of 38,000 miles, coming down to a 100-mile perigee to do that burn, and when we were about 5,000 or 6,000 miles up from the Earth, looking at the entire Earth just growing rapidly in the window, Jeremy turns around to us and goes, "I'm not sure, I think we're going to run right into it." And we were all dying laughing. And it was the most fascinating thing to watch, that Earth grow. And we actually ended up TLIing on the upper half of the Earth, and we thought we were going to TLI on the bottom half of the Earth. Like, that is the perspective we had, and then the vehicle reoriented and we went. So it is crazy up here, and it does bend your mind. So question for you guys, I'm looking around the Integrity spacecraft right now. We're rehydrating some sweet and sour chicken. We've got some Kona with cream. We've got some butternut cookies. Butternut squash and spicy green beans. So it's all the same food. We want to know, what are you eating, and we're going to mirror you today.
So I had spicy green beans for lunch, and I've been loving seeing all of the things about you guys having the same food. It's fantastic.
I had a mango salad this morning. I think you have this one. Oh, Nana, I know you love that mango salad just like I do.
Yep, there's a mango salad on the deck right now.
Well, I hope I'm not talking over somebody, but I wanted to say a couple things to my Astro sister, Jessica. One, sorry to steal your next spacewalk day, everybody, but thank you for cheering us along anyway. And Jessica, I always hoped we would be in space again together, but I never thought it would be like this. It's amazing. Congratulations to you on being commander, and I hope you have an amazing rest of your trip in space.
Thank you so much, Christina. I totally share all the same sentiments, and I'm so happy that we are back in space together, even if we are, a few miles apart. We like to joke about that up here, too, because everyone's talking about the records of the distance, and we ran to the far end of the space station when you guys were on the other side so that we could claim we were the furthest away from you in that moment.
All right. Yeah. Fair.
Love all four of you so much.
We were doing the same shenanigans here when we got to the furthest point from the moon. I tried to get to the furthest point from Earth. I tried to get to the furthest point in the spacecraft, and my crewmates were clawing me down. And I know that's a joke. We were busy doing science, but we had that same conversation. It was a lot of fun. I don't know how much longer we have here, but from the four members of the spacecraft Integrity, we really want to just say our deepest appreciation to the 7 members of the International Space Station, and this has been a true treat. It takes the entire world to do amazing things like this, and to get to come together as this group of people and talk for just a minute at these distances. We are all off the planet Earth right now, and we're all going to go home to that planet, and that is a very special thing. So thank you all for tying in.
Thank you, Reed. What beautiful words, and from here.
ISS, UHF comm check.
And Integrity Houston, ISS is doing a teacher's handover. They'll be back with you shortly.
We are loving all four of you from here, from the space station in low Earth orbit. We'll keep the fires burning here.
And we'll keep carrying the fire. Thanks, guys. Over and out.
Thank you, guys. International Space Station, over and out. Made our day to talk to you.
I'm awake. They need those subspace comp. Yep. Yeah, they do. Opcom would be very useful here. Tight beam.
Thank you to all participants. Integrity and station. We're now resuming operational audio communications.
That's
my goodness, Houston, that was amazing for all four of us. All smiles up here. Just thank you so much for enabling that. That was very, very special to this crew.
There's a shot on the ISS up there.
Reed, we were happy to do it. You should have seen all the smiles in the control room, and we had a packed visitors gallery, and everybody was grinning up there too.
Dude, that was so cool. Orion Integrity, it's 200,000 plus miles away. They called the ISS.
Made us all cheer up here as well. That is just such a cool thing for the agency, the nation, and the world. What a neat moment.
And here we are experiencing it.
The LASCOM works. Yeah, how do you think we got these pictures, Wolfman? NASA dropped new pictures in the middle of that conference, guys. Take a look. Whoa. Okay.
This is Artemis Mission Control at a mission elapsed time of 5 days, 20 hours, and 19 minutes into the flight of Artemis 2. You just heard the voices of the Artemis 2 crew and the crew aboard the International Space Station speaking with each other while both are in space. A ship-to-ship call. We are excited to share that video and audio with you later on today. You can find that on NASA social media.
Do you think they can do Tidris handover? No. The ISS doesn't have much time left. Why change it? No, Tidris handovers are fine. They take 2 seconds. You like the SAW eclipse photo more. Yeah, okay. Yeah, that one's pretty good. You don't hate that. That's a freaking real picture. Look at that.
This is Artemis Mission Control, and the audio you just heard of the crew aboard Orion and the crew aboard the International Space Station speaking with each other. Again, we are going to downlink that video, and we will let you know when that is available. You can follow NASA on social media and the International Space Station as well. We can't promise a time frame when we'll have that video down for you to enjoy, but once we do, it will be fantastic. The International Space Station is now flying 267 statute miles just south of Africa. Meanwhile, the Artemis 2 crew is flying 231,793 miles away from Earth.
What? Sorry. And there goes the VOD. Hopefully me humming it badly and off key would, not flag it, but yeah, there's more. Hold on. Let me We can, yeah, we don't need an X-Space flight right now. Images.nasa.gov. Oh! Huh. Huh. Dude, look. Look. This picture is still a little fuzzy, but down here a little ways. Look. See the lines?
Coming up next for the Artemis 2 crew is a conference with the science team.
Cool.
They will be reviewing what they saw yesterday during their lunar flyby, sharing any findings or interesting information with the science team while it's all still fresh for the crew members. Of course, they have quite a lot of audio recordings that have been downlinked to the science team. And that team has been reviewing and will continue to do so to help them understand what the crew saw and formulate new thoughts about our moon.
I love this. I love this. This is fantastic. Oh my goodness. You've got to be kidding me. Look at some of these freaking pictures.
During the crew's post-lunar flyby conference with the science team, you'll hear them speaking with Dr. Kelsey Young. You heard Kelsey's voice quite a lot yesterday as she was communicating with the crew aboard Orion Integrity. She and her team in the science evaluation room were helping determine even what some of the features were that the crew members were seeing but couldn't quite identify.
They're going to be down on Friday, Mile. The baby hair isn't just captured for cameras. No, that's the solar corona, dude. What does the corona mean? So, yes, the sun has a lot of gravitational pull. I don't think anybody can argue that. So the sun is a big fusion power plant. It's fusing helium and hydrogen, right? That's what it's doing. So like any other power plant, like any other thing that makes energy, it has exhaust, right? Like a power plant or like the exhaust coming out of your car. Same idea, right? What this is right here, what these lines are, it's not just sun rays, right? This thing going on right here, see this kind of patchy field? The solar corona is the exhaust of the sun getting caught in the sun's gravitational pull. So the sun is kind of in this cloud of charged particles that's the byproduct of the star, right? Like the byproduct of a power plant. Like power plants have exhaust, right? It gets stuck in the sun's gravitational pull. And that's what these rays are. Those rays are the lines getting stuck. They get stuck in the sun's gravity. Now, every once in a while, there's a strong enough release of charged particles that the charged particles would fly out at escape velocity. That is what solar wind is. So there's a solar flare, and when the solar flares up, right, it creates enough energy to shoot charged particles out, and they break the solar corona. That's called a coronal mass ejection, or CME, or for short. That's what makes solar wind. And you can see it right there, like that. No, it's not that we haven't taken a picture like this, you know, like Hubble could get a picture like this, sure. James Webb could, sure, absolutely. But I don't know who it was. Reed, Jeremy, Christina, or Victor. Somebody took this picture with a DSLR from a capsule out on the far side of the moon.
Houston Integrity, where did you want to do that flyby conference? On OE1 or OE2?
Jeremy, around Earth 1, please. And Kelsey standing by.
So Kelsey's going to talk to the crew here. Is that albedo from a crater? A little bit, yeah. That's the exposure of the photo.
Kelsey, fire away.
All right, hold on. But yeah, that's beautiful, man. Look at our solar system.
Integrity science, I have to start with a giant wow. Our whole lunar science team and the broader science community has been pouring out positive feedback and gratitude, so know that what you did yesterday really made a difference scientifically. Also want to say the science team has confirmed the locations of the proposed Integrity and Carroll craters, and it was such a powerful moment here for everybody listening and following along. And then also, just before I dive into the list of questions, we heard both Christina and Victor yesterday commenting that being able to discuss with each other amongst your crew, taking things from observation to inference to hypotheses, really added scientific value, and so we'd love to build on that here. So we'll ask specific questions for you guys, but please treat it like a discussion, as we heard you yesterday that enhanced value. When you're ready, I'll dive into our questions.
Okay, Kelsey, love all those words. Your plan sounds good. The one thing I wanted to ask you about today during this was I did not record at all where we saw the impact flashes yesterday, so I was thinking maybe I should do that. And if I mean, it's very, very, very rough, so I don't know if that's of any value or not. But if Reed and I can record a rough position in OneNote, do you want to get them off the PCDs, or you just get them when we land? What do you want to do with that?
Can you read my mind? This was exactly the first question on our list. So I'll actually just jump right in, and I think I'll answer your question. So number one question was Reed and Jeremy each reported 3 impact flashes. There were audible yells of excitement in the SIR. And we do not feel we have clarity on when the first 4 of those impact flashes occurred. And so we had follow-ups on, were the flashes brief or were they prolonged? And did you notice any color? And to directly answer Jeremy's question, yes, please do make an annotation on where you think you saw those, because right now the citizen science community is analyzing the data and trying to narrow down where you would have seen those.
Okay, Kelsey, I was just comparing notes with Reed here. We both experienced the same thing. It's a pinprick of light. I would suspect there were a lot more of them. However, you're going to really be staring at the middle of the dark and not looking at the edges of the sun glow around the moon. And it is just a momentary flash, no color, about the size of a star, and it really only lasts milliseconds. Half a second at most.
That's great feedback, Jeremy. Did want to also talk relatedly about any kind of galactic ray flashes you may have experienced. So have any of you guys experienced flashes in your eyes during the mission related to galactic rays, either like while working or sleeping, just to try to speak to the difference between those and what you saw yesterday?
Galactic cosmic waves, that's radiation that's
100% different
coming from other stars
than what we saw yesterday. We see, I definitely see a dozen or two every night when I'm going to sleep. I can talk about those if you want, the galactic flashes, galactic cosmic ray flashes, but the impacts on at least these, what we suspect were impact flashes, were absolutely different, 100% different. And Jeremy said like half a second. I would say they were a millisecond. Like the fastest a camera shutter can open and close, that is what I saw. And I would say they were just white to bluish white, and the size of, Jeremy said size of a star. I really like that analogy from space. It was just a pinprick of light. And maybe it was a priming bias, but to me there was no doubt we were seeing it. And we were all seeing it. So it was, and we were correlating.
Great stuff, Reed. Yeah, don't need the description of the galactic ray flashes. So I guess last question for you guys on that. We definitely want that annotation. Please let us know when you have that, and we'll try to downlink it in flight. But when during the period did you see them? Because I think we heard from you like 20 minutes in that you had already seen a couple. So any timing granularity you can provide would help us find evidence from those from the ground and from LRO.
LRO is the Lunar Reconnaissance Orbiter.
Well, I mean, I think it was just whenever we were intentionally looking for impact flashes, we were looking pretty hard. The eclipse occurred, and then we had about 5 minutes of human emotional reaction to staring at that orb floating in the vastness of space. And then right after that, we were like, oh, somebody in the cabin said, let's look for impact flashes, or I see an impact flash. And then we started looking at it, and as we were looking, we all just saw, one or two or three. Mine were, Jeremy's annotating right now, and then I will annotate on his as well. I never saw any that would have been in the Earth glow side, so I do not suspect any that I saw would be able to be correlated from a Earth-based science team.
Great feedback. So it sounds like when you guys reported multiple impact flashes, it could have been that you guys all saw the same ones occurring. Any guidance on how many total you saw?
We didn't necessarily announce everyone out into the cabin, though. Reed and I saw two identical ones. He saw one before mine, and then I know I saw another one after that. So we'll try and give you the annotation and what order they came in. But just remember, this is just very rough.
That's great. Moving on, a question for Christina and any others that observed something similar. Christina suggested there may have been possible lofted dust just prior to Earthrise. Can you describe what you saw just before the Earth popped out from behind the moon? And any other crew, did you witness anything similar to what Christina is about to describe?
Hey, Kelsey. So this was during, Earthrise. I was still on Eclipse for some reason. Yes, okay. My crewmates were they didn't see it the same as I did. What I saw was when it got close, so as you know, a crescent rose, so it was kind of like two fangs came up, one fang and then later another fang, and then eventually the center of the smile, the crescent. And right before the center of the crescent came up right before the crescent was there was when I thought I saw something.
That's a very evocative description, Christina. Thanks. You noticed it was gray. You kind of highlighted a gray color. Did it? What was the thickness of it above the surface of the moon? And anything else you can describe about what made you think it was lofted dust?
Yeah, and to be clear, this is Earthrise, right?
A-firm Earthrise, because it's that glow from Earth that would allow that lofted dust to become highlighted against space.
Yeah, I was just making sure it wasn't right after Earth set, if that might also be a time, because the picture I'm building in my mind, I just want to make sure I'm not creating false memories. Basically, and I think this is why not everyone saw it as lofted dust, it was not tall. It was it wasn't like the corona where it came up high or anything like that. It was just a slightly different gray color right before it rose. And it was like small enough to be within the fangs of the crescent. It didn't go farther than the inner part of the crescent. And it could have been an optical thing and not lofted dust, but to me it just sort of appeared, and I felt like it had a glow. I know that those different terms mean things, but I think in this case that would be the appropriate thing there, that it was potentially, in my mind, the sunlight reflecting off of the Earth and creating a little glow right before the brightest part of the crescent came over the horizon.
Exactly what we were looking for. Thank you, Christina. Similarly, on dust, we heard that Reed chose for his second crew choice target to look for suspended dust. So, Reed, did you see any glow or hints of that dust earlier that made you come back to that observation?
Negative. Just really wanted to see some, and I saw none.
Understood. Okay, for Christina and Victor, during Earth's set, we heard you say that the Earth was so bright it made the moon look dark. So you all had the Earth in view during the majority of your flyby. Did you notice any time when the brightness of Earth began to change your view of the moon's brightness? And can you describe how your perception of the moon's color changed as the Earth came closer to the moon?
Yeah, absolutely. And essentially, as soon as the Earth became in the view, the easy view, where I didn't have to turn my head, when it was in what I'll call my field of view, not my field of regard, when I could just see it looking straight, the moon was already at a point where I was losing our subtle albedo differences. I think it's the angle of incidence. The angle, the sun to the moon didn't change much, but we moved to the side, so we were seeing a different angle, and the color was less apparent. Orion Tall had also rotated really close to the limb, so a lot of the features that I was looking at were moving away, but I think the change in lighting was due to the angle of incidence, but then when the Earth became apparent, its brightness, it was so bright. It was so bright it looked out of place. The gray of the moon and the black of space kind of seemed to go together, but then more in the dull sense, but then the vividness and brightness, like the difference between an LED display and a painting, right? You can just do things with light that you can't do with paint colors. The Earth looked out of place, and it just continued to dim the albedo and color that was earlier apparent in the moon. I'm passing to Christina.
You saw me nodding vigorously back here. That wasn't just my fantastic listening skills. I was nodding to make sure. Oh, we're not on video. This whole time I've been putting on a show.
Too real. As a streamer, too freaking real, dude.
Now you know. Because I agreed with everything he said. I'll add a couple thoughts that popped into my mind, which was, I think I made the comment that the moon turned into a sponge of light. In my mind, before the Earth came into view, the moon actually was reflecting light, and it was lit up. As soon as the Earth got close enough to be in my field of view to take them both in at the same time, exactly what Victor said, it dulled, it turned into a sponge. It's almost like it went matte, like a matte finish. And for me, so that's brightness and albedo. It also, I would say for me, got like a browner taupe color, like almost an olivey brown, kind of like the boys' pants, not like my pants, but like these pants. And whereas before, I would have said it was more like electric gray in its grayer areas. So for me, it turned more brown, but a very matte brown. I'm going to stop there. There's one more comment I'll make about when it was very close, just in case it's interesting.
Absolutely, we take that observation.
The only other thing I wanted to add to that
is not scientific on lunar observations, but I think that I know myself in particular, but probably we all underestimated the amount of impact of sunlight and earth glow on cabin windows, on glare on the window structure, window frame, on the heat shield tiles coming across the cabin. That was a pretty large impact, Kelsey.
That stuck up to us here on the ground as well, Reed, and we were hearing the struggles that all of those different expected illumination sources provide, but unexpected in the impact that they had. Speaking of things that had an impact on observations, Victor, we heard during your sit rep when you were in the docking window that having that orange capped on tape in your field of view affected your color observations. That was fascinating and has a lot of impact for future Artemis missions and hardware and impacts on color. So any other comment you want to make on how your ability to perceive color on the surface was influenced or limited by other objects of color in your view? We're interested here in color rather than brightness.
Absolutely, but all the comments I made about the Earth earlier apply to this one as well. This is the thing I wanted to make sure to add, so I'm glad you asked, is that the human eye adjusting is another thing that had huge impact. Some of the colors and their patterns did not appear in the moon. The Aristarchus Plateau, you know, the browns, the streaks that we saw there, until you stared. Kind of like the impact flash, you really have to be staring. And it wasn't because of intention, it was because my eyes were adjusting. And so as soon as I would look inside the cabin, the vehicle, if those bright LEDs that were in the vehicle, or if the sun was reflecting off of a corner of the windowsill, or the bright earth in the field of view, those things would change my eyes and I have to wait for them to adjust again. And I want to add, while Victor's talking about that, on the Kapton tape color, let me see if I can nods from my crewmates, but when we're looking at Earth, just a normal Earth lit up by the sun, I'm used to seeing these deep blue pictures of like Earth Day photos, Apollo 8 photos, but when we look out, the cloud cover is so bright, it is almost blindingly bright, and you really cannot make out significant detail in the Earth when we're at long distance on a sunlit Earth. So it was very interesting to me that the Earth is so bright from the clouds that it is actually hard to look at.
Huh.
Hey, since we're going discussion style, like you mentioned, I'll add a couple comments on color. I didn't notice color changing
Sign
my
it and
view,
you'll take a copy.
Maybe, like Victor said, it was I didn't realize it when I looked down at the PCD and back, because I do think there was a time scale there where you saw things a little differently if you just stared for a long time. And sometimes even staring out to the blackness to kind of reset and come back. So I think that is a note. We were very much reliant on PCDs for instruction, but that did cause our eyes to constantly refresh on those colors. I didn't notice necessarily a color difference, but just like a quality of observation, maybe like he was saying, like the details or the contrast. So it might have even been a night vision thing. Yeah, that's all saying that. I did want to mention that when we were getting the really, really high amount of light into the windows, even the shrouded windows from the sun, the reflection on things behind the observer that are in the cabin was really strong on the window. So there's some high albedo things behind our heads, like there's a white bar, the abort sticker on the RHC, some other metal things, like we have some white bungees. I was trying to observe the dark side of the moon during the Earth set, while the Earth was behind it, and I ended up asking Reed to give me some black t-shirts, and we covered all of that stuff so that the reflection was just less in the glass, and it worked so well. It basically made observing for impact flashes possible, whereas it wouldn't have been otherwise. So that's a good tip, and I would even recommend, like maybe as part of your stuff, if you have this in the future, like a black room, a dark room cloth or something to lay behind the observers. Finally, back on the question of moon color change during Earth set, The other thing that that happened, which was kind of, I think, just more in the category of like a mirage or something, even though I recognize there's no atmosphere around the moon that would cause the same things as mirages on Earth. There was definitely an effect, like when the Earth actually set, of like when it first touched the moon, it was like your eyes didn't know what to do at that boundary, and it kind of just created a lot of light in that spot. Once it got below that tangent first touch, then it got more normal, and I was able to just see the Earth and see the moon and see their contact. That's all for me. Anybody else on this question?
Thank you, Christina. And as I think I saw you notice, we did just get video a couple minutes ago, so it's nice to see you as we're talking to you. Next question is for all of you. Ohm crater was observed by all four of you, and we're interested in whether your different viewing angles resulted in how you observed Ohm. Jeremy and Reed saw it first. Were you able to see the ejecta rays, the central peak? And then Christina and Victor, you were next, and you observed Ohm later in the past. Could you resolve similar or different features than what you're about to hear from Jeremy and Reed?
Hey.
The ejecta blanket for Ohm, I mean, it definitely changed as we went around the moon, but it did not change that much. It was always there. It was always fairly apparent. What is more apparent than the ejecta is the brownish gray, darker area that makes the 12 o'clock to 3 o'clock cut of the pie shape. Like that was always very apparent, and the ejecta rays just made that contrast much more apparent. But overall, Ohm did not change drastically as we went around the moon, unlike Oriental, which drastically changed as we went around the moon.
That's Ohm.
And I'll keep going there. And I'm kind of going to read this question, but it was later on in the orbit that I noticed the ray of Ohm, like the primary ray of Ohm that comes out of roughly the 3 o'clock position, was on the mare. And I'm not sure if I was picking that up initially in our first observations, but definitely in the latter. Did you notice that at all? No, the near side mare, yeah. Yeah, Reed says he was noticing that the whole time. That might have been more noticeable to me later on, but that would be the only delta.
Understood, Reed and Jeremy. Curious to hear Victor and Christina's thoughts after hearing you guys.
For the later observation, I was able to see into the crater wall on the east side, and the shadowing there was actually neat, so I could see layers of shadow, so that there's kind of like two faces, or maybe three. I couldn't tell because we were so far away, but I could clearly see light, then dark, then light, and so the layering within the interior crater wall on the eastern side. I was able to see the central area, and I actually thought I saw three distinct groupings of something, and I think that's in the recording, but again, I was so far away, and my eyes were quite tired from adjusting. I was wearing glasses and looking in at the PCD and then looking out of the window out above the glasses, and so my eyes were really getting to work out. And they've definitely been changing. That's the other thing about the eyes, too. My eyes shifted on this. I'm about to turn 50, and that just was very different than 5 years ago. But I did see interior structure, and I commented on the colors, but again, from the angle we were from the surface, everything just looked plain, but the interior floor seemed to be the same color as the surface outside to the west, but the wall seemed to be a different color, which kind of was the same color as the rays and I think the central lift, but I said this in my recording, and it's already becoming fuzzy, but I made some correlations between there, and I talked about looking at the Grand Canyon, where you can see different layers and know that this is the same as that, even though they're not connected. I think the interior, the floor, and the wall maybe had different color or albedo, and I don't remember which one I said in the recording.
So the Grand Canyon reason why it has stripes is because of sedimentary erosion. Basically, the river eroded the layers off.
I'll pile on with your question. We just brought up the LTP because I forgot that while I was doing this, because there was no shadows on this whatsoever, I think it was towards the end when it was just in full light and very little relief, I kept losing Ohm itself. And I actually thought that there was a crater northeast of Ohm that is at the center of those kind of starfish rays. There actually looks like there was a very simple and old crater there, and that is what I kind of actually went back and forth between that one and now what I see is true Ohm, and I wish I would have referred back to my PCD at the time. But I think the lesson learned here is without any relief, it is very difficult to sometimes make out craters, especially here where the rays are actually offset from where the crater itself is. So you're drawn into a spot, and I am so surprised right now that there's not a little crater where those rays meet, because in my mind, there was, and that was Ohm.
Hey, that reminds me of something else we talked about earlier. When reading everywhere in the windows, I remember looking out and I said something to you. I think that it doesn't look like purely rays. I did see the continuous feature of that east-west line, that 3 o'clock ray all the way into the near side Mare. There's some interesting something going on there. But at first, it looked to me like just two different, like a contact of two different materials coming together, or two different age materials coming together. And when we got on the far side, the far side view, where I was looking back at it, I mean the later view, it still looked like, I don't know, it sometimes didn't look like a ray, it just looked like different color material. And really the point of this is not to talk about the 3 o'clock ray and the 12 o'clock ray, it's to talk about the wedge. The wedge looks to me, if you remember my recording comment about continents, I kind of had the near side Mare continent, the middle from Ohm to Oriental, and then the Hertzsprung continent. Those colors in the wedge look like, and not they look the color of, but also the concrete kind of packedness of what's around Hertzsprung. Those look similar. So that's kind of also playing tricks on my eyes between rays and just different material, not just a ray laying on top of the material.
Thanks a lot, Victor and Christina. Wow, we're really looking forward to continuing to dive into this when you guys are back with us on Earth. We want to sign off now to get you guys over to your next activities. Before I do that, I'll just say when you're making those annotations about the impact flashes, any annotations you want to provide about the structures in the corona you saw during the eclipse, we would take those annotations. And that's it for me. It was so wonderful to talk to you over the last 2 days. Thank you again, and can't wait to see you all back here on Earth. Thanks again for what you did for science.
You guys did an extraordinary job of preparing us. We really appreciate you. Can't wait to talk more about this. This was too short. For the sunset recording, if you're looking for that, it's on PCD3, and the file name is recording, open bracket, 13, close bracket.
Copy all, integrity. Science is over and out.
Integrity Houston, we're maneuvering to the lunar obs attitude, and we'll be ready to dial for the PFC as soon as we see you online.
We copy, and can you say window for science pictures? We're a little PCD limited.
Checking.
We got checking, over.
Christina, window 2.
Jeff Radigan always has the best eyes. That's the guy running the show in Mission Control. He's the lead flight director for the Artemis 2
Copy, we
mission.
see it coming into view. You guys look gorgeous.
Yeah, baby.
Why, thank you.
Bro, the SLS tie goes so hard, dude. That's awesome.
This is Artemis Mission Control. You just heard Dr. Kelsey Young, Artemis Science Flight Operations Lead, speaking with the crew aboard the Integrity spacecraft, Orion. Yes.
Talking to Zeb. I'm actually, I'm here.
Yesterday was lunar flyby day for the astronauts aboard Orion. They had about 6 hours to observe the moon, and during that time, they took turns taking photos as well as making annotations and making audio recordings that were sent to the science team last night. Of course, if you got to watch, the astronauts were also calling down information real time of what they were seeing while orbiting the moon.
Sorry for the dumb question. Would it be possible to dock
the conversation
ISS?
You just heard from Dr. Kelsey Young with the crew was their post-lunar flyby conference. As you heard,
Max, no, Orion doesn't have enough fuel to do that, dude. Like, okay, something to really kind of learn about how real space flight, like how, well, I say real space flight, like, you know, like not the movies, right? In the movies, you could just zip up there, right? The spacecraft in the movies have basically infinite fuel. Like the stuff that shoots Star Wars or Star Trek has the dilithium crystals, right? We know about that. So it's hard to change direction in space. That's really difficult to do. Once you're up there and orbiting, it's hard to change direction. So in order for Orion to get to the ISS, all right, the ISS has a tilt relative to the equatorial plane of the Earth. So the ISS orbit is super tilted. The reason why it's tilted, or what's called inclined, right, is because Russia needs to get at it, we need to get at it, the Japanese need to get at it, the Europeans need to get at it. So it's in this weird kind of tilted orbit. Orion is coming back on a less tilted orbit. It's coming back on a less tilted orbit, and it's coming back at a much faster speed. Could you theoretically stop it, right, and dock to the ISS? Yes. You'd have to overcome that orbital tilt, what's called differential inclination. You'd have to overcome that to get to it. And then on top of that, if you can figure out a way to do that, you'd have to overcome the superb speed differential there. When Orion's coming back in, it's going to be going about 25,000 miles an hour, right? The ISS is going 17,000 miles an hour. So there's, it's 17,500. So there's a 7,500 mile difference in speed here on top of that tilt thing. Now, Orion's service module has, let me think. Orion's service module has about 5,000 feet per second of delta V, which means you pretty much can decelerate. You decelerate by 1 mile per second, basically. They already used some fuel. That's not enough. That's not enough to slow down. They just don't have the fuel. If Orion had an upper stage attached to it still, right, and it came back, fired the upper stage, slowed down, right, and then used that same theoretical upper stage to fix the orbital inclination, then maybe. It's not impossible. It just takes a lot of fuel to do it. That's all. The science team's nerding out over here. Yeah, like I said, it's not like the movies, dude. That orbital tilt that I'm talking about, real, it's not impossible. Physics can do it. You just need something like Star Wars to do that. You'd need something like Star Wars or Star Trek. You know what, dude? I'm not going to say that isn't out there. That doesn't exist. I'll just say we haven't unlocked that tech tree yet. Does that make sense, dude? Because I refuse to believe we won't eventually get something like that. Hey, man, look, this is basically a tricorder from Star Trek. That's basically the same thing. So how's it any different, right? We got to unlock that tech tree. Yeah, it makes a lot of sense. You might try it in Kerbal. Max, if you want to mess with that in Kerbal, come back from the Mun, right? Try to get to a space station that's in a different tilt, right? Try to put a space station 51.6 degrees inclined.
You're looking at a live view inside the science evaluation room as the team.
And try to get at it. Flip on infinite fuel if you have to, right? then get to it. See how much, clock how much burn time it takes. How much delta V did you expend? Right? It's not that it's impossible. It's just Orion doesn't really have the fuel to do that. Could we get to the point someday where we could make a craft strong enough to do something like that? Well, I think that SpaceX is going to have to with Starship, especially if they want to refuel and reuse these things. So yeah, someday that's doable. But if SpaceX is going to do that with Starship, they'll launch them all into the same tilt to try and make this a little bit easier. If you have coplanar orbital planes between what you're trying to rendezvous and what you're trying to get back from the moon, oh yeah, that's not that big of a deal. You just got to slow down and make sure you don't slam into the Earth. You got to slow down, right? And yeah, you got to make sure you also miss Earth when you're slowing down. If you slow down too much, Earth will be like, yo, gimme your tots. It'll be like, yo, come here, I need you for a second. You'd be like, no, Mr. Earth, I don't want this. It'd be like, too bad. So if you slow down too much, the Earth will pull you in. If you don't slow down enough, you're going back to the moon. You could aero brake. You can use aerodynamic perturbations to slow down by hitting the atmosphere, but now you need a heat shield, right? So it's always trade-offs here. Always a trade-off, Max. Every time. There's always a trade-off.
Earlier today, Orion exited the sphere of influence from the moon this morning. That means the gravitational pull of the moon is now no longer pulling on the spacecraft, and that they are more pulled by the gravitational pull of the Earth. Again, we're targeting splashdown in about 3 days, 4 hours, and 14 minutes in the Pacific Ocean. Our coverage remains live 24/7, all the way until...
The moon gets small quick when you're leaving it. Wow. Moon and Earth are just about the same size. We saw the Earth for a minute. Now Christina's looking at the moon. Pretty awesome.
We copy. Thanks for the report.
Give me one sec.
As you've heard throughout the flight, the Orion capsule is often referred to as Integrity. This is a name given to the spacecraft by the Artemis 2 crew members and announced last year. The crew reports that the name Integrity embodies the foundation of trust, respect, candor, and humility across the crew and the many engineers, technicians, scientists, planners, and dreamers required for mission success. And that this name is also a nod to the extensive integrated effort from the more than 300,000 spacecraft components to the thousands of people across the world that must come together to venture to the moon and back, inspire the world, and set the course for a long-term presence at the moon.
Yeah, baby. That's what I like to hear. Guys, I want that schedule. They have the extended schedule right there, and I would really appreciate if we had that. That's what that PDF shows, but there's clearly more stuff going on in the internal schedule. But oh, hello, Orion. How are you? Ryan Integrity, right there.
You're now looking at a live view outside the Orion spacecraft.
Genuinely here for education.
Solar array wing positioned.
Well, you're in the right place, dude.
Spacecraft itself.
What's on your mind? We have cameras all around our cars, so...
The command module of Orion, that shiny part, is approximately 330 feet cubic feet habitable volume. So
okay, so you're wondering why the camera quality sucks. Yeah, that's fair. Okay, so Cutthroat, the short answer is bandwidth. In Cutthroat, I'll just ask, do you know how bandwidth works like with an internet connection? There's really a maximum amount of data that can go to and from the capsule, right? There's only a maximum. The capsule's a pretty long way away. Not that that matters. You can kind of up the power, but there is a maximum data transfer rate, right? So every sensor on that capsule, every single one of them, there's thousands of them, are all relaying back to mission control. See all the laptops or all the computers with all that crap on there? That's all the numbers. That's all the systems on Orion. It's all being beamed back and forth, dude. Right? So that takes up a lot of bandwidth. So they don't up the bit rate on the cameras to get us a better picture, because that's taking up most of the bandwidth. This is a test flight. Everything should be instrumented during a test flight so you know how the capsule is going to work. And that just makes it safer. If you have a bunch of people, you have like 50 people watching the capsule at all times and watching each individual system, right? Someone will notice if something goes wrong, right? That's what mission control is for, right? So the cameras aren't going to give us the best live shot. They're not going to give us the best. They do that on purpose. They throttle it. They throttle the bandwidth on the cameras. You want to see what that camera looks like when they do get a good picture with it? How's that? That's pretty good. It's pretty good. If bandwidth is the problem, then why is the interior shot seemingly higher fidelity? Well, they devote more power to it when they do a transmission. They have to reconfigure the craft. They have to reconfigure it for the 4K stream. How's that, huh? That's a pretty good shot. Does that make sense, Cutthroat? Do you think the service module has internal cameras? It's possible. High-res is being recorded, just not sent. That's right, Felaheen. We will get high-res footage when the capsule gets back. You'll get this, but in motion, like in picture, in video format. Thanks, Bob Reed. Yeah. They just got to throttle the bandwidth, dude, because there's a lot of information being downlinked from Orion. And if you, I mean, guys, NASA broadcasts their bit rates if you really want to know. So I'm going to go over here real quick. You can see that Canberra 34 has the uplink to Orion, the uplink and the downlink. They have two downlinks because they're downloading more data because all that telemetry getting downlinked, like I was telling you, right? They are beaming too, but if we go back over here, over on the other side, and you take a look. So look, you can see the delay, 2.5 second delay here. Range is 372,000 kilometers. And if you go down here, you can see their up signal transmit rate, which is 0.2 kilowatts on the S-band frequency. And then the down signal is 2 megabits per second. That's what I mean about bandwidth being at a premium. Now, nowadays, could with modern technology, could that be higher? Yes, absolutely. Give them some time to dial Orion in. It's got to fly more. If it flies more, they'll figure out better ways. The increased biometrics of the crew expanded gave up a bunch too. Yep. So wait, or can they not amplify these signals for maximum bandwidth? That is the limitation of S-band right there. I mean, they could get 6. I think they can get 6 sometimes. But the thing is that so Orion has an optical how much information on this mission do you think is I don't know what that means, Gumbo. Maybe. DSN is also meant for long distance, not bandwidth. Yep. Why does Madrid have 4 grayed out? They're not powered. So these mean the dish is off. This means the dish is on, but not really configured for anything. Like, see, Madrid 53 is testing right now. So it's on. 55 has an uplink to Juno. Juno is around Jupiter. And you can see that, yeah, see, they're 35 kilobytes a second, or kilobits a second. That's not fast. That's not a lot. But But yeah, hopefully that helps, dude. Now, once again, Orion, I actually didn't get into this, but I can say it. Let me just tune the audio back on. Oh, solar panels moving around. Somebody's working out. My first internet was 100 kilobits a second. Yeah, right, Curtex, right? So Orion actually has they can get higher bandwidth, but it's a prototype right now. If you really want to know, let me find it real quick. I have Orion's reference guide here. Actually, you know what? The Opcom paper is probably better. So check this out. Bandwidth nerds. Orion is equipped with a laser communications link, a tight band, if you know Star Trek, right? Tight frequency, tight band, right? It has an Opcom communicator. It's called the O20, Orion Artemis 2 Optical Communications, right? That's the Orion, that's the Artemis 2 mission trajectory. We're over here somewhere. We're like right around where the 12 is. We're in trans-Earth return, but check this out. Look at these data rates. Opcom only works at certain times because of, once again, they only do it when it's power limitation, I believe, on that one right now. Because there's so much developmental flight test instrumentation on this thing that it's taking up most of the bandwidth, or most of the power, excuse me, not bandwidth. So check out the difference here. Do you work at NASA? No, BH, I'm just a fan. This is a fan-run channel with permission, basically, from NASA. That shows 2 downlinks. They have a redundant downlink for more bandwidth. Can't see me. That's what I mean. There's two going down. One of the dishes is transmitting back. It wasn't over 12 hours, King. It was they dump the waste right before the crew wakes up. Yeah, the lines are freezing up again. Oh, that's really cool. Do you have a degree in aerospace? No. I'm self-taught. Everything you guys hear from me is something I taught myself by going and fishing out technical reports off of NASA. And, you know, it turns out some of it is playing Kerbal Space Program too. I'm not going to lie to you. But it turns out if you operate a stream that's about rocket science, you attract rocket scientists. And I've had a lot of really good mentors over the years teach me about all this stuff, to the point, like, I want to learn it so I can teach it to you guys. So there's a lot of people out in the industry that actually help me. Guys that work at SpaceX, NASA, Blue Origin, Firefly. They're like, here, no. Your explanation, you gotta fix this. That wasn't exactly right. Here, say this instead, or figure out a way to say this. And okay. So you pick it up over the years, dude. I've been doing it for 15 years. I've been streaming for 15 years almost. So,
again, we're live here in the here in the Artemis flight control room. 5 days, 21 hours, and 15 minutes into the Artemis 2 mission.
So I learned.
This is the flight day 7.
I learned, baby. You got to, it takes a lot of reading and it takes a lot of time. And you can read it and you can regurgitate it, but I don't try to do that. I firmly believe
this is a little bit of a quieter day now.
I firmly believe if you're going to teach somebody about this stuff, you have to have a good enough fundamental understanding to be able to teach it. If you don't have a good fundamental understanding of it, it'll be harder to teach people. So I really take the time and make sure that I learn this. With that being said, I still make mistakes. I don't know everything. I understand that. And I know my place. Like, I'm no engineer. But I got a lot of people fooled. Though. Am I right or am I right? All right. You don't feel that when you like the subject. Exactly. So yeah, I had this PDF up in case one of my buddies that is obsessed with the DSN, that works in the industry, let's just leave it at that. We won't say who, linked this technical report about the Opcom system and how it works. So guys, the long story short is that this is what we were looking at here, these pictures are over S-band, right? S-band really it will get you somewhere, right? But the laser communications, where they basically a fiber optic cable without the fiber optic, because you don't need the cable in space because there's nothing in between, right? You could just beam light back and forth because it's just space. You could beam it right through space. You don't need, it's a fiber optic connection. That's what Opcom can do. It's just power limited at this time. So like if we sent up in the future, we sent up a spaceship with an Opcom sensor and a nuclear reactor on board. Oh, gee, yeah, you get high-speed internet anywhere in the solar system. Anywhere in the solar system. Think about that for a second. That's pretty cool, right? S-band. It refers to the frequencies that they're using for data transfer and communications right now. Starlinks do have optical communications, Ando. Yeah, if you're wondering why Starlink is so fast, even though it's flying around in space, guys, it uses very high frequency, or VHF. Same thing if you're older like me, you know, the rabbit ears, it uses that frequency, that band of frequencies to communicate up to the Starlink satellites. And then from Starlink satellite to Starlink satellite, they have Opcom. They're beaming light between the satellites, and that's how information travels through the swarm. Dude, it's wild stuff. Like wild stuff. Like Starlink is next level. That is crazy what that thing is.
Communicating with the astronauts today from...
Yeah, high speed with like a 20-minute ping. Hey, yeah, what do you want? Ping is ping. I don't know if there's any ways to get around that.
And that's the single person in the room that communicates with the...
Could you see Starlink on an old TV with rabbit ears? Probably not, Popplestone. I don't think you'd be able to dial it in. But the fun thing is that, okay, if you know older televisions, right? The snow. What you're hearing is background noise from the universe. That's what the snow is on the television. It's just the antennas pick up background noise from the universe. That's the snow is just garbled signals that are radiating off of suns and galaxies and stuff. That's what that is. I thought it was ants. I mean, it might be ants. You know, if you left your television outside for a little while, T-Bear, it could be ants. I mean, if ants are inside the cathode ray tube, it's not going to smell good. Let me put it that way. Remember when TV quality was affected by thunderstorms? Felaheen, when I was really young, I wanted a television in my room. This was like in the early 90s.
And Houston, integrity for opportunistic science imaging note.
More science communication. Hold on.
We're listening.
So I rebuilt a TV that I found at the dump.
Yeah, just wanted to mention that towards the end of that opportunity, I'm not sure if it was after the maneuver started or just before it started, but the sun was out the window that I was observing on, and I went to go look for the moon to take more pictures of it after kind of pulling my vision away to look at the lunar targeting package. And when I put the camera back out, I ended up pointing it directly at the sun for a second. So just a reminder that if something's gonna change to where the sun is now in the view that people are looking out at the camera, just give us a heads up.
We will do that. Thanks for that information. On another topic, your new state vector is on board.
Awesome, thanks, and I'll be ready for my PFC in a couple minutes. Do I need to tell you all which PCD I'll be on?
And Christina, no, we don't need to know which PCD you're on. We'll just dial your account.
Copy, I'll be signing in shortly. Appreciate it.
So, yeah, Felaheen, I do remember because I was trying to figure out how to get that damn thing to work. Once I got it working, I was trying to figure out how to make the antenna work. I ended up wrapping a bunch of tinfoil around a hockey stick and then yeah, wiring that out my window, and I taped a hockey stick to the side of my window. It worked. Yeah, and then I had a little crappy short...
As you heard, that communication's coming from Orion.
I had a little crappy CB radio, dude. Like the one that they give to kids, like a little walkie-talkie, and I took that apart and I wired that to the hockey stick. Yeah. That worked. It worked. I mean, it was not the best antenna, but it was good enough. Yeah, hockey stick rabbit ear. Yep. Yeah, I had to take it down before my parents found out. I think it may have taken some paint off the side of the house when I duct taped it to it. But hey, whatever, it worked. Radios and stuff.
PFC, that stands for Private Family Conference. All of the crew members are getting some time to talk with their families today.
Why didn't you do a degree? I have a degree in computer animation and CAD systems, guys. I can make levels for video games, or I can make AutoCAD, like I can make models for like a CNC machine to machine. That was expensive because I went to a for-profit school. Nothing against the education. The education's great, but yeah, the reason why I really don't go back is because student loans do be like that. But it's okay, man. It's okay. I love my job. This job rules. Don't worry about it. We're good. You still model stuff? Yeah. What are the displays next to those displays? So, Olivia, that's the radio. These are all telemetry. This is all the downlink.
Coming up in about 30 minutes.
This is all the downlink from Orion. That's all that bandwidth that I was talking about a second ago. Those are the radio loops right there.
The latest status on Artemis 2.
All right.
Again, that's coming up at 4:30 p.m. Eastern, 3:30 Central. That'll be broadcast on this stream on NASA's YouTube, but we will still have our clean feed on the separate YouTube stream. Once that status briefing is over, you can come right back to this feed, or just stay right here, and we will continue coverage from inside Mission Control Houston.
Do you think they're doing any classified work that won't be shared? Nah, not really with this. There's probably something, one man, but if we knew about it, we'd probably be in jail. So what's special about this mission to the moon? What is their goal? Yeah, Rigo, I've been getting asked that question a lot. The big one is a shakedown for the Orion capsule, dude. That's the biggest one. Have we been to the moon? Yeah, absolutely. We went there 9 times with the Saturn V, landed for 6 of them. The only ones that didn't land are 8, 10, and 13, right? We've been there before. But we haven't been there with that. And unless we want to go about building a 50-year-old spacecraft, no, we don't want to do that. We got to shake this damn thing down. We got to make sure Orion works with people on board. If you build a moon base, right? You don't want to build a moon base and then not have a way to get to it, right? We kind of did that with our ISS, and that didn't really work too well, right? And we stopped flying the shuttle, and then we had to fly Soyuz, right?
Go for secondary purge line dumps.
Oh, secondary purge lines. That's the CO2 dump. It's the second dumping system.
We are go for those dumps.
Can you remind me again, Stan, when we have to stand down from them today?
Checking.
Give me 1 second.
And Reed, we'd like you to stand down from CCU dumps between MET 3 hours and MET 5 hours 30 minutes, except for the scheduled dump on Victor's timeline at 3:10.
That's later in the day. That's way later in the day. That's towards the end of the day today.
Okay, we copy, Stan. I'm in the process of setting up the recorded exercise. I would appreciate a call up with a 2-minute warning to stand down from exercise.
It's on our to-do list, Victor. Don't worry.
It so happens the documentation that NASA has is highly insufficient to reproduce the Saturn V. Yeah, that's a big thing, guys. A lot of people are like, why don't we just build another Saturn V? Dude, the thing about that is we have the blueprints to the Saturn V. NASA has those, sure. But the blueprints are only going to get you so far. The reason why is the Saturn V was machined by hand. We weren't using a CNC machine to make that. CNC machines didn't exist. You wanted to make a part for the rocket engine. That was a dude manually moving a lathe or a mill. And to be quite honest, I can't believe the Saturn V was that reliable when everything quite actually was machined by hand. That's ridiculous that that thing didn't blow up. Like, dude, it's a testament to the skill it took to make that thing.
Live here in Artemis Mission Control at Johnson Space Center in Houston.
Like I said, like say you're machining a part, right? You know, how much depth, how many thousandths of an inch a cut are you going to need per mil? Like it was all done by hand. None of that was written down, right? So it's not that we couldn't make another one. It's that if we did, there would need to be a vast amount of prototyping done to figure out what those machinists were doing with those machines and then replicate it in a CNC machine. Once again, I've always argued that that's not like an insurmountable thing. We could absolutely do that. I think people just like people cope and seethe. We could make another Saturn V. Of course, we could probably make it better, right? But that's the argument in the first place. Why remake the Saturn V? Make something better, right? Like make something better. Like our manufacturing methods, like we don't make cars the same way that we did 50 years ago, right? How do I know? I can personally attest to that. That's not a modern automobile. That's my shop. That is not how a real car works. I have firsthand experience here. Why should we make spacecraft the same way? You know? We're looking at a shift change here. Jeff Radigan's gonna be out for the day. We got a new flight director in his position. We're going to get more
pictures. Stan, enjoy that and savor that moment. Please savor that moment. What an exceptional time.
So they're talking.
Will do, sir.
They're talking to that dude right there.
Those communications coming from Capcom and NASA astronaut Stan Love to the crew aboard Orion. The Orbit 1 team is monitoring the consoles here at Mission Control Houston, led currently by NASA Flight Director Jeff Radigan. The team's going to take a brief team photo. This is the team that has served this shift for the entire mission and has been training together for a significant amount of time now. All of these flight controllers are the ones keeping the systems and the crew safe aboard the Orion spacecraft for the Artemis 2 mission. Additionally, we have the Orbit 2 and 3 team with the same tasks, and they'll be taking their own photos.
Stan Love flew on STS-122. He flew on a shuttle mission. That dude that they were just talking to. That's cool. I didn't know that. Always remember the North Pole is much more near and much more nice. Yeah, right? Yeah. Right? Wouldn't the Saturn V be kind of inefficient by today's standards? So, Doggo, that's actually another interesting question, right? You know, is it less efficient? Blah, 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 blah. Well, you could make that argument, but compared to what? The other rockets that we have to go to the moon? I suppose you could compare it to SLS nowadays. In which case, I'd argue that the Saturn V can land something on the moon in one shot, and the SLS cannot. That's why I've always said, you should just don't remake the whole Saturn V. Just remake the upper stage and put it on top of the SLS core stage and call it a day, and then build a lander. Be done with it, you know? Just take the best parts of the Saturn V and the best parts of the already operational super heavy launch vehicle that we have and just combine them into the two. Now, once again, if people are watching and they say, like, okay, if you're watching you work out in the industry, you probably look at that statement and go, dude, I know it would be involved in doing that. You don't kit bash rockets. That's not how that works. I understand that. I mean, you can have some commonality, like with common avionics, etc., but you know, it's not as simple as just, hey, let's put this on that. Even the adapters have to go through months of load analysis and then testing and then structural testing on top of that. And then structural testing needs to corroborate your load analysis. And then you have to go to a flight test article and then a qualification article, then a flight test article. Like, I know it's not easy if you want to do it right. Right. But that's the other thing about the Apollo program with the Saturn V. The reason why a lot of this stuff wasn't written down is because the Saturn V needed to be made quick. We choose to go to the moon in this decade and do the other things. They had to go fast, so they didn't write a lot of stuff down. They kit bashed the Saturn 1B. All right, I'll give you that one. I'll give you that one. Sure, absolutely. And then they stopped using it. Did my first ever lathe work the other day, and I'm really happy over the part you got the tolerance within plus or minus 5 thou. Very good. For a first try, that's really great. The key is, Sea Kraken, to do it in one shot. Like, or not one shot. Like, if you make a pass, right, you want to move back and then make another pass. Don't, like, go backwards through the path. Like, don't, see what I mean? Like, it has to be like, zzz, zzz. Like, especially when you're using the hand. Like, the CNC machine can get away with it, but using your hand, you got to have that steady hand to make sure that's, zzz, you know? Have you seen the movie Numbers? No. We finally got the 8K 120 FPS launch footage from the Cessna. Oh, all right. Yeah, we should watch that. So the NASA press conference is coming up in 20 minutes, guys, but here. You're going to want to see this. Headphone users. Yeah, you manage your backlash and remember that everything's a spring. Bingo. Yeah, man. We should buy a lathe. We should buy a lathe. I gotta get one for the shop. Now I want one of those. But hey, I mean, you guys have been pretty good to me. That might be a reasonable possibility in the future. You know what I mean? All right. Anyway, headphone users, you got 15 seconds. I know you have Aqualex, yeah. Playing the footage in 5, 4, 3, 2. This is footage from a Cessna chase plane. Well, not a chase plane, but watch. This is going to get spicy in a second here. Okay, it doesn't look like there's any sound here. Core stage engine start and ignition. Oh my goodness. Oh, that's sweet. Holy crap, look at that. Look at how crisp that is. Go! Thank you for the tier 1 sub. I appreciate you. Welcome to Mission Control. Your go with throttle. Coco, give me a second, please. Did you see the shock waves propagating through the steam? How many things are so loud you can see the sound moving? That's how loud rockets are. Bro, this footage is sick. See that? That's the big orange. We need more big orange. We need more. We need more Orion. We need more big orange. Dude, this footage is insane. Somebody shot this from a Cessna? Bro, yo, we need to find this person and shake their hand. That is a disgustingly good track for an airplane. From like holding a camera in your hand on an airplane.
This is Artemis Mission Control continuing to monitor the flight of Orion.
Huh. Right, Shaw? I want more, dude. Look at it. Look at how good it is.
We are now 5 days, 21 hours, and 36 minutes into the Artemis 2 mission, the first flight of humans aboard Orion.
Dude, you have no idea how much skill it takes to keep the rocket in track like this. That's bananas. Yeah, right, bro Handy? Me too. Holy buckets, that's sick. Oh my good. I am trying really hard.
The Orbit 1 team is currently on console
Not
here
to
in
swear
Artemis
right
Mission
now.
Control and just took a group photo. We are on flight day 7 of this 10-day mission with Orion targeted to splash down about 3 days, 3 hours, and 40 minutes from now.
Nice, Starwalker. That's what I'm talking about. Link, please. Yo, I got you. I just want to watch this.
This room is full of team members who make this mission possible. That includes Prop, the propulsion officer, CDH, command and data handling, INCO, our integrated communications officer, MPO, the mechanical and power officer, and so many more.
Houston Integrity, are you ready for AGA readings?
Yes, Jeremy, we're ready to take those AGA readings.
And Houston, there's no rush if you're still taking the photo. Just going to give you AGA readings.
Bro, this guy still has it in the track. Nah, Bonji, I don't care about them.
Jeremy, go ahead with those AGA readings.
I don't let them take up my headspace, dude. Look at that. This is a goated shot. Yeah, indeed. Too hot. Yeah, you ain't kidding, man. No, he's just
27.8 for
sitting out the
O2,
window.
and CO2 is 1.5.
I bet you they have the windows open on the Cessna. It probably has the camera sticking out the window.
Copy numbers. Do you have temperature and pressure?
I don't know if this is done by hand. It just says Cessna, Ando. Okay, this should be getting into a thrust tail off. Keep in mind, this footage is high speed, too.
10.4 for pressure and 77.3 for temperature.
Copy all. Thank you, sir.
Okay, we got a good tail off on the SRBs. See how the flames propagating off the side? They're tailing off. Should get a separation here in a moment. There's SRB SEP. Bruh. It's a sensor on the nose, not hand tracked. Okay, Scoot. I was gonna say, if somebody hand tracked this, holy balls, that's impressive. But no, okay, cool. It's a modified Cessna. Good to know, man. Thank you. It's a Cessna Caravan. Ooh.
And you just heard Canadian Space Agency astronaut Jeremy Hansen calling down some AGA readings. The AGA is the Anomaly Gas Analyzer, and this is powered on before exercise. It takes about 5 minutes before they can give readings, and they want those readings once they start exercise and afterward. This is the first flight of humans aboard the spacecraft, and therefore the first flight of our ECLIS system, the Environmental Control and Life Support System.
There's the
so
three
these
panels,
readings help
and
the
there's the
team on the
last.
ground understand what gases are in the cabin, as well as temperature. You just heard it's about 77 degrees Fahrenheit aboard Orion.
That's the trisector fairing that's around Orion's solar panels, and that's the launch abort system. You can clearly pick out its shape. You've got to be kidding me, dude. That is insane. All right, here, I'll link it up, guys. I'll link it up. You guys can check it out. Holy crap. Let me back it up, dudes. I want to see what the AGA readings were.
They can give a reading.
27.8 for O2, and CO2 is 1.5.
A little high.
Copy numbers. Do you have temperature and pressure?
That O2 level is the highest I've heard.
10.4 for pressure and 77.3 for temperature.
Ooh, a little toasty in the capsule. A little toasty.
Copy all. Thank you, sir.
They're a little bit above 25 Celsius. A little toasty. O2 level's a little bit high. But like it, yeah, that's probably induced, if I had to guess. Anyway, I'm going to go back up to live. So that was what Jeremy Hansen just did is he had a gas analyzer. That's what the AGA is. It's something gas analyzer. Really awesome gas analyzer, maybe. And they're sniffing around the cabin to check the atmospheric composition to verify that the life support systems are working correctly. Probably important, right? Link for that video? I just linked it, Narv. I just linked it a second ago. Yeah, they're using yellow tablet, Ando, exactly. I'll link it again. Atmospheric gas analyzer. I mean, I like the awesome gas analyzer, but yeah, yours makes more sense. Yeah, What the heck? You don't use the decimal system. What? Who said anything about the decimal? I'm confused. Greetings from the GDR moon base. Hi. I hope Orion will one day be on a display in one of the space museums. PCS, there is an Orion on display at Kennedy Space Center Visitor Complex. It's the Orion from the EFT-1 mission. Yeah, Garfagon, maybe. Pop, you just looked it up, and they would have needed an additional 5 kilometers a second delta V to land and relaunch from the moon, which would be an extra 65 tons of fuel. Yeah, you need a lander. I mean, 65 is a little bit on the higher side of your calculation. 5 kilometers a second is... You got to circularize around the moon and then deploy the lander. I don't think you need 5 kilometers a second to do that. It's close, but I'm not... What type of fuel were you using in your calculations? Were you using kerosene? Because that sounds like Keralox. 65 tons is a lot. With hydrogen, you don't... Or even hypergulls, you don't need nearly as much. When is the splashdown? Friday morning. And do you like your chair? Secret Lab Titan? Yes, I do like this chair a lot. Venom. It's really good. I have back problems. I have herniated discs in my back. So, yeah, this chair is super comfortable. Now, Yulo. Now. I can't believe that tomorrow's already a week since the launch. Yeah, I know. I need another coffee. There's a 300 megapixel camera on that Cessna. Dual cameras and thermal imagery. Not just getting banger shots, but it actually provides launch data. What's the tail number on that thing? November 97826. Oh. Oh. Oh, that's got some, so this is off jetphotos.net here. Take a look real fast. That's got some stuff. Yeah, okay. That's got some stuff. That's got some stuff attached to the back. It was not a point and shoot.
Integrity Houston for conference and targeting.
Yeah, that's got some stuff on the back. Yeah, I am not impressed anymore. Yeah, I know, right? Ordinary Cessna. Dude, they just said Cessna. I was like, I don't know. You say Cessna, a 172 pops in my mind.
Hey, Jeremy, our GNC maneuvers are conflicting with our preliminary targeting activity. So we may have to do prelim a little later, or we may skip it entirely and pick up at intermediate. We'll keep you posted on how it's going.
Okay, copy that. And then when, just cue me up on when the latest trajectory information is on board for targeting. Do we have the latest burn plan on board?
Jeremy, we do not have the latest on board yet. That's one of the things that we're trying to catch up with. So the burn conference scheduled before preliminary targeting is definitely canceled. Again, we'll call you when we have updates.
Okay, understood, Sam. No problem. We're pretty flexible.
And Jeremy, we're expecting approximately 30 minutes to get the new burn plan on board.
They'll repress tomorrow, I believe, Miller. Hold on, let me bring up the schedule.
Okay, understood, Sam.
Yep. Flight day 8, repress.
This is Artemis Mission Control at Johnson Space Center in Houston, Texas. The voice you hear on the ground is Capcom and NASA astronaut Stan Love speaking with the crew aboard Orion, specifically Canadian Space Agency astronaut Jeremy Hansen. We are targeting the RTC-1 burn today. That's Return Trajectory Correction 1.
They woke up a little while ago.
That is targeted for about 7:03 p.m. Central Time. This is a small burn using the reaction control system thrusters on the service module of the Orion spacecraft. This helps us fine-tune our path back home. Stan Love was letting the crew know that we are canceling their first preliminary burn targeting conference. They have another one of these in a couple of hours when they will have the final burn plans uplinked and the final targeting complete.
Is Capcom always an astronaut these days? No, not all the time, Ando. I wonder if they'll stream the Rad Shelter demo tomorrow. That'd be cool. Yeah, videos are coming later, dudes. We didn't get the best video from Artemis 1, but yeah. You think we'll see video of them going up? I mean, like that? Onboards inside? Dude, they've already shown some. Hold on. We've already seen ascent footage from the interior. I just got to find it.
It's now been 5 days, 21 hours, and 51 minutes since Orion launched atop the Space Launch System in Kennedy Space Center in Florida. The crew aboard Orion is getting into the first few hours of their day. They woke up approximately 10:35 a.m. Central Time today to the song Tokyo Driftin' by Glass Animals and Denzel Curry.
Here.
There are a few more open blocks of time on the crew's schedule today, as they had an extremely busy day yesterday with lunar flyby. Right now, pilot Victor Glover is exercising.
I don't blame you, Venom.
And Christina Cook is enjoying her private family conference. You heard her call down just prior to that she was ready for her PFC, and that's what that stands for. All of the crew members are getting a chance to talk to their families today.
How do they control where the flames go? There's a flame, it's called a flame trench and a deflector duct. Yeah, there's basically they give it, it's like a chimney. Think a chimney, but on its side. And it shoots out the side. See it? That's how they change it. Yeah, that's pretty.
Thanks for joining us for our live coverage of the Artemis 2 mission. We are expecting to have a news conference today with mission leadership here at Johnson Space Center in Houston, Texas.
So see the trench down there?
We are expecting that news conference to start around 3:45, and I assume you're watching this on NASA's YouTube stream.
So that's the sound suppressors
if
there.
You're interested in watching the press conference, you don't need to change the channel or change your stream. We will be airing that right here.
Yeet! Look at how much things.
We also have a secondary stream with raw audio and video, and you can find that also on NASA's YouTube.
That's nuts, dude. So, you know, who asked that question? Like, you're like, oh, I thought the flames would kind of go out in a circular pattern.
Here's a video from the outside of Orion, and as we mentioned...
Okay, yeah, that's great. Outside of Orion. Good. Great. Grand. Wonderful. So check this out. When the rocket gets out of the flame duct, right, when it starts lifting off, right? See, they have water systems that they spray down the deck of the pad with. That's to protect it. That's to keep the pad from melting, right? Because it gets really, really hot. Now look what happens to the flames when it gets high enough and the plume starts propagating through that water, right? Watch, you'll get a huge steam cloud coming out the side, and you get a more circular plume like what you were expecting. But no, it goes out the duct. It goes out the flame duct on purpose. You got to put it somewhere. All that gas has to go somewhere, so they kind of vector it away from the vehicle. Water dampens sound as well. Yes, that's correct. These will also they'll protect the pad, and they prevent sound from reverbing off of the deck of the mobile launcher, because the sound can reverb off the launcher and shake the vehicle to pieces. Yeah, that's why they spray down pads with water. See, they sprayed a bunch into the duct there. That's for sound suppression. And these ones protect the pad and is an additional suppressor too. Water systems that are usually down into the trench in the duct is usually called the deluge system. On top, it's called a sound suppressor. Boom! You see the pressure spike when the overpressure event, when the SRBs went off? Just a big flame gets shot out the side. That's freaking rad, dude. On Friday, how many hours been between expected splashdown and flame trench, or are you taking that trench off? I have no idea what we're doing. There are no tentative plans at this time. It's potable water, Hammer Nails, not desalinated. It's just potable water. It's not distilled. Drummer, what else do you got? Actually, the press conference is starting soon, so let me just... Press conference should be going live here in a moment. Thank you for the bits, Crafty. Could the water actually be hitting the top of ML1 this time have stopped the sound wave? No. Yeah, maybe a little bit. Any idea how much fuel they burn on launch? So, Rig, that's a good question. The solid rocket boosters each weigh about 1,250 tons.
If you're just tuning in and you are looking for the news conference that was originally slated for 3:30 p.m. Central Time, we are now expecting that to begin 3:45 p.m. Central Time. That will be live here on this YouTube stream.
So most of that 1,250 tons, right, is rocket fuel because they're solid rockets. Not a lot of it is the booster. Maybe I don't know, maybe 20 to 30 tons of that is fuel, is booster. The rest is all fuel. So we're looking at 1,200 tons of fuel, right? Getting shot out of that booster in 2 minutes and 30 seconds. That's a lot of fuel, all right? Like, okay, some reference here. Let me check something. So, let's do some quick math, all right? An M1 Abrams tank. Abrams tank. Nice tank. The M1A2 SEP V3, 73 short tons, 66.8 tons long tons, right? So 66.8. So we do, let's open up the calculator. 1,200, give or take, right? Divided by 66.8. That's 18 Abrams tanks worth of propellant getting expended in 120 seconds. Any unit but the metric system, dudes. Come on, it's an American launch. It's got to be in weird units. Obviously. Pretty cool, huh? It's a lot of mass, dude. And the core stage is even more. The core stage with all the hydrogen is, well, actually, it's not even more. It's pushing... Give me 1 second. The core stage with a full tank of gas is approaching 300 tons. So 300,000 kilos, if I'm remembering correctly. Yeah, actually, no, it's got to be more than that. That doesn't make sense. I think that's the dry mass. I think it's... Yeah, no, it's got to be about there. I'd have to go look. The core stage is heavy, too. Like, a lot, that's a lot of, point is that's a lot of mass getting expended in a very short period of time. But that's the amount of power that you need to get up into space. You got to accelerate something to 17,500 miles an hour to get, just to get into orbit. To get to the moon, where these guys went, beyond 25,000 miles an hour. Watch, you'll see how much power that SLS rocket had to shoot them all the way up there, because, you know, what do they always say? What goes up must come down, right? They're still beholden to gravity here, right? Even though they're in orbit, right? They went all the way out to the moon. Now they're falling back to Earth. When they fall back to Earth, it'll be at a similar speed that was required to accelerate out to the moon. So entry interface is going to be around 25,000 miles an hour. 25,000 miles an hour makes a bullet look slow. Bullet? That's not fast. No, hell no. That's not even close to being fast. You can't even see a bullet when it's fired out of a gun without a special camera, right? You can't even see it. Now, the Orion capsule's 25 tons. It's 25 tons, and it's going like 5 times as fast as a rifle cartridge. We'll take 308 because I like 308, right? How many G's? During reentry, it's going to get a little rough. Past 5. It'll be past 5. It's going to get probably 4.5 G's sustained. Entry takes... And keep in mind, it goes up, it goes down. It depends on what phase of descent the capsule is in and how steep of a reentry they want. You'll feel it. You'll feel it. Yeah, the rockets are ridiculous. That's why I like rockets so much, because they go fast. They make bullets look slow. They make airplanes look slow. Like even the fastest airplanes around, the X-15, SR-71. Bro, that's a snail compared to rockets. That's a snail. What's Dragon reentry G-forces? It's about the same, maybe a little bit less. And like I said, you're gonna feel it. Anybody ever been to Disney World? You've been to Epcot at Disney World to ride the Mission Space ride? You ride the, the orange Mission Space? That's 3.5 G's sustained. That is, yeah, you're in the ballpark there. That's kind of what it's like. I mean, dude, I felt it after that ride. Yeah. The orange. Yeah, you felt it. I got out of there and I was like,
specifically
what
the Artemis
the
Flight
heck?
Control Room here at Johnson Space Center in Houston, Texas. This is a live view.
How close are they to inventing another less explosive and expensive way to get to space? Orange, that's going to be a little ways off. There's not many things that can give out that amount of power in that amount of time. You got to remember, do we have things that are more efficient? Yeah, sure. But a rocket needs to fart out 17,500 miles worth of change in velocity, right? And you need to do it in less than probably 8 to 9 minutes. Because if you could accelerate something to 17,500 miles an hour, but it took 20 minutes instead, Earth would pull you back. Earth will pull you back in. It's about, you have to go fast, and you have to also be able to get an insane amount of power out all at the same time. So there's not many things out there that can do that. Rocket fuel is pretty good. Good old combustion won't fail us. Dude, to be honest with you, it's really about, at this point, it's really about finding cheaper ways to make rockets. That's the real thing. You got to find less expensive ways to do it. My argument, this is my personal argument. My personal argument's always been is if you make more, the price is going to come down. But the flip side to that argument is that where's the market to make more? Where's the market to make more? And that's where I think NASA comes in. NASA should make more rockets. Right? SpaceX is doing their own thing with Falcon 9. I love Falcon 9. That rocket rules. But that is a commercial application for Starlinks. It's not really the best thing to use to go and explore space, right? I can't believe I just said that about Falcon 9, but this mission really drives home what's important. Falcon 9's great. Falcon 9 can't lift an Orion capsule. It doesn't have the payload capacity. Now, you could use the surface propulsion system as a third stage on a Falcon 9, but then you'd be running into load problems on the second stage. Falcon 9 was never designed to move something that's 36 tons up into space. It was not designed for that. It was designed to move geostationary satellites into space. That's why the fairing is the size of a geostationary satellite, right? So, and I know I said 36 tons. Orion weighs 36 tons with its launch abort system on top. Starship could be the future. Sign up. It's 36 tons with its launch abort system, Farm. It's 25 tons with the service module and the capsule. Capsule is about 10 tons. Service module is about 16. Is the spacecraft glitching? No. The solar panels are wobbling around on Orion right now because somebody's working out. I think it's Victor. I think Victor's doing some reps on the rowing machine right now. That's why it's moving back and forth, because he's doing reps and it's shaking the whole capsule. The launch abort system is heavy. Once again, Matt, the launch abort system is solid rockets. It's a solid rocket system, and it needs to be able to get you away fast, so it needs to be a powerful, solid rocket booster. Once again, guys, I don't say this to be like, oh, we're never going to invent something like Star Wars. No. I'm just telling you where we're at right now. The truth of the matter is that if you want to look into better spacecraft propulsion systems, that would be great. Please do that. If you want to pursue a career in advanced propulsion systems, yeah, absolutely. Go do that. In the past, even when I was in high school, they're always like, you're going to invent the next crazy thing. You're going to do this. Nowadays, people say, oh, that can't be done. Oh, that can't be done. That's bullcrap. No. That's not how we invent warp drive. This is ridiculous. No. Go to school. Learn how to do this stuff. Put into work. Figure it out. And make the next warp drive. You'll make millions of dollars if you do. Billions of dollars. New here. Only curious what Mr. Streamer's education level is. Not saying standard education is required to know things. I have a bachelor's degree in computer animation. Anything about engineering, I'm self-taught. Why is there tonal noise? Oh, yeah. Ben F., the buzzing noise, that's the dial tone for Orion. You are hearing the uplink to Orion. It's not background noise, I swear. That's the uplink that you're hearing. That's why. I usually don't mess with background noise on the stream. It's really annoying, right? This background noise, I'm cool with. That's Orion's dial tone, man. that sounds mean they got a connection. Now check this out. If you go on DSN now, Deep Space Network now, you could see what dish NASA is using around the world to talk. Well, at least have a signal. So that buzz, that specific buzz, is from Canberra 34. It's from Canberra 34. It is uploading a signal at an S-band frequency signal at 0.2 kilowatts. See it right there? And the downlink is 2 megabits per second at minus 110 dBm. Now, Canberra has 2 downlinks going because they're trying to they're downlinking all the telemetry back to mission control, right? And they do that through land terrestrial cables. They do that through landlines. But yeah, now I know what people are going to ask. Why is Canberra? What the hell? How's NASA? NASA's using something in Canberra? Yeah, of course. The Earth is spinning, so the United States isn't always
You're watching live coverage of the Artemis 2 mission, the first flight of humans aboard Orion.
The United States isn't always going to have line of sight. So NASA, with its European and Australian partners, built out the deep space tracking network during the Apollo program. There are dishes in Madrid, there are dishes in California, in the United States at Goldstone, and there are dishes in Australia. That is a third of the way around the Earth. So like the one in California is here, all right? Canberra's over here, Miami's over here. Or Madrid, Miami? Sorry, I've been doing this for a long time. Look at the uptime. So we have Goldstone here, you have Australia here, and you have Spain here. They're triangulated around. So as the Earth's spinning, you can always get line of sight. That's the uplink noise. That's what you're hearing when you hear that buzzing in the background.
If you are watching this channel and looking for more spacecraft views, you can switch to our other live stream. Otherwise, you can stay.
In the VOD yesterday, that seemed like we still had the wine. And now keep in mind, guys, that's the dial tone. That doesn't mean the dish isn't transmitting, right? It's the dial tone. When you pick up the phone, that means you have a connection, then you got to dial it, right? They dial it every time they click the radios on. When they're in signal blackout, they don't stop the signal. They could still be transmitting, which is why you heard the noise. That was a big leak. Sorry, we have another deep space tracking station in Miami. I don't know why my brain defaulted to Miami for some reason. Madrid, Miami? I don't know. I've been doing this a lot lately. I've been streaming since the thing launched. It launched like a week ago. I've only been sleeping when the astronauts sleep. So I've been here running like 16-hour days, dude, for like the last week. But I'm not missing any of the moon missions. See, Kraken, type again what you said last. There's a lot of people in here. Did we lose? Hold on.
Service about the lunar surface as we are the press conference live at Johnson Space Center in Houston, Texas, and expect that to begin momentarily. So if you are watching this channel and looking for more spacecraft views, you can switch to our other live stream. Otherwise, you can stay.
NASA's new nuclear propulsion. It will test space reactor SR-1 Freedom. How does that work? It's not like a nuclear saltwater system. It's using a 20 kilowatt. It's using a 20 kilowatt off-the-shelf compact reactor that's hooked to a Brayton cycle Cuban, basically a turbine. I don't think it's a space steam turbine, but that's pretty much what it is. We've sent reactors into space, guys. That's a thing. There was the Snap 27A, Snap 10A. Every one of the Apollo sites had an RTG as an LSEP experiment. All right, here's the press conference coming up. Question, is there anything that NASA can take from other rockets to replace the upper stage and make the service module outside Centaur 5. I'd say keep going with the EUS at this point, but if I had my way, cousin, I would probably say like a New Glenn. Ask New Glenn to make a shorter version of GS2 and put that on SLS instead. All right. Jared Isaacman, Lori Glaze, Rick Henling, and I didn't see who was on the end.
I'm Bethany Stevens, and we are here today to provide a status update on the historic first crewed test flight of the Orion spacecraft post-lunar flyby.
Was that
on
Kelsey
our panel
on the
today,
end?
we
Nice.
have NASA Administrator Jared Isaacman, Dr. Lori Glaze, head of Artemis.
Oh, it was Kelsey.
Rick
All right.
Henfling, Artemis 2 flight
Ricky.
director. Kelsey Young, Artemis 2 lunar science lead. We'll start with opening remarks from each of the briefers before opening it for questions in the room and on the phone bridge. If you're on the phone, press *1 to submit your question. When called upon, please state your name, affiliation, and to whom you'd like to direct your question. With that, I will hand the floor to Administrator Isaacman for his remarks.
Thanks, Bethany. It's been an exciting Artemis 2 mission so far, and a very eventful 24 hours as the crew surpassed the Apollo 13 distance record, 252,756 miles from Earth. They relayed observations from the lunar surface. They've captured some incredible imagery. They performed a ship-to-ship call with their colleagues on the International Space Station. They performed additional manual piloting of the Orion spacecraft. They've been working at a reduced cabin pressure of 10.5 psi in support of future integrated lander operations, and they did take a call from the President of the United States, Donald J. Trump. We had millions of viewers on that tuned in for that historic broadcast, and it concluded with the President promptly inviting the astronauts to visit the Oval Office. Now, Integrity left the lunar sphere of influence earlier this morning, so they're now approximately 229,000 miles from Earth, and they will splash down Friday evening at approximately 8:07 p.m. Eastern Time, and the recovery weather is so far looking favorable. Now you can see some of the spectacular images the crew have captured here on our screens. There we go. Now this is the first time humans have documented some parts of the far side of the moon. Now these images will be publicly available on NASA's website, our digital platforms, and the White House actually released the now iconic EarthSat photo from earlier today. Now, these are the first of many incredible images of the moon, and we'll continue to release them as they become available. My understanding from just a few minutes ago is that they captured over 175 gigabytes of imagery from the lunar pass alone just yesterday. And the images that you are seeing right now have been transmitted back to Earth predominantly through optical communication, which is pretty cool stuff.
The OPCOM, the O2O.
Now, before I turn the call over to Dr. Lori Glaze, I wanted to share some of the other things that we are doing at NASA while the Artemis 2 crew are underway on this historic mission. So the crew on the International Space Station are hard at work. They're undertaking the science and tech demos, many of which have directly supported the Artemis program missions and will continue to do so. The Exploration Ground System personnel, if you want a quick Kennedy Space Center update here, have been out at the launch pad. The crawler, my understanding, is approaching the outer gate, and we expect ML1 to be back in the vehicle assembly building within approximately a week. Now, this would cut down on the turnaround time that we observed from Artemis 1, measured in months right now, several months. On the science front, my understanding is the Blue Origin Mark 1 lunar lander is wrapping up here at the Johnson Space Center in Chamber A. Nancy Grace Roman Space Telescope testing is progressing, so much so that we feel reasonably confident we're going to announce a target launch date this year sometime in the next 2 weeks. In aeronautics, we've been flying the X-59 almost daily while the Artemis 2 mission has been underway. So we work to rebuild our X-plane portfolio. The first senior level Artemis 3 mission design discussion today. Teams are working with vendors on moon-based RFIs and RFPs, and we are advancing the Skyfall scientific payload for the first interplanetary nuclear-powered spacecraft, SR-1 Freedom. I think the most important point we're trying to make here is we can launch history-making missions like Artemis 2, start making meaningful progress towards Artemis 3, and do all the other important programs the world's been waiting for from NASA. And with that, I'll turn it over to Dr. Glaze.
Thank you, Jared. I just have to say, wow, when I look at all of those images that were scrolling by. I hope all of you are as inspired as I am. I know as they continue to be downloaded, they're just absolutely stunning, and we really hope that they are inspiring truly everyone in the world. As the crew surpassed their record for the farthest distance, as Jared just mentioned, when they traveled on the far side of the moon, they offered some compelling words, and I love this. They said they challenged this generation and the next to make sure that this record is not long-lived, and I love that because we have big plans to go not just back to the moon on a regular basis, but beyond. And then, of course, while it's been really exciting here the last couple of days, as we've been watching all of the activity in Orion, we still have to ensure that Reed, Victor, Christina, and Jeremy return home safely on Friday evening. So we're pretty focused on that now, making sure that they get home safely. I will just say a couple of things about yesterday's operations. Really provided a great opportunity to test how our flight operations teams and our science teams are working together in real time with the crews at the moon. And in fact, from my perspective, one of my favorite things about watching all of the amazing data that was flowing down yesterday is thinking about how so much of NASA is working together in order to enable all of what you're seeing.
Exercise within 2 minutes.
Oh, dude, they got the loops.
All right.
Hell yeah.
Stop exercising.
Oh yeah, they got the keep the command loops.
Really
That's
great
sick.
to see everybody working together. So I think about our exploration programs that are supporting our transportation systems like Orion, working with our flight operations and our flight directors, all of the ground teams that are supporting, including the science team supported by the Science Mission Directorate, thinking about our crew that are actually performing the work, and then the payloads that have been provided that they're using. So everything that you're looking at isn't just it's not just the pretty pictures. It's a huge chunk of NASA working together to enable that.
That's a big deal.
All of this information that we're gathering is really going to help refine how we plan our future missions to the lunar surface. I'll just say that our flight operations team continues to fly Orion and put it through its paces as the crew and the spacecraft make their way home. And the mission isn't over yet. We do continue to learn from how our spacecraft and our crew are operating together in space. We continue with several of the science activities that are focused on the crew health and life in space. So still a lot of things going on. And with that, I'm going to pass it over to Rick so he can share some of the operational details.
Thank you, Lori. The administrator touched on a few of the operations that the crew's been up to recently, but I'll fill in a few of the other details of interest. Since we last met Sunday evening, the crew performed the first orbital trajectory correction maneuver, outbound trajectory correction maneuver number 3. It was 10.4 feet per second. The burn duration was 19 seconds, and we used our auxiliary thrusters on the service module. Obviously, yesterday was the big day with flyby, and I'll save all those details for Kelsey, but we had some really poignant remarks from the crew, and I can assure you there wasn't a dry eye in mission control when the naming of the 2 craters was announced by Jeremy.
Carol!
As part of the lunar flyby, the crew made their pass closest to the moon, flying at 3,138 miles per hour relative to the surface of the moon. And now they're on their way making their march back home to Earth. We bid a temporary goodbye to the moon earlier today at 1:23 p.m. Eastern Time. That's the milestone where we exited the lunar sphere of influence and we're back under the control of Earth's gravity. As for today's operations, we had a couple of public affairs events. The crew is going to have, each of them will have a conference with their family members. We'll have some routine medical checks. And then in the evening, we're going to perform the first return trajectory correction maneuver. It will be 1.3 feet per second. It'll last about 15 seconds, and we're going to use the service module reaction control system thrusters to do that burn. We expect that burn to occur about 9 p.m. Eastern Time.
You say 1.3 feet per
Finally,
second?
I'll conclude my remarks with acknowledging that the USS John P. Murtha has left port and has started steaming out to the midway point for the recovery of Integrity and her crew later on Friday. That's all for today's operations update, so I'll hand it over to Kelsey.
0.3 meters a second on RTC-1.
Spirits are very high.
0.3 meters a second.
We did what we set out to do. The Lunar Science team and the crew prepared extensively, as we talked about a couple days ago, for flyby, and I hope you all saw that yesterday during execution. We confirmed, as Lori mentioned, that we can achieve science through orbital observations and through integrating science into flight operations. And as Rick just said, we left temporarily, and we're looking forward to integrating all these lessons learned in future missions. I can't conclude opening remarks without diving into science detail, so forgive me just a couple deep dives.
No, shut up, go off.
Flashes.
We're good. No, don't shut up.
Over a 30-minute observation period, and this was largely during that time of the eclipse, crew observed several impact flashes. We did have citizen scientists here on Earth also looking for flashes, and I know that the Lunar Reconnaissance Orbiter team is hard at work trying to identify evidence of those impact flashes that the crew observed. I did have a chance to have the post-flyby crew conference with the crew this morning, and we asked a lot of follow-ups on those impact flashes. Impact flashes are caused by micrometeorite impacts hitting the moon, and they really help tell us about the dynamic lunar environment, which is, of course, also important when we think about future missions. I don't know if I expected to have the crew see any on this mission, so you probably saw the surprise and shock on my face. And though I was not in the science evaluation room, I heard that there were audible screams of delight. So, a very excited science community. You've heard me talk a lot about the importance that human explorers bring to scientific exploration, especially around observations of color. And so I'm sure all of you, like I was eagerly awaiting if they saw any other colors other than black, white, and shades of gray. You heard that they did indeed. Right away, they started describing the green around Aristarchus Plateau and different brown hues. And these colors really help tell us nuances about the chemistry of lunar material, especially the greens around Aristarchus. That was exciting. That's something that we can all see from here on Earth. And so I encourage you all to go out and look at the moon tonight and look for Aristarchus and imagine those green hues that the crew members saw. You heard a lot of discussion, especially from our pilot, Victor Glover, about the Terminator, which really, to our mind, highlighted the benefits and also the challenges for future surface operations. The lighting conditions along the Terminator that the crew experienced yesterday do mimic, in many ways, the lighting conditions of the South Polar region. The low sun angles, the dramatic lighting causing, the extreme shadowing, and illumination also accentuating topography. This is really important for our agency's future moon base plans and understanding how crew member observations can contribute to future mission planning. And finally, the Artemis 2 crew, in a very poignant moment, offered proposed names for two unnamed craters in the moon's eastern hemisphere: Crater Integrity for their vehicle and Crater Carol for Commander Wiseman's late wife. I think we have a picture. Yeah, thank you. Upon return, the crew does plan to submit these to the International Astronomical Union as consideration for official names. There was, as Rick said, not a dry eye in the house. Really poignant moment, and that we were really glad to observe them describing. And with that, I think we can take questions.
Yep, we will open the floor and take questions, and my colleague Will over here will pass along the mic. We can start with you, Jackie.
Thanks so much. Jackie Waddles with CNN. I don't think there was a dry eye on Earth when Carol Crater was named. I was just curious, was Reed aware that that was going to be something that the crew was going to do? I was just curious if there was any pre-planned discussions and they were just kind of looking for the crater, or kind of how that came about. And then really quickly, I also wanted to just check on a toilet status update. We heard this morning that I thought I heard some chatter around it being considered, a reentry issue now. Like, is the toilet out of commission until they get back, or where does that stand? Thanks.
Oh, no.
I'll take the second part.
Okay. Yes, I know the crew put, a lot of, obviously, thought and pre-planning into what you heard yesterday. It is my understanding that he was aware prior to yesterday.
And the toilet remains operational. The challenge that we're working through is evacuating the wastewater tank. The vent is a lot less than we were expecting, and so we're having to fall back to some other alternate means other than the toilet. But what you overheard on the space to ground or on the Orion to Earth channel this morning was us deferring some maintenance on the toilet. Typically, when you have 4 crew members using it throughout the day, nominally, you have to do a maintenance activity once a day. And with a lower use rate, since we're not able to vent the wastewater products, we don't need to do the maintenance as often. And so that's what that exchange was about.
No, it does work. It's
Thanks.
just for pooping.
Irene Klotz with Aviation Week.
Not for peeing.
I'm over here. Jared, that's a pretty impressive and full portfolio of missions you outlined that NASA's involved in now. And without getting you in trouble with your boss, are you going to be able to defend an $18.8 billion budget, $5.6 billion for 27, or are you prepared to kind of work with Congress to see if the administration will support more? Thank you.
I will say we'd like to keep the
cool.
focus on what we were speaking about today and then move on to other questions like that at a later date and keep the focus on the mission. Thank you.
Fair.
Mark Strassman, CBS.
Look at you. Look at you.
As though I talked to about 10 people off campus today, and they all wanted to ask me about those remarkable images. And so they asked me, so I'm going to ask you. Have you seen anything in those images that surprised you? And what about those images touched you?
Take that, Kelsey?
Sure. Oh my gosh. When I woke up this morning, I've spent most of my morning just flipping through, the thousands of images that have started to come down. And there is something in every image that surprises me, right? I mean, you might think that after looking at hundreds of images taken of the lunar surface, I would get sick of it. I have not, nor do I anticipate getting sick of it. It's just their experience and the amount of time and the rate at which they were moving. Every vantage point is different. You heard them audibly describe yesterday, wow, I'm looking at the same feature as I was 10 minutes ago and it looks different, right? And the images reflect that. And so, when I see these images, I connect to each one in a different way, especially in light of what we heard from the crew yesterday. I think as a geologist by training, I love looking at the pictures of the lunar surface, but I think certainly, emotionally, a lot of us have connected with the images of Earth, with the images from during the eclipse, with the images from the vehicle cameras taking pictures of the moon during the eclipse period. And while they are inspirational and I think allow all of us to, really feel a little bit of what they were feeling, there's also a lot of science hidden, inside of those images. And I can tell you that right now, as we speak, there is a science evaluation room full of several dozen scientists who are already getting going on those images. Just as one example, there was a healthy scientific debate this morning about some of those images taken during the eclipse period and what we can see of the solar corona and what we can see of zodiacal light. So the conversations and the science lessons learned are just beginning.
Hi, TJ Mascaro with the Epoch Times. Thanks so much for taking the time. For Jared, as we saw with Artemis 2 going around the moon and having that very characteristic blackout of when they go around the moon, how much longer are missions to the moon going to have that as we develop a moon base? And where do, say, communication satellites in lunar orbit land on the priority list?
Yeah, I'd say, people have asked quite a bit about, was elevated blood pressure when we were without comms with Orion on the far side of the moon. We have comm issues in LEO relatively, routinely. Certainly our operators train for it, our astronauts do as well. But in terms of the bigger picture, can we do better? For sure, right? We've talked about, prioritizing observation and comm relay satellites for lunar operations so we can bring the world along with us as we build out a moon base. And I think I was in a meeting not that long ago where we described it as if not the the platinum age for commercial communication capabilities, certainly the golden age. We're very close. So we have a number of providers that are all investing heavily in these kind of capabilities that we can take advantage of in LEO, cislunar space, and I have no doubt in lunar orbit in the years ahead.
Hi, Kay for Interstellar Gateway. Thanks for doing these. This is really cool. Jared, question for you. Can you speak on the responsibility of what being the administrator during such a pivotal moment means? And secondly, I'm speaking on behalf of musicians around the world and bands. I have a band called Chasing Satellites, and will there be potentially an opportunity to submit music for a future Artemis mission for the wake-up calls? That was really cool to be a part of and to watch as a musician.
Certainly. So I think I've described before that I thought that certainly felt a lot more pressure, being on the outside and responsible for a human spaceflight mission than being in the vehicle itself, especially a mission such as Artemis 2, which kicks off so many other exciting ones to follow as, we return to the moon and build that enduring presence to learn so that we can undertake even grander missions, as Dr. Glaze referenced, beyond the moon in the future. So I think it is a great responsibility, but you derive confidence from all the expertise that exists within NASA, the workforce, our commercial, our international partners that come together for a moment like this, all the testing that goes into it, and the fact that we have this playbook before and we're running it. Now, in terms of contributions for music and future wake-up music for subsequent missions, I hope we're running so many missions to and from the moon in the future that we're going to have to cast a very wide net for creative content. So.
Thank you. For Administrator Isaacman, Tom Costello with NBC News. I'm just wondering, how are you feeling now? I realize we don't have the crew home yet, but you've had a very successful trip around the far side. How are you feeling about this setting the stage, testing out the vehicle for a lunar landing as soon as 2028?
That's not a bad question for CBS. I'm actually impressed.
I'd say for this mission, we're certainly off to a good start. clean launch, and the vehicle has been doing well. I've made commentary early on that I like that we're talking about, water access valves and cabin temperature and even plumbing issues, for that matter, for all the things that we could have been potentially talking about prior to the mission underway. But I'll breathe easier when we get through reentry and everybody's under chutes and in the water. In terms of getting ready for the subsequent missions, it's kind of why I picked some of the words that I did at the beginning of this press event, is that a lot of people's rightful attention right now is on the crew of Artemis 2, especially here at JSC and Mission Control, especially the recovery forces that are now making their way out to bring this crew back to their family. And for everybody else, we've got the other things to get done, including thinking about Artemis 3. It's why I was very happy that the crawler is making its way out to 39B right now. We've got a timeline to get it back in the VAB, ideally in a week. That would cut down on the turnaround, I think, by 3 months compared to Artemis 2. So we can undertake, again, world-changing missions like Artemis 2 right now and get ready for the next ones at the same time.
Hi, Josh Dinner, Space.com. Has this mission revealed anything about life aboard Orion, crew workload, flights in deep space, or maybe something unexpected that will shape how NASA and Artemis crews approach preparing for future missions?
You want to take that from Flight Ops?
Yeah, that's a really interesting question. We've learned a tremendous amount as part of a lot of the flight test subjective activities we've been doing. I think we have a couple of problems that we still need to work out, but Orion has shown itself to be a very capable capsule for beyond Earth orbit space travel. And I think the things like, as the administrator talked about, the things that we're going to have to improve upon for Artemis 3 are relatively small and incremental in nature, as opposed to wholesale redesigns of spacecraft subsystems. So overall, I'm extremely pleased with the performance of the spacecraft and how it's served as a campsite for our 4 crew members.
We'll go from Marcia to Eric and then do a couple on the phone bridge.
I'm Marcia Dunn, Associated Press for Dr. Young. It's hard for me to know how quickly these pictures are coming down. How many would you estimate that have come down so far of the moon? And these luminous flashes on the surface, was that an actual meteor shower, do you think, or is it just your usual business of falling debris?
Yeah, so the team, the FOD team, is working really hard to bring down the images as fast as they can. Of course, we also have other vehicle data that needs to come down as well. But the team is working really hard to try to get those images down and of course, get them out to you guys as well. We, as of the time I left Console roughly an hour ago, there was just over 50 gigabytes of data from yesterday that had come down. Of course, that's not, every image does not exactly have the moon in it, but it is taken from within the lunar observation period.
Okay.
So we're working really hard to get those down, as well as the audio files that the crew were taking. That's a really rich scientific data set because it captures the nuance of what the crew were seeing. You know, we heard a few of those per hour in those science situational reports you were hearing yesterday, but there are multiple hours of recordings of, you know, meaty science observations, about 2/3 of which we've been able to get down so far, and our team has already been looking at that, you know, those couple hours of transcripts and audio files. As for the impact flashes, yeah, absolutely. I mean, we think they saw at least 4 and possibly up to 6 impact flashes. Again, I talked to them about that just this morning in the crew conference with them. I think, you know, we you know, it's very early to tell, right? This happened less than 24 hours ago. Our teams are looking at it now, and spacecraft like the Lunar Reconnaissance Orbiter will be really helpful to try to help us narrow in on that. But the lunar environment is a dynamic place, and we have a lot to learn about it. You know, LRO has returned a lot of information about the lunar environment, but observations like this are a critical part of our understanding, which will pay dividends for future surface exploration.
Eric.
Eric Berger, Ars Technica. There's a question maybe for Jared. So why haven't we been back to the moon in 53 minutes? I'm just kidding. So you brought up the Artemis 3 mission design. Can you bring up sort of, or talk about the 2 or 3 hardest problems that you're tackling? Sort of, you talked about the mission design meeting today, but sort of the 2 or 3 hardest problems you're tackling right now to make sure that launches next year.
Yeah. So I don't want to get too far out in front of a mission that's underway right now. I would just say that there are a lot of things based on the information we have available today, from feedback from our vendors, that we know are achievable. And I think one of the questions probably will just be what the initial orbit will be for Artemis 3. Is it going to be LEO or HEO? And I think that we're all going to have some sense of which one, and there's pros and cons for each of them for sure. We're all going to be able to have some sense about which path we'll likely go down based on launch cadence of our 2 HLS providers, both of which have launches coming up, I would say, in the next month or less right now. So a big key to our strategy, not just to return to the moon, but to stay and to build a base, is going to be rapid reusability of heavy lift launch vehicles. So the more they get experience doing that, the more options that are available for us for Artemis 3. But I'd say right now, we certainly have a good plan for that mission. Will help us buy down a lot of risk in advance of a landing for Artemis 4 in 28.
Jeff Faust with Space News.
Hi, Jeff Faust with Space News. Question for Dr. Young. Now that you are going to get all of these images and verbal descriptions and annotations, what's the plan for the science team in the days and weeks ahead to go through all of that data and see how they address the 10 science objectives that you laid out for this mission? Thank you.
Oh my goodness, what a good question. We have a lot of data to get through. Like I said, it has already started. We had teams working overnight, you know, after the crew went to sleep, as soon as we started getting data down. You know, I will reiterate that we will be getting all mission data relevant to lunar science archived and made publicly available within 6 months post-splashdown. So these are all of the images of the moon, these audio files, and even the annotations. But in the meantime, over those next 6 months, we're also going to be preparing 2 reports that we also owe to be publicly released within 6 months post-mission. One is a science operations report that describes, how our team was structured to integrate with flight operations to accomplish our objectives. But relevant to your question, the second one is a post-mission preliminary lunar science report. And so we are going to be going objective by objective with those 10 lunar science objectives you referenced, looking across this entire, really rich, robust, but very large data set, and really trying to understand what data we got relevant to each objective, but set up the community for success so that they can access those data and help us answer these fundamental driving science questions. The lunar science team for this mission, it was our charter to develop the objectives and to maximize the science value out of this mission. We'll be doing an initial assessment over 6 months, and then we're really eager to see what the community is able to do with these data.
We'll move to Ken Chang with the New York Times.
Thank you. So I have some questions about the optical communications. How was the performance like? How many gigabytes was sent? What was the data rate? How does that compare with what was expected? And how does it compare with the usual way of sending data back? And it seems like it's been almost operational already and not just a test. Thank you.
Yeah, I think the question was relative to some of the data rates for the optical communication system. I'll just give you a stat from overnight that we heard from Consul. We got 20 gigabytes down in a little more than 45 minutes. That's orders of magnitude more than we get via our S-band telemetry system. So optical comm has been working really well, and hopefully we can take what we learned on Artemis 2 and expand its operational capability and its implementation for future missions.
And now we will move to
4 gigs a
Lauren
minute?
Grush with Bloomberg.
That's pretty good. Yeah.
Out to me yesterday was
What the hell?
the vivid descriptions that the crew used for what they were seeing and how they remained in kind of constant contact and talkative throughout the flyby. I'm wondering if it's possible to say how that might have compared to the Apollo crew observations and how that robustness impacted the science and the data that was collected.
Absolutely. I mean, probably a lot of people watching have spent a lot of time looking back at Apollo and maybe watching Apollo in real time online and reliving what the Apollo crews, not just on the surface, but in orbit experienced. You have, I'm sure, heard the Apollo descriptions of the lunar surface from orbit, and they were also really impactful. They trained heavily in geology and orbital observations, just like the Artemis 2 crew did. I will say, listening to the level of scientific discourse that the crew was having yesterday was incredibly inspiring. I mean, a testament to how much they prepared before this mission. I heard a couple times Christina and Victor especially saying, when we took the time to actually talk to each other about a specific target that we were both seeing, we elevated each other. We elevated what we were able to pull out of that target. More brains on a scientific target are better than one, and we heard from them directly multiple times that they were helping each other to advance their scientific understanding of what they were looking at. We actually also heard them say, hey, we have a hypothesis. Can you guys provide guidance on that hypothesis, like right now in the middle of our flyby? So the science team was saying, was cross-checking what they were seeing, was reading up geologic ages of major lunar impact features, and it was informing the observations they were making during the flyby. I mean, this is absolutely everything we hoped for by integrating science into flight operations, because, again, science enables exploration and exploration enables science. And the fact that, they're giving observations.
She's awesome.
And, I was able to immediately follow up on those observations with, just the quick questions that can enhance science return. It meant that they were evaluating and buying down multiple working hypotheses in real time during their flyby. And just imagining the future when we have crew on the surface for short duration missions and ultimately the moon base, the amount of science we are able to gain when, science is woven into this operational fabric is incredibly impactful. And we saw that, for 7 straight hours yesterday.
Now we'll move to Micah Maidenberg with the Wall Street Journal.
Hey, good afternoon. For Rick, what is the approximate time on Friday when the crew module separates from the service module, if you have that on hand. The administrator mentioned splashdown is expected for around 8:07 Eastern. And then any color on kind of reentry prep work ahead for the crew and mission control between now and Friday. Thanks.
Sure. I'll start with some of the times. The crew module and service module separation is going to occur about 20 minutes before entry interface. So that separation will be at 7:33 p.m. Eastern Time. We expect entry interface about 7:53 p.m. Eastern Time, with a splashdown around 8:06 p.m. Eastern Time on Friday. As for the preparations that the ground and the astronauts are doing today to prepare for entry, or today and future days, a lot of it is all of the science equipment and cameras and tablets and reference material that got unstowed in support of the flyby. Well, we have to put that all away. We have to pack up our suitcases and get ready to come home. And that takes time, and so we are laying out a plan to make sure that the crew gets everything packed away in time to get their suits on and get in their seats to perform that final trajectory correction maneuver on splashdown day and come home.
We'll move back in the room to Joey and then on to Will.
Thanks. Joey Roulette with Reuters. I just had another quick toilet question. Do you have any idea as to why the venting is not happening as fast as you hope it is, and what other hardware on the spacecraft might that implicate, or what other problems might that cause?
Yeah, so the engineering team is going to go through a full fault tree to identify all of the potential causes of the blockage. Initially, you may have recalled that we thought it might be icing up at the nozzle at the outer mold line of the spacecraft. We have pretty high confidence that it's not an icing condition. We've put the spacecraft in a sun-focused attitude to bake off any ice. We've activated heaters along the lines internal to the spacecraft, and we still see a blockage. And so the latest theory is related to some of the chemistry that goes into ensuring that the wastewater doesn't develop any biofilms. And there may be something going on with a chemical reaction where there's some debris that's generated as part of that reaction, and it's getting clogged in a filter. But again, we don't have root cause, and once we get the spacecraft back into the processing facility in Florida, we'll be able to get access to all the components and do a real detailed fault tree to identify the root cause.
That sounds like a crappy job.
Hi, Will Robinson-Smith with Spaceflight Now. Thank you all for taking the time. Going back to Dr. Young's point about the intersection of science and exploration, to both Dr. Young and to Dr. Glaze, given the number of believed to be impact flashes that the crew observed during just a relatively brief amount of time, I wonder how these observations and the ones made previously by LRO will factor into creating the conditions for a moon base that can allow the astronauts to stay safe, given the probability that they may experience a micrometeoroid impact at that site. Thank you.
Well, I do think that the data that we're collecting with these observations, and as you noted, the LRO data that we're continuously collecting, we have been for quite a while, all of that is being fed into our plans and making sure that we understand what all of the variety of risks are. There's many that we're looking at, and of course micrometeorites being one, as we start to establish infrastructure on the surface and understanding those rates. These kind of data really help inform us as far as what we can anticipate. And of course, the different parts of the moon, down at the South Pole, maybe a little slightly different rates than we would see higher up at higher latitudes. So we need to compile all of those data and understand where, what those impacts might be.
Bless you.
Hi, I'm Nick Notori with ABC 13. A question about the scientific stuff that you found yesterday. I know the question was asked about what was inspirational. I talked to Joel Kearns yesterday, and he had told me, I'm just looking at his quote, as a scientist, I can tell you what's most inspirational is when you're pouring through something you're working on and you realize you're seeing something that nobody else has ever seen before. I know you talked about the impact flashes, but is there anything else that no one else has seen before that you guys have already saw? And then also explain to us on Earth that maybe this is high level over our heads, how what was photographed or taken yesterday could maybe give us some answers on our planet of Earth.
Thank you. Yeah, lovely questions. I might just give a specific example of something I heard from the crew yesterday. My background's in geology and specifically impact cratering, so every time they describe those beautiful basins, I get really excited. They did describe Ohm crater a couple of different times, and they noticed a variety of different color and albedo hues associated not just with Ohm, but with the rays that extend out from the crater. This could indicate, impact events are really compelling for a lot of reasons. Obviously, I'm quite biased, having written my PhD on them. But they can excavate material from great depths below the surface, which means they're kind of like a geologist cheat code, right? Where you can't get all the way down there by yourself, but when an impact has brought up that material for you, it can actually perform that excavation, and we just need to send the crew to the right spots on the surface, and they can actually look at depths far below the surface. And I bring that up here to say that what the crew observed around Ohm yesterday was they actually noticed color and albedo hues coming out in those rays, and they noticed that they were distinct and different and evolved along the ray systems, which could potentially lead us to believe that that crater excavated from distinct depths below the surface of the moon. So it's those kinds of nuanced observations that can ultimately inform future landed missions, future crewed missions, to understand where can we go to maximize the scientific value. These ultimately get at chronology of the solar system, at how the inner solar system has evolved over time, which connects to, the moon being the witness plate for our planet and for the inner solar system. You heard Lori and I the other day get very excited about talking about, pesky plate tectonics and oceans and vegetation that gets in the way of us looking at the early part of our planet's past, and the fact that that part of the record of our Earth-Moon system is still available on Earth. Well, where it's available is the highlands, the far side highlands, and the South Pole. Specifically, the South Pole has the South Pole Aitken Basin, which is my personal favorite lunar and planetary science objective. It's the oldest basin in the solar system. If we can get the right age constraints on that basin, it can help us anchor the chronology for the entire solar system. And so crew observing things like they did with Ohm, where they can say, with my eyes, I can see this distinction, which can ultimately tell us that future observations of high priority landing sites could tell us something similar. This is how we start to really bite away at these really, really fundamental science questions that impact not just our understanding of the moon, but how our own planet has evolved over time.
See that girl?
Mark
See that
Kirkman
woman? She moons harder than you.
All
right.
Here, I'd like to drill down a little bit on entry day a little more.
Harder than you.
Sounds like
harder than anybody.
Primary recovery zone.
She's the
is looking
freaking best.
Favorable.
That's
can you
awesome.
walk through as we approach EI and pass EI what redes capability you have, what kind of cross range and down range capability you have, when you committed to that landing zone, and also with this thermally benign entry you're going to fly, do you still expect to exceed Apollo 10's speed record? I know you don't care about that stuff, but we do.
That's all right. You can still keep asking the questions, and we'll go follow up, and we'll find the answers. I do not have the answer offhand about the Apollo 10 speed record, so we'll have to get that back to you tomorrow. And tomorrow, I'm actually going to provide a lot of detail about the sequence of events for entry, as I'm the entry flight director for Friday evening splashdown. But with respect to your particular question about entry interface, we can select a new landing site as late as entry interface. We would prefer to not do that. We like to give ourselves a little bit of margin, but we can adjust the latitude and longitude of the site, and the spacecraft will fly to those coordinates so long as we get that command up before entry interface. So we're going to make a decision far in advance of entry interface to know where the splashdown site will be, because our top priority is to ensure that when Integrity and her crew of 4 splash down, that we have the recovery forces right nearby to help get them out and get them back to the recovery ship.
Yep.
So we have about a 475 nautical mile range. I can't do that conversion. But 475 miles of ocean within which we can select the most acceptable weather. And as you said, weather near San Diego looks favorable, so I'm optimistic that we'll be able to land close to the shore.
Tom Clark with Sky News in the UK. First of all, congratulations on the flyby and those breathtaking images, and thanks for doing this too.
This is space.
There's been a lot of focus on the toilet, but I'm looking to get a kind of overall perspective on how happy you've been with Orion and the European Service Module. What are you definitely going to have to fix before you fly it again? And how confident are you looking ahead to re-entry?
I'm not sure I heard the end of the question. You talked about how the Orion is performing, and it's performing spectacularly. I have to tell you, our Orion team is so pleased with really everything the way that it's performing. The engines, the manual control that you've heard us talk about several times, that the crew have just gone over and over about how well that's performing, how nicely the Orion crew module is handling. The service module, again, providing everything that we need. Yeah, we've had a couple of challenges, but overall, I mean, I think they're pretty minor in the whole grand scheme of things. The hardware itself performing extremely well. We're really looking forward to turning this around and flying again in a year, and then again a year after that. I think this hardware is really spectacular, and we're really looking forward to doing this more often.
Please do that.
We're going to get the toilet figured out. The toilet is actually functioning perfectly. It's the drain, the ability to vent the wastewater. And as Rick said earlier, as soon as we get this down on the ground, we'll be able to get inside, and we will get to the root of that.
Hi, Lisa Grossman from Science News. This is especially for Kelsey, but actually for all of you. The astronauts yesterday used a lot of really fun analogies and descriptors for the features on the moon they were seeing. Did any stand out for you as favorites?
Dude, Apollo shirt. Hell yeah.
Of like the analogies they used to describe lunar features? Yes, I liked the handprint, and that actually, we had a team working overnight to figure out exactly what they meant. They found it this morning. They were very excited to figure out exactly what they were talking about. I think, we train them, to be totally blunt, we train them to describe it like they see it. Tell us what speaks to you and how you can communicate it back to us. And so I think Christina delivered on that ask when she described a feature as looking like a wound. We do agree. I'm not sure it was my favorite lunar descriptor I heard yesterday, but it was evocative, and she was right. It did indeed look like a wound. And I was also really resonating with the way that several of the crew members were trying to, in the spirit of wanting to have a scientific dialogue, right? They had science questions they were trying to answer, and they were asking us some pretty sophisticated questions real time. And so to bring us with them on what they were seeing, the way that they were cluing us in to how they were moving across the moon by saying, take this feature, draw a line from that to this, and then continue going, and this is the feature we're looking at. Help us use that as a waypoint. It was an incredibly impactful way to have our team be ready to very quickly provide them with answers to the science questions, which is, again, important, not just because, of course, we want to support our crew at the moon, but when we can respond quickly and understand what they're looking at, it maximizes science, because we can immediately ask the follow-up question and have them burrow in even deeper on those multiple working hypotheses. So the descriptions are not just great to clue us into what they're seeing, but it really helps us in real time maximize the science we're getting out of, in this case, a 7-hour flyby.
I'd like to just comment real quickly on one of my favorite. It wasn't actually a lunar observation, but it was during the eclipse, and they were looking at the planets that could be seen. You could see Mercury, Mars, and Saturn.
And Venus, yeah.
And Venus on the other side, yeah. But they're looking at the planets, and I can't remember who said it, said one of them looks kind of red, and Kelsey's observation was, that's Mars, you're looking at your future. And I thought that was spectacular.
Thanks.
We only have time for a couple more questions, so I'll pass it over to you, Jonathan, and then we'll do one more.
Thank you. Jonathan Seri with Fox News. I would love to know about the logistics that went into the ship-to-ship call. If you could explain in layman's terms, how did it work out? And perhaps more importantly, what was the symbolic impact of that call?
So the logistics, we have done a number of public affairs events on integrity throughout the mission. We do them multiple times a week on the space station, and everything goes through Houston. So the data comes through the Deep Space Network, through the Jet Propulsion Laboratory over to Houston. We have audio and video technicians here in Mission Control who can reconfigure the routes for the data and send it to the appropriate destination. We do public affairs events down from the ISS through the tracking and data relay satellite system. And so that's something we do all the time. It's just a matter of connecting the two wires. And so logistics were really quite easy despite the distances.
Yeah, maybe I could add too, I was in the flight control room this morning for that call, and something I observed that I didn't anticipate, of course we're expecting the crew joy at talking and connecting to each other, but looking around the room at the other flight controllers, and actually the viewing gallery was open for other FOD employees to observe. This is a team sport, so many people, thousands of people work to enable this, and seeing the joy on everybody's faces as these two missions flying at the same time had this moment of connection is going to stay with me as a moment of inspiration from this mission.
Yeah, and I would just add, in terms of it being symbolic, it is certainly a step in the right direction. It began with a single person in a Mercury spacecraft, and we progressed to 2 spacecraft at one time. Now we've got an international space station while a spacecraft is coming back from the moon. This is progress. We talk a lot about, what is an interesting KPI, the number of people living and working in space. We want to see that number grow. So hopefully in the not too distant future, we've got communication going on between our moon base, their colleagues that are orbiting above them in a lander, relaying back maybe to other colleagues on an international or future commercial space station. These are all steps in the right direction for the exciting future that many of us were probably imagined as children and we're trying to bring into reality.
We're going to do last question.
Hi, Dr. Allison McGraw, Mysterious Meteorites from here in Houston, Texas, for Lunar Science Lead Kelsey Young. Are there going to be any science data available of perhaps the color data for the impact flashes or trajectory directions they came from?
I asked the crew about that this morning. Any color? How long did they last? Where were they? And Reed and Jeremy, as I was talking to them, had their crew tablets out and they were making annotations and sketches on what they saw. They did just report this morning in our conversation that they didn't observe any color to them and that they were very, very brief, but they did provide sketches on where about they saw them. And so again, like I said, we're going to use the Lunar Reconnaissance Orbiter to try to, track to those features and try to identify what they saw. Trajectory is going to be hard, but Lunar Reconnaissance Orbiter data can help us pull that out. What we really wanted to do before the crew, splashed down and got distracted with all of the things they're going to be doing here was capture that nuance before it got overcome by a lot of other mission events. So we were able to capture a lot more detail this morning in my conversation with them, and the LRO team is off to the races.
Great. With that, thank you for joining us today for our mission status briefing. We will have another briefing tomorrow. Until then, you can continue to follow along with the mission 24/7 on NASA's YouTube channel, and we will leave you with these beautiful images captured by Integrity.
Yeah, baby. When the Luna comes along, you must shoot it. Before the craters get too long, you must shoot it. All right, looks like a Devo album cover. Down out, down out. I said whip it. Down out, down out. That's a sick picture. Holy crap, dude. We relock on the signal on Orion. Dude, that freaking picture. Holy crap. I hadn't seen that one before. Can I go back to that? Hold on. Oh, that's cool, man. Bro, I dig the mood lighting in Orion. That's actually super neat. Dragon has mood lighting like this too, but Orion's got that. It's got that NASA Spartan look, dude. That I dig it, man. You look at, like, you can see the interior of Orion. You're like, yeah, that's a spaceship, baby. That's a spaceship. This thing spaceships. NASA Punk is top notch. Yeah, that's what it is, man. Come on, man. Look at that. Dude. That crater's got integrity, I tell you that. That crater's got a lot of integrity. That's a dang integrity crater right there. And Carroll Crater. I don't care if the Astronomical Union doesn't call them that. I'm calling them that.
Good afternoon and welcome back to the Artemis Mission Control Room here at Johnson Space Center in Houston, Texas, where teams continue monitoring all systems and the crew aboard the Orion spacecraft, the first flight of humans on this spacecraft.
I don't know, Vasi. I would assume that
the crew is having a little bit of a quieter day today. They woke up at 10:35 a.m. Central Time.
I would assume that the difference between an eclipse and a sunrise is probably whether you can see the solar corona get eclipsed, like you can see the sun get eclipsed. That's only going to happen from far away. I suppose that would be your kind of line of demarcation, right? Altitude.
Science lead Kelsey Young. You just saw her in our mission status briefing.
Yeah, that's Kelsey's console right there. It was empty.
You're looking at a visualization of the spacecraft. Now 48,670 miles from the moon and 228,090 miles from Earth, continuing to grow closer. You can keep up with this data at any time by visiting nasa.gov/track-Artemis.
That's the Kelsey console. It's not the science officer desk in mission control.
Coming up shortly, we expect the crew to have their intermediate burn targeting conference. At that time, the teams will load up the latest burn plans aboard the spacecraft. The burn we're expecting this afternoon will be small, especially in comparison to the translunar injection burn that put us on this trajectory. These trajectory correction burns are using the RCS, or Reaction Control System, thrusters on the spacecraft. Much smaller thrusters with much less power than the OMS, or Orbital Maneuvering System engine that we used to propel us around the moon and bring us back home.
You know what the expected reentry angle is? Shallow.
This is a live view from the spacecraft looking at the service module. That large nozzle is the OMS engine. We do not intend to use it again during the mission, having completed that translunar injection burn.
That's a shame. That center engine is a shuttle orbiter maneuvering engine with 17 flights prior on 3 different orbiters. It did good. Did good. Can we just make new ones? Can you stop expending shuttle parts, please? Where are they hitting entry interface? It's going to be out over the Pacific testing range, Baron. Here, I'll show you guys. Watch. Or upside down. Hold on. Damn it, where'd you go, Earth? Oh, there we go. There we go. I got the camera oriented correctly. So they're going to re-enter out over the Pacific testing range. I don't think Australia's going to be able to see it. New Zealand might be able to see it, but yeah, the re-entry is going to be... Be quiet, Pat. Uh, 7 p.m. is entry interface on Friday. So that's what it's going to look like. This is in the future here, and that's entry interface more or less. And they're going to target off the coast of San Diego. See how it's pointed right at California? What is that heading that's going to the north? The reentry is going to be fine. Yeah, of course it is. Here, let's go back to where they actually are right now. There they are. You need a week off after this mission takes Primo somewhere fancy. No, I'm all right. Guys, I don't... Take me somewhere fancy? I took you to the moon, long balls. Is that not fancy enough for you? Moon is so yesterday, when Mars, yeah. Didn't Artemis 1 have some heat shield issues? Musu, it did, and they're flying Artemis 2 on a different trajectory. You have something like NSF tips away from YouTube to thank you? Bobry, it's over on the Twitch site. If you go to my Twitch page, EJ_SA, and just scroll down under my channel, like, you don't need to log in or anything, just click the tips button, and that's how you do it.
We're coming up on the burn conference ahead of today's return trajectory correction burn with the crew members aboard the Orion spacecraft. As you heard Commander Reed Wiseman call down earlier, they have only eaten about 40% of the food allotted to them for this mission. The food the 4 astronauts eat plays a key role in maintaining their health and ensuring they can perform their mission objectives to the best of their abilities. Let's learn a little bit more about how to eat in space.
Yes, let's.
Around the moon meal.
Around the moon meal. What would you eat? Cheese? Can you think?
Oh my gosh. That's clever.
Yep, there you go.
What do you think?
All right, go ahead. My name is Christina Cook.
And I'm Jeremy Hansen. We're crew members on the Artemis 2 mission flying around the moon. And when we fly around the moon, of course, we're going to be taking some food with us.
That's right. This is how to eat in space. Here we are in what we call our food lab at NASA Johnson Space Center. We come in here quite often to sample space food. The neat thing about the food selection is it is so diverse. Different entrees that you wouldn't imagine can be rehydrated and actually good in space are completely fair game. And it's pretty awesome.
We came in for Artemis to do this. We got about halfway through the first session and we're like, we're not really sure we're going to have time on board to warm this stuff up. We talked a lot about day one. It's a long day. It's hours before we even leave the launch pad on our way to space. And then when we get to space, we have a lot of important events that day. We just did a sim yesterday where lunch is scheduled. It's
midday meal.
Yeah, midday meal for all four of us. And so those would be great moments, I think, in our mission to have prep some food and sit down or float as a crew and just have a joint meal.
For sure.
I think that'd be fun.
My name is Xulei Wu. I'm the food system manager for ISS and Artemis. The food lab at Johnson Space Center, that's where we make and package most of the space food, and also where we will be making all the food for the Artemis missions. Food is a big part for our crew members. They provide the nutrition, the calorie, micronutrient for crew members, but also boosting crew morale. It's very important. There is always a lot of steps, very strict steps for us to follow to making sure the food we provide are consistent and meet all the food safety, nutritional requirements, and most important, also need to taste good. The other strategy is always promote the variety, because everybody's food preference can be very different. Therefore, the more variety we can have, the better to meet the needs of the astronaut group.
They bring out these little tiny samples of each food, and you're like, oh my gosh, I thought we were having lunch. And then by the end, there's so many space foods, and every time you leave, you're like, I am so full.
I'm so full, I'm in pain.
And you just rate them like, I love this, I don't want to eat it, I'd eat it if you tell me I need it. Because what the food lab does is they take all your preferences, but they're also like good parents and they're like, you need a well-balanced diet.
Exactly. They were like, no, you can't have mac and cheese every day, Christina. Sorry.
Damn! Christina just scored some points in my book.
I'm Wyeth McKinley. I'm a flight controller and a crew instructor for Artemis 2. We're here at the Space Vehicle Mock-Up Facility at Johnson Space Center. We're inside the Orion mock-up where we perform crew training for the Artemis 2 mission. On the Orion vehicle, crew is able to heat up their food using our briefcase-style food warmer. The food is held in contact with the central heater plate by these springs so they can warm up and they can have a delicious meal. Much of the food and drink that's on Orion is rehydratable. And so crew at our potable water dispenser will fill up their food and drink, and then at that point, you go ahead and pop it into your food warmer.
I'm kind of envisioning there's maybe one person putting the stuff in and out, kind of tossing it out to everyone as it's done. Or maybe if we're not scheduled together, you're just on your own over there, popping some things in. Or maybe just in your 2 minutes of free time between things, you're kind of getting it ready so it has time to warm up. We'll see.
Eating together really resonates with me. I think it's just a human thing to break bread together and to enjoy that necessary thing you have to do, the thing you should be grateful for. And so doing that as a group, as a family, has always been meaningful for me.
Absolutely. It represents togetherness and something a little out of the ordinary. You don't necessarily get to have those meals with everybody in your life, but if you are sharing a meal, especially if you're sharing breakfast, lunch, and dinner with a group of people, that means something. It's like a camping trip.
And no, the bathroom has its own room, dude. The bathroom's at the bottom of the capsule.
Go ahead. Down and to the left, line 17, the DAP load is 3 for burn maneuver. Go ahead. In the guidance solutions section, the delta V tote now 1.4 feet per second. The TGO is unchanged at 15 seconds. Good, go ahead. Attitude, yaw, 154. Pitch, 26. Roll, 287.
He's telling them which position the capsule is going to be turned in for the return trajectory correction burn 1.
Copy, go ahead. And the last bit's the delta V, X, minus 1.2, Y, 0.6, Z, minus 0.6.
So that's the change in velocity in X, Y, and Z directions that the capsule is going to have from doing this maneuver. That's not a lot.
Copy all. Thanks for that clear read up, and
We see that our next step is to run 2-level targeter.
We concur. We'll be watching. And just a reminder that we're not pressurizing the tanks before this burn, so we're going to do it in blowdown.
Okay. They're using the residual pressure in the lines
Copy
to fire.
blowdown, and understand we have a go to complete step 9 on board, even though the burn execution steps show it as a skip.
This guy give coordinates like a Sailor
Checking.
Moon fan? Oh, yeah?
Oh, good catch, Christina. We missed that. That should not say skip. We do want you to do step 9 for intermediate targeting.
Copy all. We will do it and chat with you after. Thank you.
Roger.
It's body-centered reference frame lava, yeah.
That was Capcom's Stan Love here in Mission Control Houston, a fellow NASA astronaut speaking with NASA's Christina Cook aboard the Orion spacecraft. The crew aboard the spacecraft is preparing for their return trajectory correction burn. It's the first of these return trajectory correction burns, reported to be 1.4 foot per second delta V burn.
Yeah, 0.35 meters a second on the burn. 0.35 meters a second. 1.4 feet per second. That's nothing.
Again, we
That's
are
a
expecting
sneeze.
that return trajectory correction burn tonight around 7:03 p.m. Central Time.
Okay, so it's about 2 hours away.
These small return trajectory correction burns.
Houston integrity with that. If you wouldn't mind just giving the rest of the burn execution steps a once-over, we think they all look nominal from here on out, but we'd feel better. Let us know if you see any other deltas. Thank you.
We will run an additional check and call if we find any other problems.
Is Reed a wizard, Hellfish?
Perfect, thanks.
Reed Wiseman posted on February 10th, 2017. This is before he was chief of the astronaut office. This was before any crew was even close to ever being assigned for the Artemis missions. I choose to believe this fortune I received tonight, perhaps the moon or a journey to Mars. A visit to a strange place will bring you new perspective. Are you a wizard? That was, yeah, that's February 10th, 2017. That's before the Artemis program was even a thing.
Such a fantastic view coming from a solar array camera on Orion, looking back at all of us here on Earth.
How did...
Currently, the spacecraft is 227,756 miles away from our home planet. Orion is now 49,168 miles away from the moon. Earlier today, the spacecraft exited the lunar sphere of influence. That's when the pull of gravity is strongest on the spacecraft.
It's magic. My opinion, low Earth orbit docking shouldn't count as an Artemis 3 mission. Ooh, I need to eat something. So it shouldn't count as an Artemis mission? What about Apollo 9? Apollo 9 did the same thing, dude. When is the burn happening? About 2 hours from now? Angry Lisping? Astronauts are going to eat their meal here. Actually, it's a little less than that. They're going to eat their meal here, and then they do the RTC-1 burn. And then there's a developmental flight test objective scheduled for a little bit later in the night. Actually, as they move up on mealtime, I think so am I. Hey, H2, what's up, dude? How much time does SpaceX have to complete the lander? They need an operational lander for the Artemis 3 mission. That's sometime next year. I still think that if Jared was smart, he would bring a lander design in-house, but he's not going to do that. And he is smart, like not... Like,
and Terry Houston, for Christina, we have double-checked all of the steps in the pad for the execution, and we found no more mistakes.
They still have to do an unmanned test landing, Balxy. My theory is that they're going to dock Artemis 3.
You guys rock, thanks.
With HLS and then send it out to the moon.
And Christina, while we've got you, we have increased the fan speed, and we're wondering if you want us to keep it at this level for the next exercise session.
Ellie, that is the Earth, yes. I think NASA should in-house a lander, but that's just my opinion.
We feel it, and yes, please.
We will do that. Thank you.
All right. Guys, I'm gonna take 5 real quick. I'm just gonna go grab something to eat.
Thank you for that.
And yeah, I will be right back. But that's cool. But would that mean a full tank of gas when Artemis 3 visits? No. Refuel it after the mission, Balxy. All right, I'm gonna get some space food. They said couscous. All right, they had couscous, so I'll do that. I'll go make some real quick. I'll be back in a moment.
This is the Artemis Flight Control Room at Johnson Space Center in Houston, Texas. Current flight director is Jeff Radigan, leading all of the teams around the room, monitoring Orion's systems. This is Flight Day 7, following launch on April 1st of Orion atop the Space Launch System spacecraft at Kennedy Space Center in Florida. This live view is coming from Orion, looking back at all of us on Earth, or should I say looking to all of us on Earth, as that is where the spacecraft is headed following yesterday's lunar flyby.
Integrity Houston for the timeline. Integrity Houston for timeline.
Discovery, go at throttle up.
Tranquility Base here.
We're live in Artemis Mission Control, and
Vulcan
you are
salute,
looking at a live
cool
view
baby.
of the Earth from the Orion spacecraft. We are now 5 days, 23 hours, and 39 minutes into the Artemis 2 mission, the first flight of humans aboard Orion. The crew aboard the spacecraft has been working on the targeting plan for the upcoming RTC-1 burn. That's Return Trajectory Correction 1, a fine-tuning maneuver to keep us on a straight and narrow path on the way to the Pacific Ocean.
Integrity Houston, voice check, Orion Earth 1.
We have you loud and clear, Stan.
We have you the same. Did you hear 2 earlier calls for a timeline about 3 minutes ago?
Negative. Go ahead, those calls again.
Okay. We had just tried to get your attention for some timeline things. It looks like there was some uplink going on elsewhere in the system. We're going to chase that down. For the timeline, can you please give us a status on the RHC install and the docking cam install?
Yeah, we're just processing the docking cam install right this moment. Probably be another 2 minutes before it's up. And we're assuming we need to disregard that. And then the RC, we knew it was in the procedure earlier. It's prepped, not quite up yet, but it's in position, so we're good with the RC.
If you're happy, we're happy, and copy the docking cam. Next, at the end of your midday meal, we've got a scheduled flight director crew conference. The vehicle looks great. We don't think we need that conference, and if you agree, we can cancel.
Okay, crew's good up here. We can go ahead and cancel that.
All right, and finally, we saw your intermediate targeting complete successfully, and solution looks good from here.
Okay, we concur, Stan. Appreciate it.
That's it for now. Enjoy your lunch.
We most certainly will enjoy this very rare lunch out in deep space. Okay, Houston, you can go ahead and check the docking tunnel and making sure you're seeing everything you expect in the camera.
Copy, we'll take a look.
We are live in the Artemis Mission Control Room here at Johnson Space Center in Houston, Texas, with a mission elapsed time of 5 days, 23 hours, and 45 minutes into the flight of Orion on Artemis 2, the first flight of humans aboard the Orion spacecraft. We just heard some calls while the teams are planning for the upcoming return trajectory correction burn, and the crew has been given a go to get into their midday meal. Meanwhile, here in the flight control room, I am joined by Trey Perryman. He is the Orion Mission Evaluation Room lead. So thanks for joining us today.
Yeah, good afternoon, Leah.
Tell me a little bit about you and your role.
Sure. During this mission, I'm called the Orion MER lead, the Orion Mission Evaluation Room lead. And so this is a team of engineers, a large team of engineers who have a critical role in the success of this mission. We are responsible for really being the engineering source of knowledge base for the mission. So this is a large team comprised of the engineers who designed, built, assembled this spacecraft, and then processed this with our KSC team members before launch. During the mission itself, we are here in the Mission Control Center, and we provide that expertise to the operational teams, the flight ops team, the launch team, before we lift it off. And my role is to lead this organization, this team of engineers, and then during the mission, report out the findings, the observations we have to our leadership team, to the mission management team and others.
So what's the configuration like in the MER? Is it consoles like this? Are you staffed 24/7? Can you break that down?
Sure, yeah. So the MER itself is really a combination of different functions across the spacecraft.
Monitor off of battery until bedtime.
copy. Acoustic monitor on batteries, and we have checked and are getting good data from the docking camera. Thanks for that work.
Trey knows the rules, that we always let the astronauts talk first.
That's very important. I grew up in, I was telling Leah, I grew up in this room here as a flight controller on the Space Shuttle program and ISS assembly missions, and so I definitely have learned that protocol. So bear with me as I explain this. But up in the MER, this is a collection of focus areas. So we have different, we call them consoles, just like we have in the flight control room here. And these are really representatives of different engineering functions or expertise. And so we have a console, for example, for the power system, for the propulsion systems, flight software, guidance, navigation, control. And so these people are all, they come together in this one place, and they're comprised of different organizations. So NASA, the ESA, the European Space Agency, and our contractors, Lockheed Martin and the Airbus company. So we have a blended team of engineers who participated in the development of this spacecraft, and now its execution.
Well, tell me a little bit about how the MER works with this front room, because I hear calls, on these back loops about checking with the MER on something. So how does what the team does there inform what the team is doing here?
Yeah, that's an excellent question. In the Artemis program, we are really a combination of many teams. And so the operations team, the flight control team here, and then the Orion MER are different teams, and they play a unique and separate role. So the operations team, just to start there, is responsible to execute the mission. And so they fly the spacecraft, they send commands, they work with the astronauts and plan their day and plan the activities on the spacecraft. For the MER team, we're really focused on truly the engineering depth of knowledge. And so we are following the vehicle systems, monitoring the performance of components, of integrated systems together, the whole spacecraft itself, really to understand how the vehicle is performing, understand it against what we were expecting pre-flight, and then to help when there are anomalous conditions. So sometimes there are things that have gone wrong, as others may have noted here for this mission, it's the MER's role to help the ops team through that. So the operators here in the control center will respond to an issue. It'll be the MER's role to find resolution of that issue over time. So they're unique roles, and we talk and compatible, and so we talk with one another through the mission. So our flight controllers here and the MER consoles talk regularly, every day, all through the shifts, about what's going on in the spacecraft components. And then our team upstairs is led by MER managers, so they're responsible for one shift to the next in the MER. This MER supports round the clock, and just as the flight director does in this room. And so our MER managers and the flight directors coordinate as required.
Well, let's talk about preparation a little bit. So I know that we participate in sims here in the flight control team. How does the MER prepare for a mission like this?
Right, very similarly. So the MER team, we're different than flight controllers. And so where the flight controllers, this is their bread and butter, operations is what they do primarily. The engineers in the MER are also very good because they draw upon their day job of designing and understanding, really qualifying the system, testing, evaluating, improving. And so for the MER team, our training really begins with what we do outside of the mission, pre-flight, ahead of time, and in understanding this vehicle, defining what the vehicle will need to do during the missions. And so when it came to really put I think your question is really about how do we actually specifically prepare for this mission. We began in January of last year, and we formed the team and identified who would be on the team, and then participated in dozens of simulations with the launch team out at KSC, and then also here at mini sims with the flight ops team. And so exercising team communication within our own MER team, and also communicating with the flight controllers, communicating with the launch control team. A lot of the simulations we do stress scenarios, which are useful for learning about the systems, but also learning how do we communicate, how do we resolve in a timely manner, how do we understand the condition of the vehicle and make sure that it is ready to continue to fly and successfully return the crew home.
Fantastic. Well, let's talk a little bit about yesterday. So we had Lunar Flyby Day. Yes. What was the energy like in the mission evaluation room?
It was a fun day. So, and a day, I think, full of emotions. I think for many who witnessed yesterday, probably around the world, we all shared similar emotions and feelings about the gravity and the momentous occasion that was. when Jeremy was calling down and spoke about those craters, and naming those two specific craters, I don't think there was a dry eye in the room. I mean, silence. So most of the team upstairs, like here, are wearing headsets, but we had a lot of extra visitors. So we had speakers on, but you can just hear very clearly Jeremy coming through the speakers we had up there. Very impactful. And then as we approached Paralone, the altitude of closest approach to the lunar surface, lots of excitement. Immense joy as we led up to the Earth set before we went into that eclipse period and loss of signal period. Before launch, the crew members came out and visited the MER and talked with us and gave us patches, those double-sided patches that they decided, where one side is a picture of the Earth with the moon in the distance, and then the other side is different with the moon and close up, and then the Earth in the distance. So we did what they had asked us to do, and so at the moment of Paralune, we all had a little ceremony of or activity of flipping the patches, and so immense joy, excitement. It was pretty fun. And then as we knew we would get signal back as Orion continued to fly on the other side of the moon, and we knew we would get comm back with the Earth, intense focus. Really wanted to make sure, what is that vehicle looking like once we got comm back with them.
It sounds like we were going through some similar things in both of these rooms. You know, when the craters were named, it was a moment of silence in here as well. It was very, very touching. And we also have those double-sided patches, and we got to show those yesterday on the broadcast, and we had our own moment of getting to turn those around. So it was a very fun day here as well, and I'm glad to hear that you had that in the MER too. So now that we're through Lunar Flyby, we're officially on the journey home. How do you feel about the rest of this mission and coming down and coming to splashdown?
Yeah, this mission is not over until we get the crew back. So the MER team has extreme focus right now. There are a lot of things that the crew members are doing themselves in the cabin to prepare for this journey home, and we are also watching the spacecraft, and it's really mindful that we are.
Houston for smoke detector.
Uh-oh. Hold on, smoke detector.
I'm looking at it right now, and it looks good. Stan, what's up?
It is showing us a bunch of noise and spikes. We're wondering if something is bumping against it.
Fine.
We were just setting up for a photo in the cabin, but I do not think we have hit it, so that would be abnormal. Christina's checking it. There is one charging cable near it that she's re-anchoring now, but nothing is really in the way of that thing.
All right, copy, Reed. Actually, that's a helpful report. We might have been getting some interference with that cable. We'll keep an eye on it.
We just heard a call from the crew aboard Orion, from the Capcom Stan Love here to the crew aboard Orion about potential signal from the smoke detector, and it may have been interference due to a nearby cable, and the team's going to keep their eye on it, but no alarms here. Trey, we were talking about the journey home now that...
And integrity, we are no longer seeing that noise on the smoke detector, so we're suspecting interference from that cable.
Everything's all right. We're good. They kept the cable too close to the fire alarm, and
interesting. Okay, thank you.
And the noise from the cable, the RF
just what we were
noise from the
hoping to
cable was
hear.
setting off
We were
the
talking about the MER,
alarm.
and now we're on our way home, and the mission is really not over. It's definitely not over until we have the crew back safely. So what's the focus like right there now?
Right, we have a couple of trajectory correction burns coming home, and so the MER team is looking at systems that would be involved in that and the performance of those burns to really make sure we're hitting the right entry interface conditions. I mean, that's really where, for this spacecraft, the rubber meets the road in terms of recovery and returning home. We need to hit that target so that the rest of the spacecraft can go through the Earth's atmosphere, open parachutes, and finally successfully splash down. So the MER team is looking at that. We're worked through a handful of different different anomalous conditions on the spacecraft. I think the crew is doing very hard in the space, working through different things in the spacecraft and their own day, their own schedule. And so we're watching that, but really all eyes towards entry interface.
Well, we're looking forward to seeing them under good main parachutes and splashing down.
Absolutely.
And one last thing, I'm very honored to get to tell this story, but I want to make sure people know that this story goes so far beyond just this room and the crew. And do you have anybody that you want to give a shout out to?
Yeah, so the MER team upstairs in this building, it has we have dozens of people every shift, round the clock. But we have other locations. So we have people, I'd like to say hello to the people outside of this building that support the team that I'm responsible for. So we have dozens of people in Denver at a facility Lockheed Martin has. We have dozens of people outside of Amsterdam in the Netherlands, where the European Space Agency has a similar remote site. So for the people who are there, I'd like to say thank you, because we're drawing upon all of the expertise. And that Artemis expertise is really all over, and I have a lot of different individuals that come to my mind. Too many to mention here right now for a specific shout outs. But to be honest, there are moments in this mission that I will look back and realize the successes we had were really because of the many people and the necessity for us to work together and solve those problems together, which is, I think, largely what Artemis is about. It's really about going to the moon, but it's also about doing so together.
Absolutely. Couldn't have said it better. So the work of thousands of people, and now Artemis 2 going for all humanity.
That's right.
Thank you so much for joining us, sure. Trey, telling us a little bit more about the MER. And I know you have to get back there, so I appreciate your time here today.
Well, thanks, Leah.
Cool. All right, I'm back. I have ingested food. I was gonna make couscous, but I had we had Easter dinner left over, so I had that instead. It was tasty. We had cheesy mac and cheese and sliced ham and asparagus. Yummy. You hear this noise in my sleep now? The hotbox. I have the TV going in my bedroom. With this on it, yeah, that TV's been going for a while now. Much money. Thanks for the raid. You'll be having ham sandwiches all week. Score. Very nice. Not rehydrated shrimp? No, I value my digestive tract. I value my digestive tract. Yeah, I'm actually hearing it in my sleep, dude. Last goal is to get the ship home. There are a couple more developmental flight test objectives for the ride back. Yeah, but Flight 7 today is a relatively quiet day. I don't want to break the toilet, dude. Are we seeing the Earth? That's the Earth, dude. Yeah, crescent Earth when you're this far out, Morm. Just like we get a crescent moon. Yeah, right now Orion integrity is, give me one moment. (371,515 from kilometers from Earth, traveling at 2285 kilometers an hour. That's 230,849 miles, or 1,420 miles an hour. Right now, the crew is eating a meal. They were exercising during the off-duty shift. And then we got the RTC-1 burn, the return trajectory correction burn, which we figured from, we heard from Flight Director Rick Henfling that it is a 1.3 meter a second or feet per second burn, which means it's a 0.35 meter a second burn. So Orion's pretty dang accurate. Yeah, it's definitely speeding up. Yeah, the speed was 990 yesterday at Lunar Transit, Rogue Newbie. Oh, yeah.
Integrity Houston, 2 items. Number 1 for 12.2.2509, orbit burn execution plus X flange heaters are on and prop avionics are configured.
Okay, we copy, Stan.
And unfortunately, we have seen the spikes return in the signal from the smoke detector. Can you check that the cable is still not near it, and also tell us what cable it was? If that was EMI off of that cable, we definitely need to document this.
Stan, thanks for keeping an eye on that. Nothing is near the smoke detector right now. The only cable that was an unconnected HDMI cable that goes from cameras, to the encoder. We are near it right now, like a couple heads are near it, but other than that, we are not seeing anything that would cause spikes of any kind.
So this is PTV exercise. That's a developmental flight test objective. Other than that, I'm not really sure what it is.
All right, copy. Thanks for that information. We're still scratching our heads down here.
Maybe got hit with some radiation. What is the Artemis 3 mission looking like with the moon gate? And how come they are using cryofuel? Sorry, bad typing went fast. What do you mean, how come they're using cryofuel? Every SLS launch has cryogenic fuel. Ghosts. 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 Period, question mark. We never heard anything more about that, Echo T-Cat. So I'm going to assume that it's all right. Yeah, I don't know what Moongate means, Jonas. I'm not really sure what you're talking about. Yeah, maybe binary, yeah. But that's a long flight test objective, dude. Look at PTV exercise off duty. Like, that's a long exercise. Give me 1 sec. Gotta answer a message. You meant gateway, but I heard something about refueling with cryo. The reason why I ask is, shouldn't they be concerned with boil off? Well, yeah, Oni, for sure. Yeah, that's something you got to take into account. But do you think that they would go to do a refueling architecture that with cryogenic propellants and then somehow forget that they boil off? It's like, oh yeah, we successfully refueled. Ah, crap, we forgot it boils off. Damn it! Oh, dude, boil off is a tough problem to solve, but it is solvable. Sure, no problem. Well, a little bit of a problem. But, yeah, why are they using cryofuels for through the lunar landing, I think is what you're trying to ask? Because they're trying to figure out a more sustainable way to get there, dude. Return trajectory correction, Dave. Yeah, you got it. That'd be like forgetting the wire harness. Oh, yeah, there's a reason why that project got canceled. The rapid reusability is where the real problems appear. Yeah. We crossed into the 6-day mark. Mission elapsed time, 6 days. 8 minutes, 23 seconds on the Artemis 2 mission. Right now, the crew is eating lunch. Here, there is a developmental flight test objective here, a DFTO, that doesn't require attitude change of the vehicle. So that's something inside there. But yeah, we got a relatively slow day here, comparatively to the ridiculousness that was yesterday. Flight 7 is kind of a little bit of an easy day. Then it's going to start picking up from here. It's going to really start picking up from here. Or drops over chat. No, I'm not NASA, dude. I'm just a fan channel. NASA didn't think I was cool enough. Do you have a YouTube channel? Yeah, Colby, I sent it to you. It's EJSA1. Or you could just type the same name as my Twitch name into YouTube. I'm streaming on YouTube right now. Actually, the YouTube stream did really good yesterday. I had almost 700 viewers on YouTube yesterday, which is really good. I mean,
We're live in the Artemis Mission Control Room here at Johnson Space Center in...
Do they wait until I try to talk? They must. No, guys, I checked it. We had over 13,000 viewers yesterday. Which is, yeah, that was a lot, man.
3 days, 1 hour, and 8 minutes. We are now 6...
That broke my all-time viewer record. That's the first time I've ever gotten my channel into the 5-figure viewer count, which is pretty sick. Are all the parts for Artemis 3 built? They're for the most part, Silly Moist, yeah, all the parts are made, they just got to put the thing together.
The smoke detector. There are no alarms going off, obviously, on the smoke detector, and the crew sees nothing out of the norm aboard the spacecraft, so teams on the ground are trying to figure out where that interference might be coming from.
That's cool, Pat. Very nice.
It's a little more of a quiet day for the crew after their extremely busy day yesterday during Lunar flyby. They had the opportunity to speak live with the crew living and working on the International Space Station right now, and shortly thereafter conducted the post-lunar flyby conference with our science officer here.
So, Oni, the Artemis 3 mission was changed up in its flight objective probably about 3 weeks ago at this time. The updated Artemis 3 mission is a dock with the lunar landers in low Earth orbit. The Artemis 3 Orion is not going to go to the moon. It's going to go, it's going to go to low Earth orbit and dock with the lunar landers. That's going to happen in 2027. And then the Artemis 4 mission is now the first lunar landing.
Discovery, go at throttle up.
Hey, Ani. 11-month resub. Thank you. Yep. It's going to be very similar to Apollo 9. Is it going to dock with both on the same mission? It depends if both of them are ready, Jim. Which I would argue that 12 months is really not enough to come up with the right mission operations for 1 or 2 landers. But the contingencies, it could do it. Taking it easy today. Stop after RTC1. You look done in. Need A game going into Friday. I think, Foz, that it might be what I do. Yeah. But then again, I don't want to miss anything, so. But yeah, I suppose if it's a relatively easy day for the
Speaking
crew,
of coffee, there are 43 cups of coffee on the spacecraft to help power the Artemis 2 crew. I mentioned tortillas as well. There are 58 tortillas on the spacecraft. Tortillas are often used in place of bread when we're talking about Orion or the International Space Station.
For photo TV.
Go ahead for photo TV.
That's the VOD channel. Here.
Hey, Stan, on PCD2, we threw about 10 images in there in imagery for downlink for Photo TV subfolder. If Photo TV could take a look and hopefully give us a thumbs up, and if not, give us feedback, that would be appreciated.
We will get those down and take a look and get back to you.
Someone got screwed out of a cup of coffee. Tim, what's more likely is that one of those 3 extra cups are extra, you know?
That call from Commander Reed Wiseman down to Capcom Stan Love here in Mission Control Houston about some photos that they are sending down. We continue to get photos from the crew aboard Orion, and you can see all the latest ones on NASA's social media. That is at NASA or at NASA Artemis, and you can also find those at images.nasa.gov. Talking a little bit more about the food on the spacecraft, and tortillas typically being preferred as the essentially bread of choice. Bread has a lot of crumbs, and when in space, those can float pretty much anywhere and get into the ECLIS, the Environmental Control and Life Support Systems. And you do not want anything clogging up your fans for those life support systems, so tortillas are often the preferred, essentially bread of choice. Again, this is a live view from the Orion spacecraft, and you can track Orion at any time by visiting nasa.gov/track-Artemis. That's our ARROW website, which stands for Artemis Real-Time Orbit website. It's a very useful tool telling you exactly how far Orion is away from Earth and the Moon. Currently, the spacecraft is 220,586 miles away from our blue planet, there on your screen.
Ed, do you have 2 YouTube channels? Yeah, Kobe. Yes, I do. The VOD, that's the VODs channel. That is where I post VODs from prior games that didn't make it to YouTube or anything. That channel is kind of redundant at this point, but EJSA1 is the main channel. What did they do after they reclaim the capsule? Do almost a complete teardown? Orion is reusable, Nubius. My theory is that this integrity is going to fly again on Artemis 5. That's just my 2 cents. What do you think about the people who think it's fake? I mean, Deco, I don't, is the short answer. I don't let those people occupy my headspace. If somebody wants to genuinely learn about this stuff, I will teach them. But 90% of the people that come in here and say this is fake, they're just looking for a reaction because they act like they're the only ones that has ever done that. It's really funny. Every single time it's fake. Haha, you're an idiot. It's like, bro, You're acting like somebody didn't do that actually 30 seconds ago, right? Which like I said, those people are really easy to spot. I don't engage with those people. I just ban them. And just boop, bye-bye. Here you go. Because see, here's the thing. Those people like nothing worse than being ignored. So I ignore them. boop, bye-bye. Now, with the other thing is, so like, that's like 90, you know what? I said 90%. I say like that's probably 95% of people that come in here and say stuff like that. The other 5% are people that are looking for a fight. They're people that are looking for a fight. Like some guy came in here a little bit earlier and was like, you know, you believe the Apollo missions happened? How did Richard Nixon call them on a telephone? As you know, implying that we can't hook a telephone up to a radio transmitter, which is... Hey, buddy, you just blowing from Stupid Town? In which case, I didn't say nothing. I just let the guy keep talking. I didn't tell my mods to ban him. He's technically not breaking any rules. So I just let him sit there and talk all this crap, and shit, nobody engaged him in chat. Everybody just kind of went, okay, yeah, that's good. Yeah, that's such a great idea. Here's your gold star. And then eventually he started pissing off my moderators by posting too much, and then we banned him. So, dude, Diego, do I let them occupy my headspace? No. Yeah, yeah, exactly, Predominant. There's like that. Well, that was like the first thing that I said, dude. Yeah, the first thing that I said, like, if somebody's generally like ignorant about this and they want to learn, I'll teach you. It's not, you like. Here's the thing, it's frustrating because, you know, there's the people that like 5 to 10% that I'm talking about, like, they're not stupid. They're just, I don't know. Maybe they go on social media too much or something. Like they're clearly like not an idiot, right? Like, that's what gets me. It's like, dude, you're wasting brain cells on this. Like, it's just, man, that makes me sad, dude. Not sad like, oh my gosh, I can't believe there's so many stupid people out there. I don't believe in that, dude. I believe anybody can be educated, because at the end of the day, dude, rocket science is not that hard to understand. Yes, you heard that right. Rocket science is not hard to understand. It's hard to do. Doing it is the hard part. Anybody can understand it. Look at me. I'm an idiot. I'm a moron. I understand it.
Again, this is Artemis Mission Control at Johnson Space Center.
The concepts here are not that, like, it's easy to rationalize the concept of what's going on. You don't even need to be some mathematician to understand this stuff. I mean, Shake, I don't know. I played a lot of football. Maybe I got hit in the head too many times. You know, like, it's not that hard to understand. Like, the thing about that, like, 5% that gets me isn't that I am being cynical and, you know, like, oh my God, people are so stupid. I believe anybody can be educated. That's fine, you know, like, and learn and actually contribute. What gets me is, like, I don't pity them, but that's kind of the word. You know, I'm just like, that's sad, man. Like, I guess what led you so astray to think that, you know, that this isn't happening? Like, that's what gets me, dude. Like, how you clearly like can articulate sentences. You're not an idiot, right? But yet you know, it's like, oh, lizard people are on the moon or something like that. Like, it that's sad, man. That's sad that, you know, for a certain aggregate percentage, our education system has failed. And that sucks. That makes me sad. Like I said, it's not really pity, right? It's just, yeah, you know, like, these people don't even know how ridiculous they sound. Like, that's why, like, that 5%, I just let them talk. It is sad. They're missing out on the coolest thing ever because somebody and maybe the algorithm took advantage of them. Yeah, Pi, that's it, man. That's it. It's sad, dude. Like, this is something that brings me so much joy to do. And like, don't get me wrong, I don't get triggered when people say like, oh, the space program isn't worth it. I'd be like, dude, I disagree. Like, I'm not going to, like I said, the people that, if they're not breaking any rules, just let them talk. Right? Like, I don't get upset by, unless, like I said, unless it's that 95% of people that are trying to screw with me. Like, that's the vast majority of people. Like, trolls are easy to spot. If you try to, like, I sometimes have to feel it out. Like, if they say something and I'm like, well, I could teach you how to do this. And then, and they're like, well, X equals, or like 2 + 2 = chair. And I'm like, that actually equals 4. I don't think you're right. And then they usually change the subject because they're trying to be funny or trying to show off in front of their friends. Like, I'll beat them logically, I guess, if it's a competition, and they'll be like, oh, well, 2 × 2 = 4. See, like, and I'm like, okay, all right, dude, that's weird. 2 + 2 = fish. I'm like, okay. Like, once again, like that's really it, dude. I don't get annoyed with that like 5% of people. I really don't. They like, first of all, dude, you're making a fool of yourself. Like, that this is a space stream and you are full of people that understand orbital mechanics in here, and you're full of people that actually work out in the industry. This is a stream full of engineers. You are making a fool of yourself. Nah, I get it, internet anonymity. They don't care. Like, I get it, but yeah, genuinely, that is where I'm at. Like, I feel sad. I feel bad for you. Like, I feel bad. Like, maybe in another reality or another timeline, you came into the stream under different circumstances, and, I taught you this stuff, and maybe you want to get maybe they want to get into the industry or something. Like, it's sad, dude. It really, yeah. Like, and once again, it's not out of cynicism or anything. It's just sad. Yeah. When are they going to the sun? Artsy, you need a lot of power to send something even near the sun, dude. I personally discovered that the more I learn, the more I realize I don't know. And that's a sign that you're learning, Rogue Newbie. I am an expert on everything. They like to internalize a different point of view for a bit of excitement, and then they leech off others who make it seem like they have some sort of counter-argument. None of them would have done any thinking for themselves. Like, yeah, Aqualex, and yeah, you guys said it right. Like, it's, these people want to be in the know. They want to feel included, like they know something that everybody else doesn't. So it's very easy to wrap yourself up in it. Like, I mean, I'll be honest with you, like, knowing about spaceflight is pretty damn cool, and you don't need to be some crazy conspiracy theorist to do it, and the spaceflight community is pretty damn tight-knit. Like, everybody knows everybody, like, I don't know, just food for thought. Like, there are plenty of places to go and feel included other than conspiracy theory forums on the internet. I just don't understand why. You've taught me loads. Genuinely, I was talking the other day over the weekend to a friend, and some random dude. What? Some random dude came over and asked me to explain Artemis. Couldn't have done it without the stream. Hell yeah, man. Well, there you go. I'm glad. Like, that's what I'm here for. I'm here to. It really makes me happy knowing that I helped someone in a positive way, And I don't. Once again, I don't ask for money. You could. I'll talk, like you don't need to subscribe. I don't care. That's not what this is about. That's not why I do this. I do this because I want to teach people stuff, and I want to show how worthwhile our space program is. It's so cool, and it's so inspiring. In a sea of nonsense, in a sea of Facebook forums with people talking about lizard people and stuff. Like, we have this. This is a shining
this is space.
beacon.
I'm in space.
Shrammeron, thanks. It's a shining beacon of what we can do when we put our minds to something and come together as a country and, you know, with our partners, obviously, as well, with our international partners. Like, you can't, it's so good. It makes me so damn happy. And I want to tell people, but I want to show you. And, you know, if I can help somebody get off the crap heap, that is just the icing on the cake, dude. It's the icing on the cake. Because you know what, dudes? Like, if you're younger and you're watching this stream, dude, I know what it's like to be like, and you know, I'm not even going to sit here and pretend like I haven't seen this before. Kids are graduating college right now and there's no jobs. There's nothing. It's nothing. And you know what, man? I hear that. I hear that. And I hear that loud and clear. I graduated right into the middle of the Great Recession. I graduated in the summer of 2008. I know that feeling. I know the despair that's with that. It sucks. It's the worst feeling ever. You know, it's terrible. And I wouldn't wish that on anybody. So that's the other reason why I do what I do. I don't, dude, there were times where I was just like, I don't really, you know, when I was young, 22, 23, I don't really know what to do. Like, what do I do here? So I couldn't think of anything because I'm young and naive at the time. And my default was just playing video games all day. Like, that's it. Is it possible to make a dude counter? Dude! Yes. No, I would probably break it, Neo. Yeah, guys, I hear you. I know that ain't fun. It's not fun, and it's not a good place to be up here. You know, what I'm trying to do is teach people that, look, there's other ways to do things. The aerospace industry is there. The aerospace industry is growing like crazy. You know, even if you don't want to get a job in the industry, like, I would try to push people down that path. I do that.
Tranquility Base here. The Eagle has landed.
Just wait until conspiracy theorists find out they are part of a conspiracy to spread misinformation through conspiracy theories.
Congratulations, you just played yourself. So, yeah, I hear you, man. You know, if you're watching this, you don't know what to do. I hear you. Like, at the very least, if you don't want to get a job in the aerospace industry, that's okay. But, you know, at least have something that's like inspirational, something that's good, something that's a good thing. This is a good thing. This is not a bad thing. There's no strings attached. This is a good thing. It's a shining feather in the United States' cap and our international partners now too. We're bringing them along with us as equals. And that's cool, man. That's cool. And I think we need it, to be honest, in a sea of just frick this, frick that guy sucks. No, this guy sucks. Like, dude, I'm tired of that. I'm tired of it. Can we do something good for a change, please? Like, it's just, it feels like the drum of cynicism has been beaten like a freaking marching band drum. I'm so sick of it. Still think if you work hard and focus, there are opportunities. Yeah, but kids they don't know, one man. Nobody's told them where to focus their skills. All right? Nobody's told them that persistence is going to pay off here. Not pull yourself up by your bootstraps or whatever the hell that frickin' means. No. You got to find something and you got to roll with it. Finding something is the hard part. It's almost like capitalism pulls cricks. Losers blame people for their problems. Right? Losers assign blame. That's what happens. If you're young and you're watching this, maybe you want to get into the aerospace industry. Maybe you don't. There are ways to do it. Maybe you want to be inspired by something. Maybe you want to go build buildings or bridges or something. Or just be a plumber. I don't know. Or a space plumber. Right? Like, there are avenues to go through and there are ways to do it. I think kids nowadays just seem overwhelmed because we were told kids were told for the longest time that just go where the money is. Oh, yeah, if you go get a computer engineering degree, you're good to go. You get a computer science degree, you're good. That's not the case anymore. You know, I do what I do here to try and push people down the right path. And it's really sad to see someone that, I mean, they don't even realize it, but by peddling the conspiracy theory nonsense, they don't even realize that they're a lost cause. You don't even realize how much you failed. But like, I think we have failed too, to an extent, you know, like we failed them. And that sucks. That's sad, man. It's really sad. Yeah, Aqualex, I had to unscrew my mind from that for the longest time, too. It's sad, man. So, Devo, or Deco, what do I think about it? Yeah, it's sad. All this, I remember when I was 19, I interned at NASA, and because of the experience and the political climate at the time of the summer 2008, I decided not to pursue going to space. I totally get what you're saying. Yeah. Yeah, man. The flyby images are amazing, Pi Power. Yep. Can they reuse the capsule? Joggy, this is Orion is reusable. It jettisons the service module, this part right here. That part's not reusable, but the capsule itself is reusable. I missed the presser. Was it good? If you wanted to hear Kelsey going off for like an hour, yeah, it was amazing. Yeah, it was fantastic. We actually learned that the toilet actually isn't broken. We suspected it was the toilet vent, and Rick Henfling actually told us, yeah, it's the toilet vent. And I thought it was the heaters for the longest time because they were talking about the heating element. It's actually not the heating element either. Something is reacting with the wastewater in the pipe in a filter somewhere that's clogging the line. It's some type of biological reaction. And he said they're going to take apart the toilet when they get the capsule back, and they'll fix it. The toilet isn't broken. It's the drain that's broken. I mean, I don't know, like, I'm going to still go ahead and guess that it might be the waste heater, but I mean, I'm not going to argue with Rick Henfling. He's the EDL the entry, descent, and landing flight director for this mission. I'm pretty sure he knows more about this than I do. So T-minus, the vent froze, and then they put it in the sun to kind of clean it up, and they cleaned it up, and it's still having some issues. When are they visiting the sun? They're not. This mission is not going to the sun. I mean, Artsy, you remember what I was just saying a second ago about, you know, the people that are trying to screw with me, how it's really easy to detect, and how I ban people that do that, right? Like, were you not listening like 15 minutes ago? Riley, this is not NASA. This is a fan-run channel. I'm EJ. I like space, and I teach people about space. It's going to be around 7 p.m. for the entry, descent, and landing. Anonymous. No, it's all good, Riley. Don't worry about it, man. But yeah, guys, that's why I do what I do. Did I see Jack's Starlink photo? I didn't. They're using the same heat shield design on A2, just different re-entry profile. They're using the same heat shield design as Artemis 1 with a different re-entry profile.
Checking in from Artemis Mission Control here at Johnson Space Center in Houston. We are now a mission elapsed time of 6 days and 36 minutes since the launch of Artemis 2. Our crew members Reed Wiseman, Victor Glover, Christina Cook, and Jeremy Hansen are living and working aboard the spacecraft as the first crew to fly aboard Orion. They're testing all spacecraft systems and conducting other demos to help prepare for future missions to the moon.
Sterndicka, the toilet drain system is not cooperating. That's the waste dump. It's been clogging up. They cleared a device by putting Orion in the sun, and it's still clogging up. They think that Rick Henfling, the flight director at Johnson, said that they think it has something to do with urine reacting with the material element of one of the filters, but they're not going to know until they get the capsule home and get it back. So they're going to have to figure that out later. In the meantime, they basically have to use the bags. Are you planning to make Artemis 2 and KSP as accurate as possible, or did you already? I mean, Garand, I have a capsule that we could use. Excuse me. I have an Orion-esque capsule that we could use. Thank you. Don't they have a toilet auger on board? Yeah, no, just call Roto-Rooter. No, it's whatever is happening is clogging the filter. So, yeah, they can't replace the filter, but yeah. I don't want to talk about that till later, Cooking Fat. Just got home. What has the crew been doing today? It's been a very, very slow day for the crew. This is kind of a recuperation day for the crew. It's been kind of light workload. So yeah, they've done a couple of things here and there, and we are about 45 minutes out from RTC-1, the return trajectory correction, and yeah, we'll see where it goes from there. So in KSP, guys, I have a pretty decent Orion, and I don't have SLS. I haven't made one. I could. I mean, we'd have to figure out a way to make a 5-segment, but yeah, you know what? I'm sure we could get that done. Let me think. We do that. Yeah, I'm sure I could figure it out. What's this 3D model that you have on screen? That's the relative position of the Orion Integrity Capsule. This is the Artemis 2 mission, the first mission that NASA sent people out around the moon since 1972. We're into flight day 7. Mission elapsed time is 6 days, 0 hours, 41 minutes, and 8 seconds. And we're coming up on the return trajectory correction maneuver. If we want to find a relative spot of Orion integrity, you can zoom out here and you can see that it already went out to the moon. It circled around the moon, banged a UE, and came back. Well, it's on its way back. It's flight day 7. It's scheduled to land on flight day 10 over here. Off the coast of San Diego. But it wasn't without the crew taking some amazing pictures of the moon. Taking some amazing pictures of the moon on the way back. Check this out. Now, guys, this mission... Yeah. I don't just look. So this is a shot from this is the eastern hemisphere of the moon. Okay. And over here is the near side. So Earth is this way, right? Earth is this way, right? The solar equatorial plane is going like this. And because it's going like that.
Integrity Houston, 2 minutes to starfield maneuvers, and we have a couple of other words for you.
Because of that, not only do you have the moon with the sun behind it, but you also have Saturn, Mars, and Mercury. And if this shot was a little bit wider, Venus would be right here.
Stan, go ahead, your words.
Earth is that way.
All right, late call SM prop helium ISO valves are configured. The aux branch 1 will remain closed. There is no change to the burn plan or to the pad. However, right after the burn, we're going to change the active burn plan to the plan in slot 4, which is nominal PLS RTC last.
I'm not sure what PLS means. Hey, Urban, thanks for the raid.
Okay, that makes sense. We're expecting that, Stan. Sounds great.
Yeah, and then people always say, like, oh, why can't we see the stars in space? We got to have the right lighting conditions. In the right lighting conditions, you can see everything. Oh, I know what POS is. Point of sale. There's a live shot on board the capsule. That's Earth over there. They're going back towards it right now.
Welcome back. We are still here. They are in space.
And Stan, while we have you, there's a new photo in PAO for downlink on PCD2.
Copy. We'll go look for the photo on PCD2.
That was awesome. Freaking Leah. I knew I liked Leah. That's awesome.
Those communications coming from Commander Reed Wiseman aboard the Orion spacecraft about some photos that I hope to be able to show you soon. The crew's been great about providing us with beautiful imagery.
No, I don't think it's
you can find those images at images.nasa.gov.
I don't think she meant to do that. So look, see, they're reorienting the capsule for the return trajectory correction 1. Here, it's not a very big delta V maneuver, so they're only going to pulse the engine for a second just to make sure that they're on track. When they went around the far side of the moon's gravity, the moon has non-uniform gravitational pull, so it kind of pulled them a little bit in one direction. They're just doing a quick trajectory correction here, just to make sure that Orion is flying on an even keel. Flying on an even keel. Make that a notifier. Welcome back. We are still here. They're still in
And we
space.
are standing by for the return trajectory correction 1 burn, now just 43 minutes away. Again, this is a small maneuver for the spacecraft, firing of those reaction control system thrusters.
Houston Integrity, are we okay for secondary purge line?
Checking.
We had a checking, over.
And Integrity, we are go for secondary line.
The secondary line is the CO2 dump. They have CO2 scrubbers that are pulling CO2 out of the capsule. There it was. Did you see it? Dump. Dump. Toot. Actually, I'm not sure if that was the vent line for the secondary dump CO2 for the vent line, because that was on the service module. Smoke alarm is still being a little funky, but street, but we'll see. We'll see. Is it possible to have an international station style structure orbiting the moon? Two things. That was kind of supposed to be Gateway. Gateway was managed by people that are not good at spacing. Second of all, there was a vehicle that we had that would have been really good to assemble Gateway on orbit. If only, like, we had something where we could, like, go up there and, like, use like some
You're
type
looking at a live
of
view from the
robotic arm
Orion
to like build
spacecraft and a
something?
camera mounted on one of its solar array wings. As you can
That'd be
see,
really
some
nice.
of
Oh, wait,
the
we
light
stopped using
changing
that.
outside of the spacecraft.
The secondary dump is the CCU dump overboard. Yeah.
These cameras are exactly what we used
that's
to
the thing,
observe a
too.
lunar flyby yesterday. And of course, we got some beautiful images down from the crew inside the Orion spacecraft.
Would have been nice, like, but we stopped using the space shuttle, so. Bradley, I see it. Welcome back. We're still here. They're still in space. I'm not saying it couldn't be done someday, though. Couldn't they get rid of the wheeze? That connection noise is the dial tone for Orion. Unless you, I mean, you could get rid of that buzzing noise if you wanted to not know if you were connected to the capsule. Yeah, we want this background noise, that buzz noise. Needs to be returned whenever you're playing Kerbal. Welcome back. We're still here. They're still in space. Sun's coming into view. No, Spartan, NASA canceled Gateway 2 weeks ago. Earth's coming back into view. Hey Taylor, what's going on? How's it going? What's happening? They're doing the return trajectory correction burn here. That's kind of the original position that the capsule was in. Signal handover. The return trajectory should be in about 35 minutes. I'm just not really sure what they're doing with the capsule right now. So the capsule spun this way and then it spun back, which is somebody like kicked the RHC or something. Like, spacewalk to recover the GoPros. There's no airlock on Orion, dude. It's not a signal handover or anything, guys. I'm just wondering why they're slewing the capsule around. Capsule's moving. All right, I'm just taking a stretch break here. They mentioned something about Starfield earlier. Are they doing some star-based navigation? Admiral, there is 2 star trackers, 2 redundant star trackers on board, and then an optical navigation system. So, yeah. Madrid is getting ready for an acquisition of signal. 3LRD. Thank you. I thought this was RTC orientation, Cardin, but you see how it moved back to where Earth is? The capsule kind of did this, and then it kind of turned back up again.
Integrity starfield maneuvers complete.
Okay, that explains that. Those are the starfield maneuvers. Urban, thanks for the raid, man. How are you?
We copy, Stan. Thank you.
Stan, the man with the plan. So what's been your favorite moment of the mission so far? Oh, dude. Huh. So I was really looking forward to the solar eclipse. So once again, the solar equatorial plane is this. So this would be like the sun's equator. It would go left to like top left to bottom right on your screen here. So Earth is up here somewhere in this shot. Okay. Now the sun is obviously behind the moon, and because the sun is behind the moon, you see. You can see the solar corona a lot easier right there. See what I'm talking about? Now, the other cool thing about this is that, you know, you guys know moonlight. Everybody's seen moonlight at some point, like you're out in the middle of the night and light reflecting off of the moon will light up the sky and the ground. And you can kind of see at night because of the light that's being reflected off the moon, right? That's Earth light. Right there. See how the moon seems like the sun is coming up on the moon because you see a terminator line. That terminator line ain't there because of the sun. The sun's behind the moon. That's Earth light right there. How cool is that? When you get this kind of unique scenario here, you can see the profile of topography on the side of the moon. Like, look, you could see mountains right there. You could see craters. You could see impacts. Because you're getting a very unique 2-point light system. There's 2 different sources of light, and that creates a lot of contrast. See how all this stuff is super defined right here? All the craters, superbly defined, because they're being backlit by the sun and side lit by the light from the sun bouncing off of Earth. Pretty cool, huh? Now, another thing is that you could see some constellations from other stars back there. I have an overlay of it somewhere, but the craziest thing about this, and this is probably my favorite, see these 3 bright guys right there? 1, 2, and 3? Those aren't stars. That's Saturn, Mars, and Mercury. Mars is in the center. Mercury's there. Saturn is there. Remember, I said the sun's equatorial plane is going like this. If this shot was any bigger, you'd see Venus right here. So there's somewhere out there, there's a shot of Venus, the moon, Saturn, Mars, and Mercury all in the same shot. Actually, fun fact, if you really, really want to know, take a look. So if you look between Saturn and Mars here, we just enhance. So you see that very dim sucker right there, that thing? That's Neptune. So you could see almost 5 planets in this one picture. That little dim sucker, that's Neptune. It's really far away, so it's not very bright.
Live here
it's
in
about
Mission
halfway
Control
between
Houston,
Saturn
where
and Mars
teams are
in this
continuing
picture.
to monitor the flight of Orion. Coming up on the return trajectory correction burn 1. This is, again, a very short burn. It'll be 1.4 feet per second.
0.35 meters a second.
And that's coming up in about 31 minutes. Before then, the team here on the ground will have a final burn conference with the crew.
So here's some other pictures from the Earth set when they were transiting the far side of the moon. The moon north pole is over here. The south pole is over here. Here's another shot of Earth set with the North Pole oriented on the top here. That quite possibly is one of the coolest pictures I've ever seen. More so because it was taken in my lifetime. Every shot of Earth set or Earth rise that I've seen was taken long before I was born. So that's pretty cool. Can you point out the two newly named craters? Here's a shot of the lunar South Pole. Yeah, sure. I'll show you. I think I have a picture of them here. And here's a shot from the Orion solar array cameras when they were transiting the far side of the moon. You can see the Oriental Basin right there.
If you've been watching throughout the day, you can tell this is a little more of a quiet day for the crew. We are preparing for this burn now coming up in 30 minutes, but the crew had an extremely busy day yesterday and therefore got some time off, especially scheduled for after this burn. The crew woke up at about 10:35 a.m. Central Time, got into their post-sleep period before moving into their daily planning conference, talking with teams on the ground.
Integrity, we see good targeting. Go to burn the onboard. Also, MCC has pulled go for RTC-1. And a reminder, there's a 1 hour forward link LOS right about the time of the burn, so we can watch but not call or command during that period. And correction, we're still assess and go for the burn.
Yeah, done.
Okay,
Crazy.
that sounds good, Stan. Then we'll plan on just closing out 12.2.2509 as per the burn plan, and we'll talk to you on the other side of that burn then, or after that loss of return, or loss of forward.
Roger. Stand by for final go.
This is a shot from the solar array wings of the lunar eclipse shot that you could still see Saturn and Mars right there, but it's behind the panel. You can't see Venus. Actually, unless that's it right there, that might be Venus. There's the same shot. This is the same shot, but I don't know if this is IR or not, but this shot's really cool, and the reason why I kept this one up is because if you squint your eyes, you can see lines. You can see rays coming off the sun. That's part of the solar corona. The area of the sun where ejecta gets pulled back in by the sun's gravitational pull. See the rays? You could just barely see one right there. And over there, and over there, and over there.
And integrity, MCC is go for the burn.
Here's another one. You can see the rays.
Okay, we copy. You're still go. Then we're go up here.
See the rays a lot better. How's that, huh? It's pretty good, man.
Recapping a little bit of those communications between Capcom's Stan Love and the crew aboard the Orion spacecraft, specifically Canadian Space Agency astronaut Jeremy Hansen.
Reed Wiseman.
Ground team confirmed that we are go for the RTC-1 burn, return trajectory correction 1, coming up in 27 minutes. That will be at 7:03 p.m. Central Time. Again, a very small fine-tuning of the spacecraft's trajectory ahead of splashdown, now 3 days and 17 minutes from now.
I know, Aqualex, yeah, same shot.
You also heard Stan Love call about a forward link LOS. That's a loss of signal, and that means that the teams here on the ground won't be able to send signals or communications to Orion or the crew. However, we will still be getting communications and data from the spacecraft. We occasionally have these loss of signal periods. Yesterday, we had our biggest milestone, loss of signal, which was to fly the Orion spacecraft behind the moon when they were unreached from Earth for 40 minutes.
I'll try to find the crater shots here. I think NASA posted it.
But again, recapping the crew's day, they had their daily planning conference with the team, getting a read on any of the spacecraft systems and asking any questions before they started their workday. First thing on their schedule today was the ship-to-ship call with the International Space Station. It was wonderful to hear both voices of the space station crew and the crew aboard Orion talking to each other. We look forward to being able to share that audio paired with video from both crew members at a later date. After that ship-to-ship call, the crew got to talk with the science team here on the ground during the post-lunar flyby conference. This was scheduled specifically for this morning while the flyby was fresh in their memories to get to talk with the science team and answer any outstanding questions that team had following yesterday's flyby. We've continued to release imagery from that flyby period, and they are absolutely remarkable. You can find those on NASA's social media or at images.nasa.gov. Since that post-lunar flyby, it's been a little bit more relaxed for the crew. Christina had some opportunistic science imaging when she was able to take pictures of the Earth and the Moon from the spacecraft's current point. All of the astronauts have also had scheduled time for a private family conference today. That's a PFC. The crew has also, some of the crew members have also completed their exercise for the day and their midday meal. After this RTC-1 burn, again, 7:03 p.m. Central Time, we will have
and integrity looking ahead to the forward link LOS. The ARS is configured for exercise, so Christina can begin during the LOS.
Okay, we understand that, and she will follow the procedure and say facades before she starts.
Thank you. Great words.
Wanted to test out the toilet. It should have just sent up a crap ton of Taco Bell. Well,
part
of me is thinking that they want to do that on purpose.
Astronauts
Some of the
have
food
not
that they've been
exercised yet
eating
today. We'll do that later this afternoon. And not much else on the timeline for the crew today. Again, getting some well-deserved rest following their very busy lunar flyby day.
What are they doing right now? They're getting ready to perform a burn butterfly, the return trajectory correction burn, and then they're going to be in a forward link LOS. How are you? What is the most dangerous part of the whole mission? So, David, out of the entire mission, or, what's left in the mission? The entire mission? Definitely going on the far side of the moon. Transiting the backside of the moon, which was yesterday, crazy. That's insane. Because, dude, no help. On the backside of the moon, they can't contact Earth. There's a moon in the way.
Looking ahead to the crew's timeline tomorrow, flight day 8. Some of the timeline does shift around as this is the first flight of humans on this spacecraft, and we are learning exactly what we need to test while on board.
You don't think reentry is more dangerous? I mean, you will also be out of contact during reentry. That's
to work
probably
with the OX suits, the Orion Crew Survival System suits. We had the crew suit up in those just a couple of days ago, and obviously this is a major part of the mission because the crew launches in these suits as well as splashes down in them. So figuring out how to put them on and take them off in space, especially in the event of any sort of a cabin depressurization in which these suits would become essentially a private spacecraft, allowing the crew to have a breathing environment for 6 days. It's very important to us to best understand how these suits work in that environment. The crew will also have their scheduled exercise tomorrow, and we are tracking a potential manual piloting demonstration. We saw this just a couple of days ago when a couple of the crew members were able to manually control the spacecraft, continuing to teach us about how Orion flies in space.
No, just Livy. The suits can last 6 days. They tested them on the 5th. They tested...
The integrity tank pressures are good for the burn.
Okay, we're about 15 minutes out from the RTC burn. Capcom is capsule communicator. Out of all the places in mission control, Ellie, that's Stan Love.
Integrity copies.
Stan Love, that's this guy. He's a NASA astronaut. He flew on the space shuttle. He is the only one that talks to the crew. It's much easier for the crew when they have one person that they can talk to and one person only. They figured that out in the 60s. Now all the other different stations in mission control. So like mechanical and power operations, ECOM, which is the HVAC systems and life support, science desk, flight director, ground controls, flight dynamics officer. They all talk to the Capcom, and the Capcom is the intermediary between the capsule and the mission controllers. Yeah, biomed as well. Mm-hmm. Yeah, he's the radio man. He keeps cool, makes sense. Don't bullcrap, just talk. Usually in NASA, with NASA, the capsule commander or the capsule communicator is somebody that's flown. Usually it's an astronaut because astronauts know how to talk to other astronauts. So once again, Stan Love is an astronaut. He flew on the STS-122 mission.
Recent calls from the ground to the crew letting them know that we've had good systems checks aboard the spacecraft. Of course, we remain go for that upcoming RTC-1 burn, return trajectory correction 1. These are such small burns that sometimes they are canceled. We did see that on the way out. These were called outbound trajectory correction burns before we got to the moon, and we canceled the first 2 of those. They were just deemed unnecessary due to the current trajectory aboard Orion. We also see that sometimes when our crew members are flying to the International Space Station, will be precise enough that they can forego some of those burns. However, we did opt into the last outbound trajectory correction burn, and we're opting into this return burn as well.
How many space missions can you name the crew from memory? Not many, Cyborg. I have to look them up. I know most of the Apollo missions, most of them. There's a lot of shuttle missions there's 2 shuttle missions where I know the whole crew.
The integrity saws in position for the burn, all brakes set.
Okay, the solar panels are positioned for the return trajectory correction maneuver. Name every orbital mechanic.
Okay, we show the same step.
Hilarious. What do you mean? Are you talking about like...
Capcom Stan Love calling to the crew that all of these solar array wings or saws are in the proper configuration for this return trajectory correction burn. Before we conduct a burn, or even when we conduct exercise, we Place these saws or solar array wings in a locked position so that no loads imparted on them by the thrusters can damage them.
That's cool.
So we are targeting that burn in 16 minutes, but ahead of that, this Artemis 2 mission is a new opportunity to study the moon, but teams are also conducting other scientific experiments, including on the crew themselves. Here's a little more about the science of the mission.
So this is the return trajectory correction. I don't know why
Artemis 2 is our return of humans to the moon, flying around the moon on board Orion. But along with that, we're doing a lot of great science.
One of the exciting things about the Artemis missions to the moon is that science is actually a fundamental pillar of why we explore, why we're going, what we're doing in Artemis.
I think it's incredibly exciting that not only are we testing the vehicle, but we're testing science on board. Science where the astronauts are conducting experiments, science riding along with the astronauts. We have astronauts looking outside the window and really observing the lunar surface.
It will help us understand the deep space environment. It will help us understand how that environment affects our astronauts, our systems, and life in general.
So deep space is a challenge for us because you have to leave Earth's protective magnetic field.
That's pretty close, Waldo, yeah.
The crew members are protected from some of the harmful radiation. Going to the moon, they'll no longer be protected, so they'll have a higher radiation exposure.
Much like Artemis 1, we have so many radiation sensors and detectors that are inside the capsule so that we can fully understand and appreciate the radiation environment for protecting our astronauts. In my hand here, I'm holding a tissue chip model. This is the exact design that's going to be flying alongside the astronauts. We'll be collecting samples from each of the crew members, and we can make these organ chips out of the astronauts themselves. So every crew member will have their own avatar on board, and then upon return, we can evaluate that deep space radiation environment and what that compares to the astronaut themselves. Not only are they going to help change the course of medicine for the astronauts, but revolutionizing that on Earth as well.
We're looking at sleep, we're looking at team dynamics, we're looking at how you interact with the environment. We're also looking at the immune system, so what are the biomarkers? We're using saliva as a method to study hormones and different things in your body that may change during a mission like this. And then finally, how do we function after microgravity, being close to the moon, then returning to Earth?
Which will ultimately help us achieve our goal of getting humans to Mars.
And then on top of that, we have an opportunity to look at the moon from deep space on the far side for the first time in over 50 years.
Having human eyeballs and brains back around the moon is going to unlock a new generation of lunar science discovery. The human eyeball is capable of taking in so much data in just a split second. They'll be able to tackle impact history, volcanic history. They'll be able to look at how the albedo, or kind of the shade and hue of the moon and the color of the moon, can tell us something about how that terrain evolved over time. We're integrating science in ways that have never been integrated into human exploration before. We have a front room mission control flight controller position called the science officer. We have a brand new science back room where it's basically our brain trust of lunar scientists and geologists supporting the crews of the future. And Artemis 2 will allow us to really test how this works so that future missions are really set up for success.
We'll also be deploying some CubeSats. They're small shoebox-sized spacecraft of their own. They're each provided by another country, one of our partners. As they conduct their research, they'll complement what we are doing at the moon with Orion.
It is so incredibly exciting to be a part of this mission.
It has been, really one of the privileges of a lifetime.
I can see the work I'm doing benefit crew members right now and benefit the crew members in the future. So it's incredibly exciting and it's very rewarding.
As this rocket launches humanity off of the Earth, we'll be setting the stage through our science to prepare humanity to leave Earth and explore the solar system.
Understood, Stan.
Inertial measuring unit. I don't know why they showed that B-roll. They're getting up on the RTC-1 maneuver. But yeah, I'll answer stuff in a second. As for naming orbital mechanics...
Live here in the Artemis mission control room, we are 11 minutes away from...
Naming every orbital mechanic, there are 6 defining characteristics of an orbit. Inclination, eccentricity, semi-major axis, inclination, eccentricity, right angle of ascending node, argument of perigee, and time of perigee passage. There, 6 orbital mechanics. Boom, I'm getting my water.
Currently, the Orion spacecraft is maneuvering to its burn attitude.
This isn't a NASA YouTube channel. This is fan run with NASA permission. How do you get the badges? You got to follow the official NASA
Discovery,
Twitch stream.
go at throttle up.
I'm the EJ Twitch stream. But yeah. Imagine if you were limited to 43 cups of coffee. No, you can't make me. No, you can't make me. Cristoforo says YouTube chat's better than Twitch chat. Ooh. Dude, that's borderline like torture. How are we feeling after day 7? It's been really impressive watching how well you've hosted for an entire week. Urban, I'm doing okay. I'm doing all right. Yeah, not doing too bad. I'm starting to get a little tired today for some reason, but I got another cup of coffee. We're good to go. Dude, having the stream on while you're sleeping, not watching me sleep, but having the stream, like having this be live, I have not gotten like a decent night's sleep because dude, it's like, think about it.
This view on your screen is a visualization.
So think about it like this. You start your car outside, you leave your car running and then go to bed, right? Like, you're not going to sleep very well because you know your car is running outside, right? Like, you know your car is run. Like, that's how it's been for Bree and I. Like, and Bree, I'm sorry. That's kind of the reason why I wanted to sleep out here, but yeah. Yeah, that's how it's been for the last couple of days. Yeah, that's Urban. Other than that, I'm doing okay. I have completely, my internal clock is 4 minutes away.
I have time, but that's within our tolerance.
Oh, okay, Bree. Sounds like a dumb idea. Why would you do that? Yeah, I know, right?
Okay. Copy.
So, no, that's the NASA channel, Isaiah. Sorry. Sorry, yeah, I'm waiting for the coffee. I'm sitting there, I'm like, is the machine done? Is the machine done? You guys can't hear it.
Houston integrity. We just want to report what we're seeing here to make sure you're seeing the same thing. So, ox helium isolation valve 1 was closed and inhibited prior to the caution and warning. And then it seemed that when ox helium isolation 2 closed and fuel helium isolation valve 1 closed and were inhibited, that is when the caution and warning started.
Oh, shit. The helium valves on the...
All correct, thank you.
Okay. The helium valves go into the nitrogen tetroxide tank seem to not...
In integrity, we had a branch swap. We thought we had inhibited the fitter. Evidently not. We're still evaluating.
Integrity copies.
Oh, all right. That's a little strange. I'll tell you guys what's going on in a second. But yeah, other than that, Urban, I'm doing okay. I have completely lost track of like what day it is, what time it is. I've completely lost track. Like my internal clock is so screwed right now. I am getting 8 hours of sleep. It's not the best sleep, but yeah, my internal clock is boned. I have no freaking, I don't know what day it is. I don't know what day it is. My brain is completely fried. Like when it comes to like day-night cycle. Like, let me give you an example. For me, right now, it feels like it's 3 in the afternoon. It's not 3 in the afternoon. It's 8 in the afternoon, or 8 at night. Like,
we are now 5 minutes, 28 seconds
screwed.
from the return trajectory correction 1 burn.
Like, it's going to take some time to unscrew this, I guess. But, yeah, 8 in the afternoon. Yeah, Eliana, see what I'm saying? But they seem to have problems with the helium isolation valves on the nitrogen tetroxide side of their propulsion systems. Let's see what happens here. Something like that, likes.
Integrity Houston for prop. After the burn, we'd like the valve reconfig per the procedure, and recall that's been edited so that you won't touch the branch 1 aux. We will have 2 PRUs to recover later. We'll do that after the forward link LOS.
Something's funky with the NTO valves.
Okay, understood. So we will execute the procedure as written with the delta about the aux helium isolation valve 1.
Good words, and the procedure guides you that way.
Is it possible that could become deadly?
Thank you, Stan.
Yes and no, F-35. So first of all, guys, don't panic. I'd have to draw you a fuel diagram of how
now
these systems work.
Now less than 4 minutes until the return trajectory correction 1 burn.
It shouldn't be a big
the
deal.
crew did receive some warnings, or cautions, I should say, about something in the prop system, specifically the PRUs.
Friday, Kev. The end of this week.
These are the pressure regulator units, and those will need to be reset later today. We are going to go into a forward link LOS. That's a loss of signal where we can't send communications or commands to the crew. However, we will still get data and communications from the spacecraft. That forward link LOS will start shortly after the burn, now about 3 minutes away. And the team here in Mission Control Houston remains go for that burn.
Lava, I'll draw you guys a diagram after. I know the fuel system off the top of my head because I'm a loser. Don't worry, I'll explain. The PRU, the pressure regulation valves between the helium tank and the NTO tank, they're 2 fault redundant, and both of them are not cooperating right now. They have the capsule in blowdown mode, which means the residual pressure in the lines can be used to execute the maneuver. All the thruster systems that Orion uses are all dependent on pressure, and as long as there's pressure in the lines, even if it's downstream from your PRU, it'll work. You're not a loser, bro. You're helping all of us. Yeah, I know, Jetty. I like taking myself down a peg or two every once in a while, dude. It's very weird that I would know the fuel diagram off the top of my head, but also, yeah, just in case there's any normies watching.
Now 2 minutes away from the return trajectory correction burn. Again, this is a small burn using the reaction control system thrusters on the Orion spacecraft.
Yeah, power. We'll get it. It's not. F-35. Yeah. I don't want to discuss like how bad this could be or how potentially how good it could be or anything like that. Nerd. Wait, what are my values? I'm very interested in seeing that. I mean, Pi, all right, let's be real. I can give a high-level overview, but I remember the diagrams from the other day. You know, the ones that I showed you. So.
1 minute away from the return trajectory correction burn.
They're doing the return trajectory correction burn, Atlantic. This is just a course correction maneuver. Very routine. Coffee. How much delta V is this burn? You want feet per second or meters per second, Orion?
Standing by for the RTC1 burn.
1.3 feet per second, 0.35 meters a second. It's nothing. It's just going to be a quick pulse of the engine. You do get blown off course on the way out there and the way back, Judo.
We have ignition and 4 good engines and good control.
So they're firing the Apollo, the auxiliary motors, the Apollo. What is it? B4Ds, A4Ds, something like that. I'd have to go look again. All right, everything looked A-okay there.
Integrity preliminary look is a good burn. Still assessing. 40 seconds to LOS.
There's a handover, a 1 hour forward loss of signal.
Okay, Stan, we saw a good burn on board as well.
There was a little bit of a rotation rate. There was a little bit of a rotation rate imparted on the vehicle there. See the Earth moving in the background? I'm not sure if that's intentional.
From the crew that they also saw a good return trajectory correction 1 burn coming at 7:03 p.m. Central Time.
No, they said they would use the auxiliary
coming
thrusters.
from the spacecraft, looking down at the European service module and the solar arrays.
That was a little weird. There's your loss of signal. They have about an hour loss of signal because of terrain obstructions in the Deep Space Network antennas. They can receive signal. Yeah, see, auxiliary. But once again, look, she's rotating. That could just be them reorienting into bias XSI configuration post-burn. In fact, that's probably what it is. But I did notice that the auxiliary thrusters did impart rotation onto the vehicle. I'm not sure if it's supposed to do that, but that was always planned to use. This was always planned to use the aux thrusters. Yeah, Pi, but they picked up a rotation rate from it, from a translation maneuver. Did you see the RCS firing? The reaction control system's fired, and it put a roll into it. That's what I'm wondering. I know about the auxiliary thrusters. I knew it was using the aux thrusters. Yeah, they heat shield towards the sun. Yeah. That's bias XSI for sure. You could tell because of the sun. Crew will say something. So the crew can, they're in a configuration with the Deep Space Network where they can hear what the crew is saying, but they can't transmit back. The reason why is because the Deep Space Network, the antennas can only be so low on the horizon for the Deep Space Network. If they tried to broadcast too low, they'll microwave a building. Yeah. Yeah, not great. Yep. Educated guess says that's unrelated to the ISO valve issues. I would suspect yes. So they're in a forward link LOS, so they can still see the capsule, And the capsule can talk to them, but they can't talk back just for a second. So let's fill a building with popcorn. Yeah, Weird Science style. Or not Weird Science. Real Genius. No. What's the name of that movie with Val Kilmer in it? Why am I forgetting that? Dude, that's how you know I'm really tired. I can't remember movie references. Real Genius. That's it. Dude, but like the fact that I'm second guessing myself. Yeah. Real Genius. Yeah, there you go. Also, rip Val Kilmer. That was good stuff. So, okay, ISO pressure valve or pressure regulators. Pi, what do they call them? PLVs. Give me 1 sec. I need to just check something. Can't they go faster?
Again, we just conducted the RTC-1 burn. That's return
Evie, the Earth will
trajectory
pull them
correction
in.
1.
They'll go faster. Don't worry. They're accelerating right now. Watch, the speed will
That
go
came
up.
right on time at 7:03 p.m. Central
PRU.
Time, and then we entered a forward link LOS, or loss of signal. That means that we cannot send communications to the spacecraft right now, but we can still get data from them.
All right, so the first thing I'll explain is the forward link. All right, so
Again, a very quiet day for the rest of the day for this crew. They will have some opportunity to exercise. There will be another private family conference. And that's about it before the crew steps into their private medical conference, or PMC, before they get to sleep tonight. We schedule these private medical conferences occasionally throughout a flight, so we can have them check in with the teams here on the ground and report how they are feeling while in space.
All right, so a forward loss of signal works like this. All right, the capsule is out here. Here's Orion. It's just out there doing its thing with its... All right. Now Orion has phased array antennas on it, so it can be kind of oriented in every direction. Now over here on Earth, just chilling. Dang, that is a sweet Earth, you might say. There's a deep space network in California. There's one in Australia, and there's one in Spain. All right, so this is the North Pole right there. All right, cool, sweet. Everybody's on the same page. All right, when the deep space network is communicating with Orion, boom, you get a signal, right? But if it's rotating and you're in a position like this, right, which is where they are right now between Australia and Spain, right, there is a downlink. Orion can see them, right? But if you look at this spot right here, round, negative. If you look at this spot right here, right, let's just get a little bit of a bigger picture here. This deep space network has a couple of hills, right? And the radar dish, or the antenna, is right here, like that, right? Right? It's like that. So it's very low on the horizon. It has a low azimuth. Or it's no, not a low azimuth, low degrees. Like the antenna can rotate back and forth, like it can look up and go down. But when you're low on the horizon with the antenna, they can receive from Orion. That's no problem. But if they tried to transmit, like say there was a little, like a village or a city right here, you'd absolutely obliterate that with microwaves. Remember, that's a signal that's powerful enough to go 200,000. It's 250,000 miles up, all right, or 400,000 kilometers that way. I mean, they're a little closer now. If you tried to send that through a building, you would absolutely microwave everyone inside. Don't want to do that. So that's what a forward loss of signal is, where they can receive, but they're in a position where both Australia and Spain are in low azimuth or low degree positions, so they can't transmit.
Houston integrity, RHC stow is complete, and we're proceeding through the prop valve reconfiguration with your comments in mind.
They can't respond, but they can hear them. They won't respond, right? So like you'd hear Houston say, "Oh yeah, Roger, mission control." No, they can't reply. Now I know what people are saying. Okay, put it on top of a mountain. No, bad idea. What do you see on top of mountains? Particularly for communication purposes. What do you see? Cell towers. Cell towers, antennas, all kinds of arrays. If you put your deep space network up on top of a hill, right, it's going to intercept all of that crap. There's too much RF interference. So all the deep space tracking stations are in a valley. They're in a valley on purpose. Rocks! I mean, those two, you're not wrong, right? So all the DSNs are in a valley. I've been reading about this since we started the stream the other day. I've been reading a lot about this because I knew this question would come up again. Open to weather too, correct. Caps are not supposed to be on. You know what, Brent? It was funnier that it was. Rocks! You know, like... EJ, I wish I had you to narrate the technical parts of my life. See, guys, listen. John needs about two joints to get out of bed. Once he's completed that, he'll start the roll out of bed maneuver. Dude, hey, you know what, man? There was a time a long time ago where I was good at what I was doing. Like, this was probably like 2017, 2018 when I was streaming. I was good at what I was doing, but I wasn't really disciplined enough. All right? Like, discipline is is your hedge against persistence. If you do the same thing every day, like not the same thing every day. That's the definition of insanity. You do the same routine every day, right? You'll build up good habits. You build up good habits. It makes you easier to take on the world. Makes it easier to take on the world, you know, so to speak. You got to take the bull by the horns, you know. It's a metaphor for how I live my life. But that actually happened, you know. No, that's dodgeball. So, John, you know what's funny, dude? Like, during that time where I really, really wanted to get it right, and I really, really wanted to learn it, I would have...
This is Artemis Mission Control. Again, we are in a temporary loss of signal.
Yeah, we know that. I already explained that, Leah. Jeez. I had, like, Jocko Willink narrate my life. He's like, okay, now you're going to get out of bed. Now you're going to go in there and you're going to take a shower. Now you're going to go attack that. And now you're going to go make your freaking bed. And I'm like, all right, cool. It works. It worked to start building a habit. I don't do that anymore, but it's funny you mentioned like having somebody narrate your life. I definitely did that. Dude, it works. And now, like, actually building discipline is really nice, to be honest with you. You build it up and you can pick and choose what you care about. I care a lot about space, so I'm disciplined enough to just care about space. It's great. So it's funny that you mentioned that, but yeah, so the DSN you don't want to put it on top of a hill. That's no good. It has to be in a valley. It has to be in a quiet zone where, you know, cell signals and stuff won't intercept it. And simultaneously, they don't want to transmit, so, you know, Joe Schmo on his cell phone, you know, goes to make a call and gets zapped by a death ray. You know what I mean? We are still here. They are in space. Yeah. Dude, even the smell of coffee. Now I'm good. It seems to me that if the goal of these missions is to really become more common, we need DSN satellites in order to retransmit. Oh, yeah, we need this thing that requires a lot of power. Let's just throw it into space, Yarg. Sure. Bro, you know the big DSN antennas are 70 meter, right? Like, yeah, let's just take this thing that can transmit across an entire solar system that needs a lot of power. Yeah, let's put that into space. What's the transmit power? 20 on the upgraded dishes, Lava. I believe it's 20 kilowatts, which is bananas. That is some death ray stuff, dude. If you pointed that at something, it would just bye-bye. I mean, yes, I want that. All right, cool. Couple them to nuclear reactors, and then we ball. Yes, but you wouldn't need that much power to transmit to Orion around the moon. Okay. They're working on localized positioning satellites that they can bounce off the DSN. Intuitive Machines is working on fixing this forward LOS problem. NASA is working on a lunar relay network with Intuitive Machines, if you really want to know. The SIGINT antennas the NSA has are over 100. I don't know nothing about that, dude. I have no idea what you mean. I don't know what you're talking about. They launch in 5-meter fairings. How could they be 100 meters wide?
Get final confirmation of that return trajectory correction 1 burn being a successful burn, and it ended up being 1.6.
I don't know nothing about that. I don't recall these events at this time.
We are in a forward link LOS, or loss of signal, and the crew aboard the Orion spacecraft is, Christina Cook specifically, is going to get into some exercise. Again, this is a quiet day for the crew, as they had a very busy day yesterday and have some busy days coming up as well.
Was the Arecibo Observatory part of the DSN? No, that was part of SETI. The point is, guys, is like, it's not as simple as just launch the thing up there. Now, Yarg, do I disagree with you? No. That'd be cool to see a 70-meter antenna just, you know, messing around in space. If we had that, which we totally don't. That'd be really cool. It'd be even cooler if said antenna that we didn't have, you know, would be pointed not at the ground and out into space. That would be really useful. How about a space elevator all the way to the moon? Hilarious, you're going to build a 250,000 mile long elevator? Question? Hams can bounce signals off the moon with less than 1 kilowatt. Yeah, guys, NASA's working on it. It would be on a track. All right. That's good to know. Yeah, no, you should do that, dude. You should do that. Hilarious, you saw when I labeled 6 orbital mechanics for you, right? Right? Were you here? Did you hear that? I did it. I did it, dog. Was there testing of laser communications on this mission? Yes. Yeah. Desmonio, yeah, they did. They tested the laser. They've been testing the laser comm every night because of power consumption needs while the crew is asleep. I believe, Flight Director Rick Henling in the press conference said that they moved, what was it, guys, 20 gigabytes of data? They moved 20 gigs in 45 minutes. That's pretty good considering there's no connection there. There's no landline connection, right? Like, that's 20 gigabytes in 45 minutes. What is that? That's above 50 megabits per second. That's pretty good. That's a good connection. You could stream in 4K from that thing. But they are testing it. But it does work. That gave us these pictures. It's power, Yarg. Power is that is your constraint here. The OPCOM is just a tech demonstrator. I mean, it's a pretty damn good connection considering you're out at the moon. That one's pretty good. When was the DSN built? Domingo, the DSN was built for the Apollo program, dude. Yeah. It's been upgraded since, but it was built for the Apollo program. I gotta head out for now. I'll be back later. Oh, Pi, I didn't even get to draw the fuel. The fuel thing. All right, whatever. Bye. See you later. Yeah, we'll figure out what's wrong with those the pressure regulators in a moment. You can stick around for a few minutes. Yeah, guys, the other thing is that they were having problems with their helium isolation valves. So, give me 1 second. So I can give you a high-level overview of how Orion systems work, at least to an extent, guys. So Orion's propulsion systems are tied to a couple of different thrusters. So you have your service, let's say you have your service module here, right? And then, you know, right, and then your capsule's over here. Right, and then you got your solar panels here, 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 and here. So how this works is you have your main thruster, that's a shuttle orbiter maneuvering system engine. It's an AJ-10190. And then you have 2 sets of thrusters there, 2 sets of thrusters there, 2 sets of thrusters there, 2 sets of thrusters there. Now simultaneously here you have thruster blocks up here. Those thruster blocks have 2 sets of thrusters going this way, 2 sets of thrusters going that way. And then you have another thruster block here with 2 sets of thrusters going left and right. Those ones go forward and back. Okay. So every single one of those thrusters, right, is a pressure-fed hypergolic system. So how does a pressure, oh man, my mouse got stuck. Pressure-fed hypergolic system. All right. So a little bit of kind of understanding what this means. Pressure fed, meaning you're using a pressurant to pressurize hypergolic liquid fuel and oxidizer. What does hypergolic mean? Hypergolic means that when the liquid fuel and oxidizer, when they touch each other, they blow up. They do this with they use hypergols on a lot of spacecraft because it's simple. You hit the oxidizer and the oxidizer and the liquid fuel together. When they chemically combine, they explode. That makes each one of those engines, very, very, very simple. I want to draw Orion's little windows there. Let's draw the little windows. Yay. Yay, windows. All right, so draw these little thrusters here too. Yeah, you know, just draw the little thrusters. Yeah, just draw them. Just draw the little thrusters. Yeah, just happy little thrusters, just thrusting along. They're just doing their thing. And then you draw your nice little solar panels there. You got to generate power somehow. You just have your happy little solar panels. Yeah, look at that. We're generating power. Look at us. We're generating. That's great. All right, where is the toilet? I'll show you that later. Bob, you aren't. Socks. Socks. There we go. All right. Anyway, so hypergolic means what?
We are live in the Artemis Mission Control Room here at Johnson Space Center in Houston, Texas. We are in a forward link LOS, loss of signal, with the Orion spacecraft. Forward link meaning that we are not able to send commands here from the ground, but we can still receive data from the crew. We are using the Deep Space Network for this mission, being that we are so far from the Earth, and these LOSs, or loss of signal periods, are tracked.
Thank you, Liam.
We're currently 54,082 miles away from the moon. That's almost 50,000 more miles than our closest approach yesterday during
50,000 miles used to live here. Now it's a moon base. All right, so back over here real quick. So the hypergolic fuels, right? The hypergolic fuels that Orion uses is nitrogen tetroxide, or NTO for short. That's your oxidizer. And then MMH, monomethylhydrazine. If those sound like chemicals that will kill you if you get near them, yes, that's right. Yeah, that's correct. Good for you. My childhood. Captain, your 3D artist is showing. Might want to cover it up. Oh, sorry. So, when nitrogen tetroxide and MMH and monomethylhydrazine, when they hit each other, they pop. This makes it so the engines are very, 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 very easy to ignite. All these rocket engines on here, from your RCS, your reaction control thrusters, so your thrusters that control yaw, pitch, and roll, your thrusters that are your auxiliary fine-tune adjustment thrusters, the A4D thrusters, or the AJ10190, how the high-level overview of how all of this stuff works is like this. Okay? You got your little happy little rocket engine right here. This is what's called a De Laval style nozzle, combustion chamber and nozzle. It's very straightforward. You have the place where the rocket fuel blows up, right? That's your combustion chamber. This is the throat, right? And this is your nozzle. Okay, these hypergolic engines are very simple. There's an injector here, and there's an injector here. That's it. That's all, right? This one has NTO, and this one has MMH. They use an electrical signal, or they might use pneumatics. It really depends, right? To actuate these, they spray out, boom, you get a rocket engine, right? That's how most of those engines work. So, in order for this to work correctly, you need a pressurant. Because if it's just an injector, the injector needs a back pressure. If it doesn't have a back pressure, you're going to have a problem. All right? So, how this works is they use helium. All right? You have 2 helium tanks, primarily, right? Hey, Ultrasaurus, what's going on? You've been killing it with the Artemis mission. I had so many people come and tell me how they've been enjoying your coverage. Oh, well, thank you. I appreciate that. 4-month resub. Thank you very much. I'm starting to get a little tired. I'm starting to have to drink coffee I was about to say in the afternoon. It's not the afternoon. It's 8:30 at night. My brain is fried from doing this so much, but I'm good. I'll be all right. I'll be fine. Hypergolic, pressure-fed hypergolic engines in the application of long-duration spaceflight. Let's go! Let's go! You know. All right. So, you have your helium tanks, right? And then you have, let's just say the other tanks look like this, right? This one is NTO, right? This one is MMH. Okay? How this works is the NTO and the MMH tanks have a cavity in between the outer pressure wall of the tank, right, and the fuel that's inside. The fuel and oxidizer are inside of fuel bladders. They're called fuel bladders. Okay? So, the helium goes through a line that goes in to the bladder, and it squeezes it. Don't squeeze your bladder, okay? Unless it's a fuel bladder, in which case it's okay. All right? So, these, let's just do a very high-level overview. Those lead to your rocket engine, like I was saying. Right? You have your injectors. Right? But in order for the injectors to work, you need to make pressure. So the helium goes into the NTO tank, and the NTO tank, the fuel bladder becomes pressurized, and the bladder is connected to the outbound lines, and then the outbound lines go to the rocket engine, right? I'll just draw the flow here, right? Thing at the bottom. I saw it somewhere. No. Why would it look like that? So the valves that they're having trouble with are here. There's a pressure regulator valve here and here. Those are those PRUs that they keep talking about. PRU. You have your MMH PRU and your NTO PRUs. Okay? Now, Orion has 2 fault redundancy, so there's 2 of them. Okay, there's 2 PRUs. There's one there and there's one there. The other side has the same deal, right? You can't unsee it. Bro, it's not even the right angle. What are you talking about? Anyway, so these pressure regulator units, one of them broke. It broke on flight day 2. It was out. It was out during Victor's manual pilot demonstrations. The second one is causing problems. Second one had an issue right there. Now, so if that had an issue, how did they do their maneuvers, right? How did they do that? They had pressure already in the lines. Basically, the bladder tank was already squeezed. This is called ullage pressure, or what did they call it? Blowdown pressure, right? So they already had pressure built up in the tank, so they didn't need the PRU to fire the rocket engines to do that burn, right? They didn't need to do that. So the PRU was causing problems, but they don't know. I bet you they're trying to figure it out, and that's why we haven't really heard anything. But they're still in that forward link LOS, so we have to. Excuse me for a second. We have to get back to it. Let me just get rid of this. Give me 1 second. There we go. Spade. Perfect. What? Pretty sure you can make the eraser bigger. Can you? I don't know. It's paint. Maybe, oh, yeah. Hold on. I got to finish my Orion diagram. There. Perfect. Any idea what they would do if they didn't have enough reserve pressure left for their burn? I mean, Pie Guy, if I was doing fault tree analysis on this, I would try to figure out why that thing is doing that. Art, final, _ final2.png. Art. Yes. Backwards R. Yes. Orosho. Dude, that's a shirt to go with truck. Brimo's idea, not mine. Oh, yay. Orion has its own thrusters that could do it at this point. The roll control thrusters? Roll control thrusters don't get armed until the service module is jettisoned. Is it cold in space? No, space is nothing. I think I stole it from someone in chat. Okay. Do you think they could use Victor as a backup PRU? No. So the second one, they weren't getting actuation from the second one, if I heard that correctly. So fault tree analysis, I would Yeah, I mean, I don't even know. Like, these systems either work or they don't. Like, that's a tough one. Could venting the urine bags be a means of propulsion? They could be able to use the remaining ullage pressure in the bladder tank to do this, guys. You might not need any more. You don't need to do much more trajectory corrections. Honestly, like, if you can't get it working, it's not the end of the world. It's just, if anything perturbs your orbit from now until entry interface on Friday, you might be coming down not exactly where you want, but you'll still come down. They did do the RTC-1 bird blazing. There's RTC-2 and RTC-3 scheduled for the next 2 days. And those birds are contingencies. They're just in case they're off course. They might not be off course. They might not have to worry about it. But that doesn't mean that this behavior shouldn't be understood, because you have another Orion teed up. This is Orion serial number 3. You have Orion serial number 4 with the 4th European service module. You got to figure out why that's doing that. But it's on a component of the ship that you're not getting back. So this is something that we kind of got to figure this out. I hate reposting things multiple times, but here we go. Then don't. Boom. Get Ricardo'd. Get space Ricardo'd, idiot. They said they had enough pressure in the tanks to get home already and didn't need to add any more. They skipped the second burn. No, those were the outbound trajectory correction burns, Charles. This is the inbound trajectory. So that was on the way out. Now we've looped around the moon. Now we're on the way back. There's still 2 more burns. For the engine pressurization, those Capri Sun packs full of cancer and death, but when they cross the streams, it goes boom and pushes the ship the other way. You made it a thing to retype that and then show it to me. And you were like, yeah, he'll find this funny. Do you work for NASA? No, T-dubs, I'm self-taught. I didn't retype the whole thing. In the press conference, they said they had enough and they didn't need the PRU to work. This was the press conference from today. Would you like to? If they needed me, Tiny Frank, I would, sure. Not sure what I would be able to contribute to, but I'd definitely help. Bro, if NASA was like, yo, be the janitor tomorrow, I'd be like, bro, you're going to have the cleanest toilet you could find. You know what I mean? Sorry, Vin. I've been lying to you for 15 years. I'd guess there's probably some way to bleed oxidizer pressure from the fuel tank lines if they needed to. Well, Pie Guy, here's the thing. You have a valve and you have your pressure regulator. What I'm really wondering is if are those 2 different things? Are those 2 different systems, or is it combined into one unit? I'd have to go look at the plumbing for Orion.
This is Artemis Mission Control. The Orbit 1 team is currently on console, led by NASA Director Jeff Radigan. The Orbit 2 team is starting to filter into the room. This will be the team that...
Integrity, we're just calling in the blind to keep you synced up with us. We have 2 points we'd like to make. We'll give you a second.
Hold on. Let's listen.
All right, the first point in 12.2.2509, when we got to the property configuration, as you are seeing, our ox helium isolation valve 2 and our fuel helium isolation valve 1 are inhibited, and so we left those closed. And of course, ox helium isolation valve 1 is also closed. And we're going to leave them in that config until we get 2-way comm back with you. And I've got one more item with you.
So both the valves are closed. Did you hear that? Helium isolation valves, they're both closed.
Item is, we've talked it over as a crew, and based on the recommendations in the daily summary, if we did end up in an off-nominal situation where we absolutely needed prop, we would go ahead and open ox-helium isolation valve 1. That's all we got for you. We'll talk to you when you have both forward and return.
So 1 seems to be the one that's screwed up. Yeah, exactly, Andrew. Yeah. So that was. So both of those redundant valves that I was talking about, so the 2-fault redundant valves, both of them are closed. So they have no helium pressure for their NTO tanks at this time. Jeremy just said that the vehicle's in that configuration, and they're going to leave it there until they get that reacquisition of signal. Yeah, Stan Love, exactly. Stan Love's on the at the Capcom desk. He nodded, and Jeff Radigan agreed with him. So that's fine. That's good. Jeremy said that if they...
Those calls from the crew, specifically Canadian Space Agency.
Jeremy said that if there was something wrong, they will open they would open PRU-1 to try and get actuation. There's not necessarily anything wrong. Nothing should be blowing them off course right now like crazy. Like nothing's going to blow them crazy off course. It's just a contingency, guys. Part of spaceflight is it's like a game of chess. You kind of, in chess, you got to kind of predict what the other guy's going to do before they do it. You think 3 or 4 moves down, 3 or 4 moves past, right? You do that with spaceflight too. You come up with contingencies. Like, okay, if they move that chess piece there, I'm going to move this piece there. But if I move that piece there, they're going to move this piece there. What do I do then? Okay, I move that piece there, and then they're going to move that piece. It's a contingency. I thought they couldn't send messages from the forward LOS. Ender, a forward LOS means that mission control can receive. Integrity can broadcast to mission control. Control can't broadcast back to integrity. The reason why is because they're in a spot where at 2 deep space tracking stations where the antennas are low on the horizon. You can't broadcast low on the horizon because you don't want to microwave somebody that's walking near the dish. Can I post a YouTube link? I found where Debbie Korth said we have enough in the tanks for the remaining burns. Yeah, Charles, go ahead. I need to hear it. That's not what I heard, but I'm kind of like half asleep, so. No, that was Jeremy Hansen broadcasting back. He said he's broadcasting in the blind. He knows they're not going to respond because they're in that forward loss of signal. Do you think they could put a crossfeed line on both sets of valves for extra redundancy? You want to add redundancy to your redundancy? So Scott, yeah, sure, of course you could do that, but that basically means you're expecting your valves to fail. At exactly 40 minutes in this VOD. All right, let me listen.
Hi, thank you so much. I think this question is for Debbie. I wanted to check back in about that isolated helium feed that was brought up yesterday. Just wanted to make sure that second line is still holding up okay. And I think I was a little confused about the answer that was given on the redundancy of that system if the second helium feed that's being used right now goes down. What did it mean that you don't need to regulate? I'm just wondering if I could get some more clarity on that. Thanks so much.
Sure, yeah. So as mentioned yesterday, I believe we did isolate one branch of our MON line as a part of the SM prop system. And we have not exactly determined what is...
So one thing real quick, they're using MON. MON is a different type of hypergolic oxidizer. They're using MON 25, not NTO. Just on a side note.
Happening there, we saw a little bit of pressure rise, which was higher than, or not in family with what we had seen in previous testing, and so we isolated that branch. The secondary branch is completely redundant and is completely operable right now, so we have no concerns about being able to operate the prop system. The remaining burns that we have actually don't require the helium pressurization into the MON system tank. The MON system tank is now holding an amount of helium that it already needs. It, backfilled the prop it already used up with the helium, so it's already primed and be ready to go for the remaining burns that we would need. If we did have an issue on that branch, we can always go back to the other branch. Using the other branch is not precluded just because of this item that we saw, this feature. We just decided to isolate that one and use the from a health perspective, use the healthiest branch for any remaining burns. Those burns are really small. I'm sure Judd could speak more to what we have left to do, but that's why we said we don't need the helium pressurization anymore, because the MON tank already has the pressure in it that it needs to execute the remaining burns with, I think, 4 to 5 times more than we would actually need based on the predicted burns.
Yeah, I'll add, so the trajectory corrections that we have, we skipped the first 2. We got 4 planned remaining. Each one of those we budgeted maybe 30 seconds or so for, and we're really only seeing we only need, probably 10 seconds at most. And so we've got plenty of
This is Mission
Okay.
Control Houston,
I heard what I wanted to
specifically
hear,
the
Charles.
Artemis
Good-
Flight Control
good catch.
Room. Now a mission elapsed time of 6 days, 2 hours, and 13 minutes into the flight of Artemis 2. We are in a forward link LOS, meaning we cannot contact the crew right now or send commands, but we have good data from them. We expect to regain communications from this side
Oh, nice, Emma.
in
That's
about
cool.
13 minutes.
Yeah. Okay. So that means they have enough pressure in the bladder tanks for
We
for
were
all the
monitoring
burns.
some prop cautions for these.
So yeah, that's not that big of a deal, but they'll have yeah. So people are asking in YouTube chat, is this going to be an issue? No, it's not an issue. However, guys, it's a test flight. It's a test flight. Remember, this is a test. This test flight, the way that NASA does their testing, guys, it's not like SpaceX. It's not like using the scientific method. All right, let's put this thing out, fly it. We think it's going to do this. Does it do it? Oh no, it didn't do it. All right, okay, it didn't do that. All right, let's try it again. That's not the type of testing that NASA does. NASA's testing is much more in line with a final exam for a course, for like a college course or a high school course. It's a final exam. You don't want any surprises. You don't want any surprises at all. Nothing like that. You want to get 100% on the test. So your ISO valves on your helium side of your MON 25 oxidizer here is not. That's not good behavior for this test flight. That's if we're using our final exam analogy, that's getting a couple of answers wrong. And you really want to you really want to make sure, okay, Hellfish, I'm not sure how that's relevant, but that's cool. That is cool. That's a cool UI. I have that one up over there. You'd really want to figure out why that's doing that sooner rather than later, because that's deviant engineering. There's something wrong there. Yeah, it's not going to affect this mission, but you don't know if that's going to affect another one. So I would still be doing a fault tree analysis here. Yeah, exactly, Tillerius. Yeah, you got it. In a future scenario, you might not have the blowdown pressure. You might not. And you don't want to leave any stone unturned in a test flight like this. I'd be very curious to see what they think is a good idea. Exactly. Tillerius, spaceflight, Murphy's Law, dude. If you just kind of let it be, it's going to go wrong. Right? Can you explain what happened? I just got back from class. Give me 1 second. So Brian, they're having some trouble with the oxidizer side of their pressure-fed thrusters. It's not really It's not mission critical, but it is anomalous behavior from Orion. It's not really going to affect the outcome of this mission from what I can tell. But you don't want any surprises with this, right? We should be in a forward link LOS for probably another 10 to 15 minutes. We'll figure out what mission control says in a moment. Yeah, you don't want your thrusters acting up, that's for sure. Hang on one sec. Let me look at something. Sorry, Lockheed. I'm about to go snooping on your displays. Crap. They don't have it open on the center display there. Sweet picture of Jeremy, though. Let me see if I can find another one. Oh, here we go. Oh. Dude, the mood lighting in Orion is fantastic, though. How long can loss of signals be? This was an hour forward loss of signal. Now, to be fair, they're not in a blackout. They still have the downlink from Madrid. They still have the downlink, but you see how it says 9 degrees on the antennas right there? The antennas can only broadcast up to 10 degrees. Like you can't transmit unless your elevation is above 10 degrees. At least I think it was 10 degrees. I'm pretty sure that's what Boreal was telling me. So we're close to a reacquisition of signal here. The dish is slowly tilting up because it has a downlink. So the crew, Integrity, can talk to the ground, but there's no up. See how you have an up over here on the DSN? You have an uplink. We don't have an uplink with Orion right now. The reason why they can't transmit when the antenna is close to the ground. If there's like a skyscraper or an airplane flying around, right, you are going to zap the snot out of that thing, right? These dishes are very powerful antennas. You don't want to go and microwave some guy flying around in a Cessna, you know? So they wait until it's a little bit higher on the horizon to transmit. So we should be getting back. See, 10 degrees is the elevation limit. When this clicks over to 10 degrees, they'll configure 54 for the uplink and they'll start talking to him again. But Emma, thank you very much for the super chat. Yeah. One of the images you could see Australia. Dude, when they came around from the far side of the moon, Emma, they had yeah, you could see Australia, which is really cool. It's non-ionizing. They'll be fine. All right, stand in front of it then. Oh, wait, you don't want to do that? That's weird. Oh, you don't want to do that? Oh, that's bizarre. That's bizarre, dude. Put a turkey in front of it. That's just cruel. I need to walk my fish. Yeah. Oh, yeah. No. Fish walking. Yeah, no, of course. Fishes can walk. That's how we evolved. We evolved fish walk out of the water. It makes sense, dude. No, you're telling the truth. Why are you assuming a live one? Because assuming makes you a hole. Not me. I'm good, though. What a dick. No, yeah, I mean, I don't know. You want to make a turkey dinner really fast, that'll probably do it. So do you like fish?
This is Artemis Mission Control at Johnson Space Center in Houston, Texas. You're looking at a visualization of Orion's current state. We are now 55,000 miles away from the moon, a number that will continue to grow as that number, 223,617 miles from Earth, continues to shrink. You can track Orion at any time by visiting nasa.gov/track-Artemis. Here in the flight control room, the Orbit 1 team is starting handover with the Orbit 2 team. This room is monitored 24/7 throughout the mission, all the way through the time the astronauts splash down in the Pacific Ocean, now 2 days, 22 hours, and 55 minutes away. And we are also live on NASA's YouTube throughout the mission.
Rarest. Non-ionizing or not a full power blast from that dish would not be a great experience. Yeah, you might get chicken pox. Yeah, that'd be terrible. Wait, no. It's got to be your chicken. When are you scheduled to rest tonight? So I figure we'll give a schedule update. Mission elapsed time is sitting at 6 days, 2 hours, 24 minutes. Here. Yeah. I got rest in about 3 hours. Probably go a little longer. I don't know. We had a long sleep window. No sleep till splashdown. Yeah, I don't know. I don't like that both of the PRUs, the pressure regulator units on the NTO side, have decided to not work. I don't like that. Dishes are at 10 degrees. We should be getting an acquisition of signal. There we go. Wait for the uplink. It'll happen. Had a rough day at work. How did things go? Been a relatively quiet day, Gore-Tex. This was a slow day. Consider this the day off of the mission. Flight day 7 is... There wasn't a lot. They called the ISS, which was pretty cool. They talked to Kelsey Young about describing their science findings that they did when they close past the moon. They did the RTC-1 burn, which was a 0.35 meters a second correction burn. That's actually like nothing. And now we're kind of here. This is like, you know, a little bit of time off from the crazy schedule that was yesterday. They basically clocked in and worked all the way to the FD conference. Now, from flight day 8 is kind of... There's a lot of stuff going on here. They do the rad shelter demo, which is pretty cool, where they test the radiation shelter that they can kind of set up inside of the capsule. In the case of like a radiation storm, they can, you know, use Orion as a shelter in case of solar flares. Yeah. And then they have the manned piloting demo. There's another manned pilot developmental flight test right there. And then flight 9 is basically get ready for reentry. Flight day 10 is do the reentry. Yeah, this day is going to get rowdy. These two, 9 and 10, are going to be pretty good. There's going to be a lot of work. Were the battery they were worried about on Sunday's fine? Seg, they haven't talked about them since, so I think we're okay. I didn't hear anything about it in the press conference. Let's see. Do we have an uplink? Nothing. Do you think Wolowitz is going to be on Artemis 4? I don't think we need Wolowitz there. You should probably just fix it. If they miss the atmosphere, will NASA prepare a rescue rendezvous? Nerd, so it's not that they're going to miss the atmosphere. It's that they can't. It's that it's not about dialing in the trajectory like that. It's more you're going to hit the atmosphere with this trajectory that they're on, and there's nothing you can do about it. They're already, I would say, for all intents and purposes, if they're doing a 1.2 meters a second correction burn for RTC-1, I would say that you are pretty much you're gonna hit it whether you like it or not. It's more that than anything. They're not gonna miss. What's the thruster issue? The MON 25, so that's the oxidizer side of the hypergolic system, the pressure regulator units, and the helium isolation valves are not working correctly. There's the uplink. Okay, we should hear them hailing them real fast here. Integrity Houston, comm check. What the hell was that? The animation. Oh, that was the resync. That was the animation resync. They reestablished the uplink. What's the thruster issue? Are you serious? I just told you that a moment ago. You're not screwing with me, right? Well, why male models? I stepped away to pee? Oh, come on! Why'd you ask a question and went to pee, dude? Are you kidding me right now? What the hell? The helium isolation valves on the MON 25, so that's the oxidizer side of the hypergolic system, is not happy. They went into a forward link loss of signal right when they were trying to figure out what's going on, and they we're coming out of the loss of signal here. They did execute the return trajectory correction 1 RTC-1 burn was executed on time. It was a 1.3 meters or 1.3 feet per second, so 0.35 meters a second burn. Basically,
Integrity Houston, voice check on Madrid after the LOS.
There we go. Should have a reestablished link here. Should. Give it a second there.
We're with you, Stan.
What's up, Stan?
We got you loud and clear. During the forward LOS, we copied your call for the RHC stow. Jeremy, we copied your call about the prop valves in 12.2.2509 and your plan that if you needed prop, you would open NOx helium iso valve 1, and we were good with both of those conclusions. And we have more software words when you're ready.
All right, let's listen. I'm gonna shut up and listen. I'm just gonna not look at chat for a second. Should get a copy right about now. Or not, or just have another sip of coffee.
Okay, Stan, we're ready for those words. Good.
Okay.
All right, for the prop cautions, it's still an evolving story. We had a fitter function that should have been inhibited. Even left enabled, we did not see its trigger conditions being met, yet it executed. So we are running tests starting now to understand this better. That fitter swapped branches and turned off 2 PRUs, and we're putting the recovery steps for that system in work, again, starting now. Current thinking is that we'll disable that fitter for future burns.
Interesting. It's all good, Nader.
Okay, that is understood, Stan.
Also, we saw unexpected software commanding to the OMS engine after the burn. Flight software checks which burn type you are doing before the burn and not after. And when the software does its engine check, if the OME actuators are on, it assumes you're doing an OMS burn and will command a post-burn gimbal check. So today the actuators were on for the TVC motion checks we were doing earlier in the day. So despite doing an RCS burn, we got a post-burn gimbal check.
Oh, yeah, you should probably shut that off. That's
Okay, Stan, understood. No impact on that, but an interesting item to know about. Thanks for that.
a little bit of a software funny there.
Well, we take it seriously when the software doesn't do what we expect. That's all we got for you. It's good to have you back.
Is that why it rotated? I don't think the thrust vector controls on the OMS engine would be enough to do that, Echo.
Okay, and then what configuration do you plan to put the valves in at this point?
Yes, Rarest.
Jeremy, we're going to run procedure 30.52.2200, 30.52.2200 from the ground. That will put us into the valve config that we're seeking, and you can follow along in that procedure if you like.
Yeah. Okay. So, must be the Windows update.
Okay, and I thought I heard two different procedure numbers, so can you just read that back again?
There was a
30.52.2200.
How did I make it get the roll? It looks like it was commanded, Sean. I don't know what that was.
We got it.
But
And then, sorry, just we're not going to get into that procedure. We're going to get into some other stuff. But what will be the end configuration for those helium valves?
okay.
Jeremy, we're going to end with aux helium branch 1 closed, all other helium branch open.
Okay. Okay.
Okay, understood that. And what about inhibiting? Will anything be inhibited?
Checking.
We got a checking over. I'll tell you what's going on, and I'll translate what this all means in a moment.
Jeremy, all 4 helium isols will be enabled, but only aux helium 1 will be closed.
Okay, understood. All enabled and aux helium 1 closed. Appreciate those insights.
Good readback.
Okay, so what happened there is there's 2 valves that go from the helium tank to...
And Houston, just one other detail. We want to make sure it got down accurately communicated to you prior to the burn. We went into that seeing aux helium isolation valve 1 inhibited, closed and inhibited, which was not what we were expecting from the daily summary. We just wanted to make sure that that was clear to you, and that's what you were seeing as well.
Yeah, sorry, Jeremy. We inhibited that valve from the ground earlier, and we should have told you about it.
Okay, cool.
Okay, all right. That closes all the loops for us. We're doing good up here. Everything feels great, and we're just working through our timeline. Appreciate it.
Okay.
Our pleasure. And FYI, we're doing team handover to Orbit 2 as we speak.
Copy that. Thanks, Orbit 1, and looking forward to working with Orbit 2.
Here, one more question for you. We're 18 minutes out from an attitude maneuver and wondering what the exercise plan is.
It's 8-hour shifts, Willie.
We were a bit late getting to that exercise. The intention was to still do it. Can we do exercise through the CCU dump? Any restrictions on that?
Checking.
We are checking, over. We're going to go with plan alpha question. Charles, what did you have for dinner last night? I know you're trying to race. I need to know if you preferred the spaghetti or the penne question.
And while you're checking that, Stan, if you guys could just safely raise for us from the ground, we'd appreciate it.
Yeah, Lewis, I know your tires are graining and they are falling apart, but please stay out. Do not pit now. Oh, you crashed. Oh, well.
So, Jeremy, we can't exercise during attitude maneuvers, and we have an attitude maneuver at the beginning and at the end of the CCU activity that's coming up here. So I think we're going to have to shift exercise to the far side of the CCU dump.
Stay out, stay out, stay out.
Right, okay. That makes sense. All right, we will sync you up on what the plan is. We may start exercise before the CCU dump if you're okay with that, and then cease it prior to your maneuvers, if that works for you.
Copy. We'll give you a 2-minute warning for stopping exercise to allow a raise to damp and then do the attitude maneuver. Basically, you only have 10 minutes before you have to stop.
Plan. This is just a resistive set for Christina, so it's easy to stop it in the middle and pick it up after the dump.
Okay. And Jeremy, we'd like you to not try to start exercise before the CCU dump. We'll pick it up on the other side, please.
Jack, hold on. I got to explain to you guys what's going on first. Give me a second. I'm just standing up because I've been sitting down all day, so just got to stand up and make sure I don't get
Okay,
DVT.
understand your direction is to defer exercise till after the CCU dump.
Yes, thank you.
Yeah, Transit, they did have a little bit of a communication because they were trying to isolate the valve issue. Guys, the short story here is that there's two valves that go from the helium tank to the MON 25 tank. What's MON 25?
This is Artemis Mission Control, a mission elapsed time of 6 days, 2
For
hours.
the love of God! All right, anyway. So you have your helium tank here, and then you have your MON 25 tank. There are two main valves that go from the helium to the MON 25. Now, what's MON 25? That's your oxidizer. That's the oxidizer that the fuel that they're using. Okay. So they have valve 1 and valve 2. Valve 1, it was not working correctly on flight day 2, so they said screw it, don't worry about it. We use valve 2. Valve 2 is working. It's fine. It had some weird readings, so they shut it and switched to valve 2 out of an abundance of caution. Now valve 2 is showing prop warnings. All right, it's flashing prop warnings on the dash, indicating that it might be bad. So what they're trying to do, what Stan is trying to do, is make sure that the prop system is working correctly. They're basically troubleshooting it. So they put valve 1 and valve 2 into a shutoff, and they didn't tell the crew that they shut off valve 2 remotely, and that's what the miscommunication was, Transit Biker. So what they're going to do now is they're going to try to get valve 2 working again. That's the idea. They're going to try to get it working again. They're going to follow step 32.80.2200 or 30.52.2200, which is probably some kind of troubleshooting contingency, to try and get that valve working again. Once again, this is all being done out of an abundance of caution. The helium to MON 25 isolation valves, if this mission needed the service module firing some more, you would have a big problem here. You would have an issue at this point. Sit down. No exercise before the burn. Oh, okay. It's not necessarily dangerous, guys. They have I drew a diagram of it a little while ago on stream. But the short story is that they use helium to pressurize the fuel and oxidizer tanks for these, and that's how they get the propellants to move to the rocket engines, right? That's called feed pressure or tank or head, right? It's called head. I know. Funny name. So with the head pressure, they have enough pressure in the tanks that's downstream of the helium isolation valves to execute all of the burns, provided they don't have to do like a crazy maneuver. But for all intents and purposes right now, if they needed to do more than 15 seconds of burn, you would have a big problem here. I don't think they need to, but, you know, if your helium isolation valves on your oxidizer side for the entire module are not working correctly right now, you could get out of this sticky situation. I don't think there's really any safety threat here, because there isn't. However, they, you'd probably rather figure out a way to get that to work just in case something weird happens. Also, Orion seemed to have a little bit of a software problem there. It seemed to have a little bit of a software problem there. They did the RTC-1 burn, and for whatever reason, the onboard computers enabled the main thrust vector control system. And the main thrust vector control system started wiggling the capsule, or wiggling around to prime itself for a test. That's definitely weird behavior, and it's behavior that you got to figure out, but it's not that big of a deal. Not mission threatening, but this is stuff you really got to figure out. You have to figure that out. That's you do not want your prop valves or your engines potentially firing it when you don't want them. That would be very bad. Ask anybody in Kerbal when you accidentally hit the X key and full throttle when you have an engine enabled and blow yourself completely off course. Yep, definitely have done that. They're on the correct trajectory right now. Anyway, I'll be right back 1 second. I'm just going to go take a piss. I'll be back momentarily.
Good evening from Mission Control Houston inside the Artemis Flight Control Room. I'm Anna Schneider with NASA Communications, and the Orbit 2 team of flight controllers has recently come on console and have completed their handover with the Orbit 1 team. The Orbit 2 team tonight will be led by Flight Director Fiona Ankoviak, and the Capcom or capsule communicator will be Tess Caswell. The Orion spacecraft, of which you can see a live view there on your screen, those views coming to you from the solar array wing cameras. That spacecraft and its crew are currently about 55,000 miles away from the moon and about 222,000 miles away from the Earth. Following yesterday's lunar flyby, they are now in the return leg of their journey with an expected splashdown on Friday, April 10th. The crew has an off-duty day today, so there's very minimal timeline tasks for them. However, the first return trajectory correction burn, or RTC-1 burn, was recently completed at 7:03 p.m. Central Time, 8:03 p.m. Eastern Time. There are 3 planned small return trajectory correction burns along the return journey home to ensure the crew is set up for a safe re-entry and splashdown. The last of the trio of burns is scheduled to take place on flight day 10, about 5 hours before entry interface, once the crew has begun working through their preparations for coming home. So while it's an off-duty day, for the remainder of the day, the crew will complete their daily exercise using the flywheel exercise device on board the Orion spacecraft, but otherwise, they mostly have free time to do as they choose before preparing for sleep.
Integrity Houston, 2 minutes to the maneuver to the CCU dump attitude.
Integrity copy.
And Ike, while I've got you, we have 2 requests for you on this activity.
Okay, I'm ready to copy.
All right, if you would please just let us know when you start and stop the vent and how many CCUs you dump, if more than one.
Okay, I will let you know. I plan to dump 2 CCUs, and I will let you know when I start and when I stop. And just confirm through the maneuver, though, we are still go for CCU dumps until then.
And Victor, if you would please pause on any dumping until we get to the timelined activity.
Okay, we copy. We have paused secondary line dumping.
Thank you.
This is Artemis Mission Control. You're seeing a live look of the Orion spacecraft as it makes its return journey back home to Earth. You just heard some communication between the crew, namely NASA astronaut Victor Glover and the Capcom or capsule communicator here in Mission Control Houston, which for Orbit 2 is Tess Caswell. And they were discussing an upcoming CCU dump. CCU stands for collapsible contingency urinals, and they typically vent that liquid overboard each day. So they are in the process of preparing for that upcoming vent overboard.
Did they dump the CCUs? Did that happen? They told them to hold it? Oh, God, that sounds painful. Didn't you hold it too? Not for long. Dumping pause till scheduled event. Interesting. Yeah, just pull over and go in the bushes. Two CCU dumps are ready. Okay. Oh, Coco, I gotta go poopy. I got creme de peroline. It's got cocoa in it, and I just went poopy, so we're good. Control, don't worry, don't talk about that in here, dude. That's good, but don't talk about it in here, homie.
And this is Artemis Mission Control in Houston, Texas. You can currently see a live view of that Orion spacecraft as it performs a small attitude maneuver to get it into position to perform an upcoming wastewater dump.
Sigwally, I'm not that much of a code guy, to be honest with you. But if I had to pick a language that I like, I'd say just C++ or Python, dude. Those are the only two languages I've coded anything in. You thought I had a black and mild? Well, I just wanted something to go good with my coffee. Did you wash your hands? You're damn right I did, dude. Oh, shoot, Alistair. I didn't listen. Is that bad? No, Hunter, I got Biscoffs down there. Don't you worry. Yeah, these are addicting, and they're not good for you. But, you know, we're here. That's right, Plus. Yeah, Mishot, we can do that. Yeah. Don't hate that. Nice. Mm. Neil Davidson, welcome to Flight Control. You're now Flight Controller for the EJSA on the YouTube channel. Thank you. Thanks, Neil. I appreciate you, man. Thank you very much. This is just black coffee, dude. It's Dunkin' Original.
Houston Integrity, we have dropped a VC call. Can you please redial?
In work.
Shmam, I was dying about an hour ago. I was dying, but I needed a cup of coffee. I'll be all right, dude. This won't screw my schedule. This won't screw my sleep schedule any more than it's already screwed. So don't worry about it. We're good.
This is Artemis Mission Control. You just heard a call there from the crew. They were referencing a PFC, which is a private family conference. The flight control position here in Mission Control that is responsible for coordinating and setting those up, specifically the connection from the ground to the crew, is the BME position, which is the biomedical engineer. And they ensure crew health and safety by planning, facilitating, and monitoring all activities involving crew health, medical operations, and relevant hardware.
All right. I'm going to convince myself that that's enough for now, but I'll be snacking on these again in 30 minutes. Let's not kid ourselves. There you go, 1997 Nissan Sentra GXE. I mean, Sentra, I was more a fan of the Sentra Spec V, but GXEs are good too. Spec V with the SR20 was a good car. Because SR20. A couple Nissan SR20s. Pull a premium right before Race Wars. It's been light geek, but yeah. Their 125 helium isolation valves aren't working. So, that's good. Oh, wait, no, it's not. That's bad. It was your grandma's car that got handed down to you, so it only has 60,000 miles on it. Dude! Wow! I was reaching for the... Nope. Pirouettes, nope. Valves are tough when you're dealing with all kinds of different rocket fuels and stuff. That's cool, Nissan. That's sweet, dude. If you want to stay awake, Jaeger, Red Bull, and gin is the call. Just be sure you have a whole day to recover. I'm trying to stay awake, not have a stroke. Yeah. Yep. I mean, I'm not going to lie. That sounds like fun. Maybe on a weekend, but... They're only 65 calories each. Hey, Rosebud, how are you? You'll stay awake for the rest of your life, yeah. They're only 65 calories each. Only 65 calories each. Look what you did. Chat scumbagged me into doing this. It's your fault. No, these don't have any caffeine in it. $65 of them are a calorie? No. You fit 9 people in an 89 two-door Sentra when you were 17? All right. When do you want a crate of Tim Tams? I have a crate of Tim Tams. I only break them out for special occasions. Blame Chad, no. I don't have anything yet, Cirrus. I might get something a little bit later. Cleric, your brother had a Sentra Spec V? Dude, Sentra Spec Vs are cool. That was a cool little car. I mean, 200 horsepower in that tiny of a vehicle. I mean, there wasn't a lot there. That's when Nissan was cool. And then they merged with Renault, and they haven't really been cool since. Your coworker showed you 2 AI videos of the moon today. Oh. Want to hear a good one, Semi? My cousin sent me a video of an F-16 dodging a missile. He was like, look at this crazy footage from the war. And I was like, yeah, that's cool, but you know that's War Thunder, right? Typing ... No typing ... Typing ... No typing ... Typing ... Really? Yep. Yep. You know that's War Thunder, right? Oh. Yep. Yep. Yeah, that happened. That was actually a couple weeks ago, but yeah, no, that's a thing. Sorry, cousin, if you're watching. But see, here's the thing. My cousin was like, you know, okay, what video game is that? I'm like, careful. What video game was that? Hey, Anathemia, how are you? I'm sorry if this question is being repetitive. No, not at all. But how can I get the Twitch badge drop? You need 10 minutes. So when NASA turns their stream back on, you got to get a little bit more watch time on their channel. Are we there yet? No. Oh.
Okay, Houston, we're about 60 seconds from the first CCU dump.
Yeah, only the NASA channel, Anna.
Copy.
60 seconds from the first collapsible contingency urinal dump. It is an hour of watch time, Sentra. At least I'm pretty sure. Today's Nissan is a massive bag of horribleness. Yeah, Sean, exactly. If Nissan released the 5-trend retro thing they tested a few years back, they would have gotten you. Yeah. Yeah, exactly, Sean, which is odd because Renault builds to build some actually decently cool things. Yeah. Very interesting.
Oh, this is space. I'm in space.
Oh, you gifted a sub to Anathema. Anathema. Do you like Saturns? Yeah, they're all right. All right, here, hold up 1 second. Guys, we're talking about cars because we're kind of out of the loop. They're going to dump. They're going to try to dump, do a secondary dump, which is dump. They have bags of piss that they're trying to feed through the toilet to get it to dump correctly. They're working on that right now. Other than that, they were troubleshooting a valve issue with the helium isolation valves on the Mon 25 tank.
Okay, Houston, turning the valve in 10, 9, 8, 7, 6,
Cross your fingers.
5.
Houston copies. Vent started.
Okay, I stopped the dump. We don't like to let the CCUs collapse. I'm going to vent it, let it open back up, and then start the dump again in 10 seconds.
We copy, Victor.
Vent is open.
That's correct, Nader. Hey, Rob, what's going on, man? All right, so... Okay, we got a good nod from the Capcom there. Or from the flight director. She's running the show right now. I honestly forget her name. I don't remember. Her over here, her name's Tess, but... Tess... Fried? I forget her last name. She's the capsule communicator. That's the lady that you're hearing talking to Victor right now. The other man's an extra. She's CIA. The other man's an extra. Oh. You never seen Hot Shots? All right, cool. Nah, Booth, I don't think that's her last name. Tess Caswell is her name. Thank you, Stormcrow.
Houston Integrity starting the second CCU dump in 5, 4.
Oh, they got one to go. Hell yeah. 2 is better than 1, Hellfish. Yeah.
Valve closed, venting, and dumping the rest of the second CCU in 10 seconds.
We're getting good nods there.
We copy.
What are they dumping their dump into the vacuum? The dump lines is for piss only. It's not for poo. Poo gets stored on board. The reason why? It's easier to dump a liquid than it is a solid. If you were going to dump a solid, you'd need an airlock. That doesn't necessarily need to be the case with a vent line.
Houston Integrity. That is the filled CCU dumps complete. I can actually provide another one for you in about 2 minutes if you want, and actually I would love to do that if that's an option.
Yes. Get her done, Vic. Yeah, you don't want to stir the poo tanks. Could end poorly.
And Victor, we'll be happy to take you up on that. For your awareness, the maneuver out of this attitude kicks off at 3:20.
He's got 28 minutes.
And to be perfectly clear, that's when we would want the dump to be complete.
That's the best control loop ever.
Victor copies.
So once again, just to be very clear, I keep making toilet jokes, and I make toilet jokes because they're funny. The toilet's actually working. It's the vent line. They vent liquid waste overboard. They vent piss. Yeah, that's what happens. They vent piss. Solid waste gets put into canisters. That system is all working correctly. It's the vent line. That system has not been tested prior because they don't have a vent line on the ISS. This toilet is derived from the ISS's toilet, right? They don't have that on the ISS.
Integrity Houston, for awareness, we are 1 command away from clearing the prop cautions that are on the board. And if you want to follow along, you can look on the prop SMPRU display.
Okay, that's the center display. How does someone even become a capsule communicator? NASA Flight Operations is what you'd have to go. It's specifically NASA FOD or Flight Operations Directorate. That's the mission. That's where you'd want to go for mission control. So yeah, the ISS does not vent liquid waste overboard. They recycle it.
This is Artemis Mission Control in Houston, Texas. You're hearing some communication there.
Orion does not recycle it because that's too heavy. It would be too heavy of a system to do that. So they vent it overboard because it's less mass. It's trade-offs. Orion's already heavy. It has a whole toilet. There's a whole head. There's a bathroom in there. And that's taken up a lot of mass. The recycling system would be too big to put inside of the capsule. So they have the vent system in its place. And the vent system is the thing that hasn't been tested, and that's the thing that they're having problems with.
And the team here in Mission Control also noted that the cautions on the screen that appeared ahead of the earlier return trajectory correction burn are starting to be cleared as they are returning the propulsion system back to a steady state, and they are putting those recovery steps in work after those cautions were received.
So they are using the toilet for solid waste, or does it still... So they're peeing in bags, Nikki, and they're going poo on the toilet.
CCU dump complete.
Okay, Vic got the third bag.
Copy. Perfect timing.
What do they use for body cleaning? Wet wipes. No shower. Water's too heavy. And water's at a premium. Hello? Just reading about Tess Caswell. She's not an astronaut, but she was the extravehicular activity. She's on the extravehicular activity team. She works as a capsule communicator in the Flight Operations Directorate. She is on rotation as the Artemis lead Capcom, helping develop and training processes for the Artemis campaign by leveraging her experience supporting the space station. She helps ensure that astronauts aboard spacecraft receive the right information at the right time, like when to go poop. You think I'm kidding? The role involves a range of activities, from learning the language of spacecraft and its onboard operations to participating in simulations to relay critical information to the crew, especially during dynamic operations or when things go wrong. She's from Soldotna, Alaska. Whoa, all right, cool, sweet.
Integrity Houston for awareness. Once we complete this maneuver, we will park the saws and we will let you know, but we are prioritizing getting into configuration to allow you to begin exercise expediently.
Killer. Hey, Astro, what's going on? Most astronauts are usually, most Capcoms are usually astronauts, but they still have other people there too. Soldotna. I've never heard of it. I have no idea where it is. That's actually near Kodiak. Well, not really. Alaska's huge. It's closer to Anchorage. It's southwest of Anchorage a good ways. That is, wow. That's out in the sticks, man. There's nothing up there. I mean, that's the more populous side of Alaska.
This is Artemis Mission Control here in Houston, Texas. Joining me now on
Anna?
console is Dr. Suzanne Bell, Principal Investigator for Artemis 2 Archer Study. Welcome, Suzanne.
What's up, Suzanne? Anna. And to start, can you tell us a little bit more about your role for this mission?
Sure.
How are you?
Well, I'm the Principal Investigator for Artemis 2 Archer Study. Welcome, Suzanne.
How are you?
Well, this is an exciting mission for us because it's the first time that we've had astronauts beyond low Earth orbit in 50 years. And so it's exposure to deep space, which for us is a number of space hazards that we don't get exposure to anywhere in the world or even in low Earth orbit on the International Space Station. So what we're doing is collecting data to understand behavioral health, how crew interacts with Orion systems, how the team works together, and then how sleep affects their performance.
So you mentioned a little bit about the data you'll be collecting, but can you go into a little bit more about the devices and how you'll be collecting that data?
We collect some pre-mission data, which is a really important understanding of the crew's baseline before they're exposed to deep space. We collect in-mission data. I actually wore one today. It's an actigraphy device, and the crew is wearing it even on their day off today. So we can track their activity as well as their sleep patterns and getting an understanding of the way they're interacting and using the cabin and some other things. We also collect a lot of data post-mission. Something I'm really excited about is our R+0 or return +0 data collection on their cognitive performance as well as their operational performance. Humans are very adaptable, but that transition, because we are so adaptable, is something that we pay attention to for preparation for things like landing on the moon someday. So that's an important data collection for us. And then other data collection after post-mission also includes a really important debrief. So we get an understanding of where there might be performance sticking points, or where the crew might need more supports with behavioral health or how to team together. And so it's critical that we can get an understanding of the data, but then explore this data with the crew, and they really provide important insights. This crew is the only one that's gone into deep space since we've had more modern methods of looking at these things, and so getting their interpretation of what happened is really important context for us to understand.
Cool.
And so Orion is significantly smaller than the International Space Station, which a lot of us are used to, but how will that size impact how the 4 crew members are living and working together on their mission?
Well, that's a very good question and something I'm interested to find out. So one of the aspects of teamwork we look at is something called group living, that concept of being considerate of others and being tidy in the workspace, and how does the space work in terms of habitability and being able to be together in that small environment. And Orion's interesting. It's very small. The International Space Station is something like a 6-bedroom apartment, and this is something like the size of a camper van or 2 small vans. It's a little different, though, without gravity in the way that we have in Earth, and that you can use little cubbies of it and different spaces on it. So I'm really interested to hear from the crew, is it as tight as it seems? Did they have procedures and workarounds to make it seem more roomy? Particularly interested in sleep. So right now in the International Space Station, sleep is very well managed, and they have private sleeping areas, and it's just it's conducive to sleep. But Orion's quite different, and it's similar to hammocks or just spread across in that small environment in a different way. And so it'll be really interesting to hear from the crew. Well, one is to look at their sleep patterns with our watches like this that we have with them, but second, to get their perspective on, did it work out? And one of the reasons it's good to hear their perspective is because this is a 10-day mission, but we're looking at a sustained presence on the moon, 45-day missions, longer. And so some of the stuff will be passable for a 10-day mission, but they'll also give us insights into, we worked it out, but there's going to have to be a different setup or different ways of using Orion for longer missions.
And you touched on how this is a test flight. Is there anything that you're hoping to learn that maybe you haven't learned yet from the 7 days that we've done? There's probably going to be a lot of data collection even after the mission.
I'm really interested in this part of the mission. So we've done testing of Orion. It was magical to do the lunar flyby. That is really meaningful work. Now we're on the way home when the high is kind of over, right? And so there's fixing toilets today and some other things that
it's kind of coming off of that high. We know from our data that having positive affect, having that excited feeling can actually help your performance and really is important for the crew in terms of their well-being. So even this coming down, I'll be curious how they react to that. And so it's still a critical part of the human test, even though we're done with a lot of the other testing, although testing is ongoing on pretty much everything. But
so you touched on it a little bit, but what role does team dynamics play in your study?
Team dynamics is one of our main pillars that we look at. So we're interested in both how the crew works together as a team, but also how they work back with mission control. A lot of the ways we do things right now are based on real-time interaction. And as we create a sustained presence on the moon and are increasingly looking to things like Mars, we'll become more Earth independent. So we have to push some of the decision-making to the crew, some of the problem-solving to the crew. And so looking at that dynamic both within the crew but then back with mission control so we can kind of create this Earth independent eventual direction that we're trying for.
That's super interesting. So what about sleep? So what role does this wrist device play in tracking their sleep, and how does sleep play into this study?
Sleep's really important. Even in this mission, we pushed the crew a couple times, and they had smaller sleep intervals than you would expect or that you would even suggest from a performance perspective. Co-investigator on this project is Dr. Erin Flynn Evans at the Sleep Lab out of AIM, Sleep and Fatigue Lab. And so she and her team actually tested some of these patterns ahead of time to make sure that performance could still be sustained under the extremes of not only being in
Houston, the saws are parked. You are go for exercise.
Oh, exercise time. So, Nader, why not make the habitable space cylindric?
Copy, thanks. Starting now.
And this is Artemis Mission Control. We just heard a call up there from the Capcom capsule communicator here in Mission Control to NASA astronaut Christina Cook, currently on board the Orion spacecraft. They mentioned that the solar array wings, or those saws, there's 4 of those attached to the Orion spacecraft that manage power generation. Those have been placed in a park position, so the crew is now able to resume their exercise, that exercise using the flywheel device on board the Orion spacecraft. All right, Suzanne, so you were talking a little bit about sleep and the role that plays.
Yeah, so as we are doing things like testing systems, sometimes you don't get all the sleep that you wanted. So we had early in the mission, for example, the crew was allowed a 4-hour sleep opportunity. Dr. Erin Flynn Evans and her team, that's collaborators on this research of ours, tested that ahead of time to make sure that it would be doable for the crew, because you're talking about a performance circumstance that's extreme. Okay, so now you're doing performance in a different type of gravity. You're in a small space. You're coordinating not only with your crew, but back with mission control. The crew is highly trained, so that goes obviously a very long way. But still, if you're tired, you can still make errors. And errors in this type of situation and in space, can have severe consequences. So we really want to make sure the crew's positioned for success. We can learn about where we can push them in a mission like this, where we were able to push them a little bit on the sleep, but then where we'll have to pull back, where there might have been areas that we've pushed a little too far. And so that's some of the data we'll be getting.
And I'm curious, so the crew right now is actually mostly an off-duty day. So does that also kind of factor in to some of your study, like when they have busy days and then they have some time off? How does that play a role into some of that health and performance?
Yeah, so on the International Space Station, the Behavioral Health and Performance Operations Group is fatigue management. And so importantly, having that work-rest cycle and interval is critically important. All of us at home, when we work, we need that day off. So do astronauts. And they really need to get a lot of work done while they're up there, but they also need that time to unwind. We have research that would suggest that when you take time off, it's important that you disengage. And so crew being able to have that opportunity to have that
restorative time and whatever they need to do to disengage. Like my understanding is today crew wanted a little bit more exercise time. That might not be the same for every crew, but this crew in particular, it seems like something that they're interested in and helps them kind of get that restorative time for themselves.
Let's work out.
Super interesting. So there's lots of insights that are going to come from your study, and how will some of those insights help future missions to the moon and maybe even onto Mars one day?
Well, this is critical data for us. So we have learned a lot from low Earth orbit. We know about cognitive performance change. We know that social support is an important buffer for stress. We know that teamwork is critical for performance outcomes. Now we're asking them to do it in a completely different environment. So we're going to use those baseline from our data in low Earth orbit and really build on it using what's called a Bayesian methodology, but where you update each time with new data. And so what Archer really does, which is our research study, is really sets up the infrastructure for understanding human health and performance for Artemis missions. We'll learn from Artemis 2, then we'll roll that right in to do our best estimates for Artemis 3. We'll provide supports for the crew where we can in these areas, and then we will learn from that data, see where we can push a little bit more, and iterate into the Artemis missions as they get more and more difficult to create that sustained presence on the moon. It's a human performance challenge. And so, it's really important to know where can we push, where are we pushing too much, because ultimately that human system is as important as all the other systems that are being tested right now.
Well, it's been a pleasure to have you. To wrap it up, can you tell us what you are most excited to learn regarding this mission?
I'm really interested to learn the sticking points. We try to replicate and understand space as much as possible on Earth, but when you get all of those things together, it's radiation, it's different forms of gravity, it's being in a small space. It's always surprising what kind of can be a sticking point. And so just that crew perspective on, we saw these changes in your data, but from your perspective, where are the sticking points and how do we best support crews of the future? They're the best position to tell us of what's needed to really support the Artemis 3 crew and then Artemis 4 after that.
Well, thank you so much, Dr. Suzanne Bell, Principal Investigator for the Artemis 2 Archer Study.
Thank you, Anna.
Core didn't like that. That was cool, though. That was cool. I was listening. I'm all right. I'm fine. Well, now your back's going to hurt because you just pulled landscaping duty. Yeah, I think that was really cool. The Avatar mission is pretty sick. That's like one of the headline science missions from this mission. Avatar, for the most part, is just seeing how the astronauts' health fares over a 10-day mission out beyond low Earth orbit. That's the big one. You should stretch. Yeah. Oh, God. Core is not happy. I did kind of belt those out, though. Yeah, I think it's awesome. Has EJ done his 10 push-ups today? Yeah. No, my back's fine. It's my core. I'll be all right. Today's the 33rd anniversary of The Sandlot. Let that one marinate. Why? No, Spartan, I've done push-ups every day. I've been doing 10 push-ups for a week straight, dude. I just didn't stretch, that's all. I'll be all right. I'll be fine. Don't worry, the pain is going away. Yeah. You're killing me, Smalls. All right. Where are we on the timeline? 10 push-ups per day, Surfer. 10 push-ups whenever the toilet is mentioned. Oh, God. Mission elapsed time, 6 days, 3 hours, 39 minutes, 9 seconds. Oh, boy. Good job on sticking with the push-ups. Thanks, man. I don't think we're getting any tone, per se. All I got is the farmer's tan that you guys can make fun of me with. Like, you're not going to get any tone from doing this for a week, but it can't be bad for... Yeah, okay. All right. There's a little bit of farmer's tan. All right, we're good. Got some deltoid bicep tone there, but it's still mostly flab. It's mostly flab. 10 push-ups every day for a week is not going to do anything. You need to do that for a couple of months. Corn is doing good this year? Oh, yeah, fella, I tell you what. It's the same as road trips. The drive home always feels longer than the drive out. Right, Pac? "100 push-ups, 100 sit-ups, then run 10 kilometers every day." Yeah, that'll get you toned pretty fast. I actually, guys, yeah, as long as we're gonna stick to doing this, I actually, I got a bar from my parents' house when I was up there on Sunday. I got a bar, and I have some weights with it. I'm probably gonna have to buy a new set of weights. I'll bring the bar up here, and we can start lifting that thing. Thanks, Dave Reno. Yeah. All right, me. So yeah, today was pretty much a slow day. Today was because the last couple of days, flight day 4, 5, and 6 were really packed full of activities, especially the lunar observation stuff. Flight 7's kind of a quick day or an easier day here, as Susan was just talking about when Anna was talking to her. Like, this is supposed to be this is the kind of downtime. You need a little bit of downtime because activities are going to start picking up again here as they get closer back to Earth. They're going to do a cabin repress tomorrow, rad shelter demo. There's another manned piloting DFTO demo tomorrow. A lot of exercise demos, something that a developmental flight test activity that has to do with urine. The activities are going to start picking up as we move towards reentry. Didn't they do a call with the ISS today? Yeah, that was today. It was this morning. It was pretty good, dude. Pretty cool. But yeah, this is kind of the calm before the storm. We're getting into the third act here. Consider this your intermission for this mission. Intermission for this mission. Allow myself to introduce myself. Is the trip home to Earth faster? It's about the same amount of time, Musu. 3 days out, 3 days back. Today was the eye of the storm. That's right. Isolated. Yeah, the schedule's going to start picking up again soon. I dropped my dragon capsule. Don't mind me, just dropped my dragon capsule. Shuttle parts did go to the moon. Yeah. Yeah. How you doing? I'm doing all right, dude. Yeah. Doing fine. You're still blown away by the photos, Shmim? The photos are... not bad. So, this photo here is pretty cool. Yeah. This photo is pretty cool. What you're looking at is the moon on the far side. This is the back side of the moon, right? And the terminator line on the moon is about, well, I'd say it's about here. So this is the close side, right? And this is the far side. That's not an arrow.
This is Artemis Mission Control in Houston, Texas. We are currently 6 days, 3 hours, and 44 minutes into the Artemis 2 mission here on flight day 7. We recently had Dr. Suzanne Bell join us to talk about the Archer study flying as part of Artemis 2. And as a part of this study, NASA wants to know how Artemis 2 astronauts adapt to Orion's living space. The crew is wearing wristband devices that record their sleep and movements. Let's go ahead and take a closer look at how data collected before, during, and after flight will provide scientists with valuable insights into how crews adjust.
All right, hold on. Let's paint first. All right. So this is the shot on the kind of the eastern hemisphere of the moon. The sun is behind the moon in this picture. Earth is that way. Earth's out that way. Okay. So the reason why I point up there is because if you guys look right here, banana. You see that shine on the moon? See how this side of the moon is illuminated? How could it be illuminated? The sun's behind it. That's illuminated because that's Earth light. That's Earth light. That's light being reflected off of Earth and shining on the backside of the moon, even though the sun is on the other side. That's pretty damn cool. The sun, here, hold on, let me go around there. Sun behind the moon. This is the moon. Let me redo that so it's not poo-poo. Yeah. Right? Now, this is pretty cool because, all right, you got the Earth light, you got the sun behind the moon, but here's the real kicker. Here's the real kicker. Take a look over here, bottom right. You see that, and that. Those are not other stars. That is Saturn. This one right here, Mars. This one over here, oh, no, no, not Ford's. Excuse me. Mercury. Wait, don't circle that. Hold on. Pretty cool, huh? You have the moon, Saturn, Mars, and Mercury, the sun, and if this picture was a little bit bigger, Venus would be over here. There is almost 4 planets and a moon in this shot that are visible. Now here, check this out. You want to see something pretty damn cool, right? If we go about halfway between Mars and Saturn in this picture, right? You see a very, very, very dim light right there. Very dim. That's Neptune. It's very, very dim. You can barely see it. If I zoom in all the way, you see some slight variation on pixels right there. That's Neptune. So Mercury, Mars, Neptune, Saturn, the Sun, Earth's moon, and Venus is almost in this picture. The other thing is that you can see other stars. There's constellations here. One of the constellations is that one. It goes that away, like that. There's another one is this right here. And then it goes that way. I forget which one that is. And then there's another one that goes over here like that. I forget which one that is. I don't know the names of any of them, but you get the idea. That is my favorite picture from this mission. By a long shot. What's the cloud fuzzy spot underneath the Earth arrow? That's probably just glare. So the cool thing is that, see this kind of dust cloud that's happening right here? That's the solar corona, or at least part of it. That picture is your new phone background. That's awesome, dude. And maybe, you know, what would be a cool thing to do? Just, we do something like that, and then we go back over here. We get on here. There you go. That is my favorite picture by a long shot from this mission. It's not even close. Screenshot it, please. Oh, you guys want me to do that again? Let me... I should draw this with the constellations. It'd be cool, but you know what? That's fine. I'm pretty sure people can understand that they're stars. So, oh, no. Enjoy. I thought those are galaxies. I labeled them incorrectly before, Rick, when I did this picture before. They are not galaxies. They are other stars. Sign it. The APOC, the thrusters seem okay. We haven't heard anything about them since, but there you go. Oh, I gotta move my mouse off of it. Hold on. Pretty cool, huh? That's my favorite picture. It's just absolutely mind-blowing. So I can show that to people next time. I need you to draw a giraffe. Are you proud of me? Do I get my gold star? That's its ears. That's not horns. Why are the legs so broken? Shut up. Just shut up. Love that animal, whatever it is. Are we going a little crazy? No. You guys should see my Orion diagram. Hold on.
Houston integrity, low priority question for prop system when you have a minute.
Hold on.
We have as many minutes as you need.
There's my Orion.
This should be quick. We see that the prop system is reconfigured after RTC1. The only thing that we wanted to verify from our crew displays is that it looks to us like oxhelium isol 1 is both closed and inhibited. We expected it to be closed, but not inhibited.
Checking.
We are checking, over. No word on the smoke alarm, Jim.
And Reed, you are just one step ahead of us. We had inhibited it as part of the recovery process, but we are about to re-enable it as our last step.
Good eyes, Commander.
Okay, thank you.
No problem. And while I got you, just wanted to give you a heads up. We've got slot 4 active on board for RTC last.
That's why he's the commander. That's why Reed's the commander, because he knows what's good. He noticed.
All right, high fives all around. That's a big accomplishment for the team and for the mission. Thank you.
Is the we are checking? It's a reference to Formula One, Musu. Weston, they do 3 shifts, 8-hour shifts a pop. So yeah, first, second, third shift. They're called teams. But yeah, dude, you know, like you have to zone it. Like you don't want to be on the console for too long. You'll start making mistakes if you're there for more than like 8 hours. That's not like a OSHA or something. No, you do not want to make a mistake here, right? Never. You don't want that because it's space, it's dangerous, stuff can go bad real quick, right? You don't want to make a mistake, so they do 8-hour shifts, right? And they do 3 shifts over 8 hours, right? Not because like, OSHA and stuff. No. They do that so someone doesn't screw up. It's the same reason why pilots can only fly for a certain allotted time of day, because even if you just flew a plane for like 8 hours or something, right? And you feel okay, you don't know that for sure. You have to be sharp to fly an airplane. You have to be sharp to fly a spaceship, like Reed just was. He picked out their procedures before they were finished, because he said they told him like, the valves are going to be isolated but not inhibited, and he saw it on the console. That means he's watching. That means he's watching them reconfigure the valves. He saw that wasn't configured correctly, and he caught them in the middle of their troubleshooting diagnosis because he was staying sharp. Exactly that. That's why the flight controllers swap out every 8 hours. There's 3 teams. Truck drivers have that rule. Pilots have that rule. Mission control is no exception. You do not want to screw this up. You do not want to screw up. Get a good night's sleep. The hard part of that, like, dude, is like, this is a crazy lunar mission, right? And, you know, say you're there, you're talking to the crew, right? You're talking to the crew and they're taking all these sweet pictures of the moon and your shift ends. Good. Go to bed. Think about that, dude. Think about how gnarly that actually is. Like, okay, I was just talking to people out at the moon. Now you have to go to bed because you have to, because if you don't get a good night's sleep, you're going to screw up the next day. You have to, yeah, flight control, dude, flight ops. Like, once again, I will never not have an opportunity to, like, or not take an opportunity to shout out the flight operations directorate. Flight ops is cool, man. That's Gene Kranz. That's Chris Kraft. That's old school. Flight ops is old school, dude. I love it. These people work real goddamn hard, or gosh darn hard. Excuse me. Yeah, man. Flight ops is cool. Yeah, but yeah, 8-hour shifts so you don't screw up, and then you have to compartmentalize it, which is like, okay. Can you think about like during Apollo 13, if you're working on the shift, right? The spacecraft blows up and then your shift ends. Now what do? You have to go home and just pretend like nothing's wrong. What are you going to do? Talk to your wife about that? Like, no. The cigars help a lot. Like, now think about it during the Apollo program, why they had coffee and smokes in mission control all day. You know, I asked Charlie Duke one time, how many did, like, during Apollo 11 PDI, Charlie Duke was on Capcom. He was the Capcom. I'm like, how many packs of smokes and coffee did you guys drink? And he just kind of looked at me and he went, a lot. I'm like, yeah, I bet it smelled like a pool hall in there. He's like, yeah, that's pretty much right. I'm like, yeah, all right, man. Yeah, smoking in mission control. Let's do this, you know. That's cool. It was good stuff. I wouldn't smoke. Smoking's bad for you. But also, you know. Yep, we got a bunch of people. Roger, Tranquility, we copy you on the ground. There's a bunch of guys turning blue down here. We're breathing again. Thanks a lot. Yeah, there you go, Ernok. Right. I mean, Neil stuck the landing because he's an absolute unit. He was an absolute unit of a person. Yeah, back then it was good for you. 9 out of 10 doctors recommended it, Crow.
Integrity Houston, for any available regarding additional annotations on science impact flashes.
Yeah, weather guy, right? I mean, it was like chewing gum, dude. What's up?
Go ahead, Houston.
Oh.
Hey, we understand that you guys have some additional annotations that you made in OneNote regarding impact flashes, and the easiest way we think to get that to us is if you would take a screenshot of those additional annotations and place that in imagery for downlink, which will save us having to re-downlink the OneNote file.
Okay, I'll do that right now. It'll be on PCD3, and it is a work of art.
Oh, shoot, not OneNote.
Copy, Jeremy. We look forward to taking a look.
I can't believe they're using crappy Microsoft programs. Anyway, here, let me draw you another diagram in Paint. Oh, no, that's bad. Sorry. Sorry.
This is Artemis Mission Control in Houston, Texas. A few moments ago, you heard some additional communication between the crew on board the Orion spacecraft and the team here at Mission Control. They were discussing some science observations that had been made yesterday during the lunar flyby.
I like that
specifically related to some impact flashes that the crew saw during the eclipse period at the very end of the lunar flyby.
Bro, is there a good video contrasting the technology between Apollo and Orion? Dude, a lot of the technology is in the same tech tree, but Orion's a modern version of the CSM. It just needs it needs a better service module, but that's another story.
Checking.
We are checking, over. A box we need to pit to undercut with plan A. Oh, never mind, stay out. Oh, you lost the lead. New NASA pick, Histic? What do we got? Oh, that's pretty neat. How neat is that? Oh, man. Wow. Now that capsule's got a lot of integrity. Wobbly. Yep.
And Integrity Houston, for the CCU dumps, we are still analyzing imagery related to the timelined dump. We would like you to hold off on any additional dumping until the end of our analysis activity, which is in approximately 90 minutes, and we'll give you a call when that's complete.
Okay, we copy. Holding off on dumping, and you confirm 19er or 90 minutes?
And that is 90 minutes. Of course, you can let us know if that's an issue for you guys.
Right, binary? The crew took this shot, yeah. Following a successful lunar flyby, the Artemis 2 astronauts captured this breathtaking photo over a galaxy on April 7th. That was today. Wow.
This is Artemis Mission Control in Houston, Texas. Again, some additional communication there between the crew on board the Orion spacecraft, specifically NASA astronaut Victor Glover and the Capcom, or capsule communicator here in Mission Control, Tess Caswell, regarding a wastewater dump. They were working to complete a wastewater dump about an hour ago, and then they put a pause on some additional wastewater dumps for about 90 minutes. And then prior to that most recent call, the crew was also calling down related to some clarification for observations they had made during the lunar flyby related to some impact flashes. Again, these are flashes of light from meteoroids that are striking at the surface of the moon. Earlier in the day, as part of Flight Day 7, the crew did have a post-lunar flyby crew conference with the science team here on the ground to discuss some of their observations while they were still top of mind. Currently here in Mission Control, the science officer on console is Angela Garcia.
We don't know the next crew yet, Hitman. Endeavor, knowing that the Earth can somewhat illuminate the moon even during its lunar night, would NASA ever consider extending a ground mission to observe Earth light? I know it might be super cold. What do you mean, a ground mission? We can observe that. I mean, well, actually, you're not going to be able to observe it as best as a lot from the surface. We're just going to have to send up more stuff up there, dude. What is that sound? Kevin, what you are listening to is the dial tone for mission control to talk to Orion. Specifically, it's this signal here coming out of Madrid 54. This is NASA's Deep Space Network. Normally, dude, on a stream, I would not want background noise. I'm not really a fan of that. That's really annoying, right? But it's okay in this regard. That is that beam that's going up. Specifically, it's an up signal at 0.3 kilowatts in the S-band frequency. Yep, that's what that buzzing noise is. I'll keep it. It's fine. It's basically a combination of dial tone and missile lock. Yeah, I've been calling it the signal lock or dial tone. Yeah, that's what it is. Do you have an idea on how the Apollo crew rotation works? Apollo missions? What do you mean, Sloth? I mean, there's not really necessarily an ebb and flow to it. They just picked the people that they thought were most qualified. That's the reason why Neil and Buzz landed on the moon first, because they thought that they were the two most qualified astronauts to do it. I would argue that John Young and Gene Cernan were probably qualified as well, but John Young and Gene Cernan flew the previous mission. John Young ended up flying on 16, Gene Cernan ended up flying on 17. The idea that NASA was going with is that you send a bunch of guys out there and then you split the crews that you send out there and have them command other missions, right? Like Apollo 10, for instance. Apollo 8 with Jim Lovell. Jim Lovell ended up commanding the 13 mission, right? 13 didn't go how we wanted, but that was the idea. Joe Hayden, welcome to Mission Control. Your go at throttle up. Thank you. How worried are you about re-entry? More worried than the dark side? I mean, Solar Salami, the re-entry is going to be a real big critical phase of the mission. I would say that's probably the part of this mission that I am the most concerned about. Yeah, it's pretty much right up there with transiting the far side of the moon and signal blackout. Do you reckon it would have been one of the Apollo 1 astronauts on Apollo 11? Yes, absolutely. Gus Grissom was going to be the first man on the moon.
Purposes, and so you're tracking what I'm doing here. I was scheduled for aerobic today. I'm going to go ahead and film resistive exercise just because of our Titan timeline. Resistive goes a little faster, and I prefer more resistive anyway. But let me know if anyone has any major heartache with that, and I'll switch back to aerobic.
Copy. Checking.
I wonder if Stafford would have gotten a slot on the commander role. Let me see. I want to see. Let me check something. So for Apollo 18, the crew was the backup crew for Apollo 15. So Dick Gordon, Vance Brand, and Harrison Schmitt. But Harrison Schmitt flew on 17, so it probably wouldn't have been him. They probably moved him up to... Yeah, Schmitt was moved up to 17 under pressure from the scientific community, replacing Joe Engle. Schmitt, a geologist, became the 12th man and only professional scientist to walk on the moon. Deke Slayton, who was the chief of the astronaut office, his intention for the Apollo 19 crew was the original, prior to cancellation, Apollo 16 backup crew. So Apollo 19 would have been Fred Hayes, Bill Pogue, and Gerald Carr.
Integrity Houston, back with you on the exercise question. So there are a couple of factors here for you, Jeremy. One, since this is a recorded session, we are looking to get one of aerobic and one of resistive. And because of other activities tomorrow, we think that the resistive fits better tomorrow from a spatial constraints perspective, which is why we had aerobic today. So we're leaning towards recommending that you stick with aerobic today, but additional context is that we do have some wiggle room to extend the time frame where you guys can be exercising today if needed.
Okay, Houston, I can do aerobic today.
Thanks, Jeremy.
So the backup crew for Apollo 11, by that logic, was Jim Lovell, Bill Anders, and Fred Hayes. So there's not necessarily a rhyme or reason to this. None of those guys flew on the next mission. Jim Lovell flew on 13. Apollo 12 was Pete Conrad, Al Bean, and Dick Gordon as the command module pilot. Who was the backup for 12? Let me take a look. What is the point of landing on the South Pole on the moon? There's water down there. We should go get it. Water makes it easier to make a base. So the Apollo 12 backup crew was Dave Scott, Al Warden, and James Irwin. Dave Scott ended up landing on the moon on Apollo 15. Al Warden was also on Apollo 15. And the backup crew for 12 ended up on 15. So as they launched more missions, guys, they started getting in, they started kind of getting into a rhythm here, with the backup crew basically flying on the next mission. 13 was after that. That's Jim Lovell, Fred Hayes, and Jack Swigert. Fred Hayes was on the backup crew for 11. He ended up flying on 13. Swigert was the part of the backup crew for 13, and he replaced who did he replace, guys? I forget who he replaced. He replaced Mattingly because Mattingly got exposed to smallpox. That's right. Yeah, Ken Mattingly. That's right. Or German measles, I said smallpox. Yeah, sorry, I was I'm sorry, it's getting late. I apologize. So yeah, it seems like towards the end of, like, as they got further and further into the Apollo missions, there was a rhyme and a reason to this. So the Apollo 14 crew is Al Shepard, Stu Rusa, and Edgar Mitchell, right? And who was their backup crew? The backup crew was Gene Cernan, Ron Evans, and Joe Engle. I think Shep was supposed to be on 13. Yeah, maybe. What is the best space documentaries? Hitman, my knocked over a water bottle. My favorite documentary / miniseries is something that came out in the 90s. It's called From the Earth to the Moon. Yeah, From the Earth to the Moon is amazing. If you can get past it being, from the 1990s. The special effects aren't the best, but it's really good. There's also When We Left Earth. When We Left Earth is a fantastic documentary from the late 2000s. To the heat shield thing again, people seem to think outgassing is abnormal for them. It's actually completely normal. That's why the shuttle tiles have undercoating. Demo, I'm not worried about outgassing from the heat shield. I'm worried about charring and spalling at the seams because somebody decided to redesign the heat shield from the mechanical design that was used during the Apollo program with the honeycomb lattice. The honeycomb lattice allowed for outgassing, and it also allowed for the heat shield to not char and spall as much. It mechanically stays together, and the blocks, right? It doesn't get in the seams at the blocks, right? I know the heat shield outgasses, but I firmly believe that, and I know that NASA hasn't said this, I get it. You know what, dude? I don't want to talk about it. I think the heat shield's going to work. I don't want to talk about it. You don't put bad vibes on the mission like that. From the Earth to the Moon is amazing. Yeah, Shirley, you'd see it would look like puffs of gas coming out. If you can contain the gas by flying, well, that's why I think they're doing an Apollo landing trajectory demo. I still don't really understand their rationale for doing the skip with Orion at all. Like, why would you do that if you're redesigning so many things on the heat shield? But, whatever, dude. I think it's going to work. I don't think they'd be up there. If that, Yeah, Banana Bean, how does a normie chud like you get into astronaut school? And you could try applying to start there. NASA has, open field for becoming an astronaut, but you really need to have a good resume to do that, Banana Bean. I think I've watched From the Earth to the Moon 100 times. Ballin', I watched my favorite episode from the Earth to the Moon, the spider episode last night, and dude, this mission hit me like a ton of bricks. I'm like, it's not a dream anymore. It's not something that we, thought that we wanted to do. Flight 7, guys, today was kind of a slow day, but let's not.
Integrity Houston for SA regarding a ground activity.
Let's not undersell it here. We went back to the moon. How did you have time to watch an episode? I lost sleep. How else? And there's peak heating and G-load benefits. And all those benefits mean dick, Aqualex, if your heat shield doesn't work.
Go ahead, Houston.
Hey, Reed, just wanted to let you know the ground is about to take a team photo at 4:25 your time. so I will be stepping away from the desk, but I will have my device on speaker. So if you call, it'll just take me an extra minute to pop over here and respond.
Did we get some high-res images of the backside of the moon?
Okay, no problem. And we see that the prop system is in the configuration we did. Thank you.
Yeah, Yudi, I think we did.
Fantastic. That is true.
The soundtrack to the Spider episode is what gets me, Breen. And the end of the Spider episode is just... What's that one called? This one? This one is the Eagle. So good. What's your view on aliens? They're out there. I want to be the one finding them. I do not want to be found by aliens, Dan. Is that fair? Right, Ballin? There you go. The fact that the temps inside the capsule, even with spalling, leaves me zero concern. The temp stayed the same with spalling. Yeah, dude. Like I said, I don't think... Look, Amit Shathria, the second in charge at NASA, Amit's an engineer to the end. You could just tell he's got it. Like I've been in this business long enough to know who knows what the hell they're talking about. Like Amit knows what's going on. I really don't think he would let this mission fly. Him or Jared would let this mission fly if they weren't sure. Hello from Brazil. What's up? What's up, Christina? How are you? After Spider, there was Snoopy. No, they talked about it. Yeah, they talk about that in the episode. Yeah. But yeah, that dude, this isn't like, and then I watched the end monologue from the Earth to the Moon, but I'm saving that for later. The Spider episode, when he talks about, like, this is something I firmly believe, and I did talk about it the other day. Something I firmly believe is that, so the Orion capsule, thousands of people came together to touch that thing, to build it, to make it work. And what the guy says at the end of the Spider episode and From the Earth to the Moon is that, like, he's really proud of the LEM that he made. He feels like he's seeing his kid off to college, right? But you know that these spacecraft that we build are it's an amalgam of aluminum and wires and stuff. It doesn't have a soul, right? Like, but it does. You know, the soul is the people that put hands on it, to turn the wrench, to make the thing work. If you work on something, I firmly believe that you impart some of yourself onto this. Like, this would just be a bunch of aluminum and wires and copper and Kapton tape and stuff if people didn't put the effort in to build it. That's the soul of a vehicle. All the people that worked on it. And it's something that really drives it home with Orion and integrity, because, you know, dude, I wasn't around for the Apollo missions. I don't know. Like, I see the service modules in the museum, and you know, I don't know. I didn't see the thing fly. I just see it as a museum piece. Like, but think about all the people that came together to build those things, right? And that's why I love that From the Earth to the Moon episode, because it's true. Look at all the people that made this thing. That's the soul of the vehicle.
Integrity Houston for secondary dumping.
And the fact that we're doing this again, we're going out to the moon, and it just kind of happened like that. And we're back.
Go ahead, Tess.
In that is very
Some
moving
good news.
for me.
We have determined that we are okay if you have additional CCUs that you want to dump. We would just appreciate it if you would let us know anytime you're initiating a dump until MET of 536. We are still collecting imagery associated with that first dump, and it'll just help us to know when additional dumps happen.
No problem, Bet. Yeah. From the Earth to the Moon.
Okay, sounds good. We're going to have a dump in about 1 minute here, plus or minus a few minutes. Well, not minus a few, but maybe plus a few.
Friday
And I thought you were
pizza.
taking a picture, Tess.
We are about to. We're waiting for one very important flight director to arrive.
Okay, great. As we told the Orbit 2 team, really savor these moments as you got the whole group together to take a picture, and just we're really proud of everyone, and we're having a good time up here. Thank you.
It's probably Jeff Radigan. It's either...
Hey, I had you on speaker for that, and we really appreciate your words. The whole team heard you, and we are all really proud to be here with you.
Excellent. And Victor just had a great comment. If you guys get a couple of these early drafts of these pictures of y'all, put them in the mission summary. We'd love to see your faces.
We can absolutely do that.
Yeah, when we left Earth is great. Yeah, and you know, like as I was saying, like
This is Artemis Mission Control in Houston, Texas.
They're dumping more pee, if you really want to know what that meant. I can, rationalizing this, that is a vehicle that we've sent off to the moon, and you're not getting some of it back, just like they weren't getting Spider back, was very moving for me. It kind of drove home, like, just how special this is. And man, I kind of had a little bit of a moment last night off stream when I was sitting there on my couch watching this. I'm just like, dude, I can totally understand where you're at. Like, this is a heartfelt thing. This is the real deal. That's the real deal, man. We're here. We went back to the moon. We transited the far side of the moon. It makes me really happy.
Oh, this is space. I'm in space.
Hey, Ice Cold. Thanks for the 5 subs, man. Sorry, I'm getting I'm starting to lose it again. All right, let's dial it in. It's cool. It's so cool. We're here. That's awesome. It's something to be happy about, man. Like, it's something that I've often thought of what this would be like. Seeing a mission go to the moon. It's just, I don't know. Because, I know the Apollo missions, I know what they did, and it was great, and it was amazing to be there, or not to be there, to
this is space.
to learn about them in retrospect, right? Hey, thank you, Nova. And man, like, I knew the Apollo missions, and I kind of knew what to expect here, but that lunar transit yesterday, dude. I didn't think I'd react this way. Like, you got rated a second ago? Oh, thank you. Stardust with the 399 viewer raid. You're catching me in a tearjerker moment. What's going on, buddy? How are you? Yeah, I mean, we were just looking at some pictures from the far side transit yesterday. Bonjour. What's going on, guys? How are you? I'm Stardust Air de Espace. What's up, guys? Dude, I've spent a long time. You're a bit toilet tired. Yeah, we all are, dude. I stopped trying to explain things. Like, I'm just like, I want to look at pictures of the moon right now.
Discovery, go at throttle up.
Hey. Empty Rib. Welcome to Mission Control. You go at throttle up. It's just, I've spent a long time telling people that we need to start doing this again. We need to do this again. We need to go back to the moon. We need to go out. We need to explore. You know, we need to be a part of it. We need to lead it. For the eyes of the world, now look into space, to the moon, and to the planets beyond. Right? Like, I don't mean to quote Kennedy word for word, but that's exactly right. That's what we need to be doing. Right? Like, it's to see it happen is a real, I feel like a weight has been lifted, because you guys know, if you know me, I take this stuff real seriously. It means a lot to me. And I feel like at times, like over the last 10 years, like I've been screaming into the damn void. But, you know, this is a payout, and I didn't necessarily have anything to do with actually making it happen, but it's pay dirt, baby. It's like a weight has been lifted off of my shoulders, you know? That's what it feels like. I don't know, dude. Repost. Oh. I've invaded your workplace. Me and a coworker have been following your coverage. He went home and started watching along. We discussed it at lunch. Great job. Yeah. Are there any good shuttle documentaries? When We Left Earth has some, it's the entire space program from the beginning of it to the end of the shuttle program. So yeah, there is some parts about the shuttle in there. They already called the ISS. Yeah. Honest question. Has the shuttle been dethroned for you? What's our criteria for this pie? What is our criteria for this? I mean that. What are we talking about here? Like in terms of missions, this mission is cooler than a shuttle mission, if that's what you want me to say. I like lunar missions more, and we haven't even landed on. I like this more than the shuttle. Now, in terms of vehicles, I think the shuttle reigns supreme as the coolest vehicle that we've ever made by a long shot. But I watched STS-133, 134, 135. I've seen 2 shuttle launches in person. I saw STS-116 and 117. Those missions are very special to me. But I don't think in terms of vehicles, I will always love the shuttle, but this mission is cooler than a shuttle mission. Yeah. See last. What's up? What's up? Been doing the Switch thing long enough. Probably have indirectly contributed. Yeah, maybe. I don't see your last, Grits. I'm sorry. Can you type it again for me, please? Would Orion fit in the shuttle's payload bay? It's just a little too wide. Check my veins with lunar regolith. Nice. Yeah, I did say that. I said that in front of NASA. Whoops. Has the ESM been performing well overall? There's some problem with the helium isolation valves, but for the most part, yeah, it's working great. Never been able to see one in person? Any update on the helium issue? They're going through troubleshooting procedures now, Grits. Yeah, they have it in the configuration. They should work, but I don't think they're going to test them unless they absolutely need to. Yeah, and then you told them to fist your bump. Yep. Hey, Stardust, the geology audio descriptions from Victor were so perfect during the flyby. That was a very emotional moment, dude. Yeah. Your soul, I feel, is going to... Leave your body when HLS touches down? Yeah, maybe. It'll definitely be an emotional moment. I've dreamed about it, dude. I've had dreams about it.
This is Artemis Mission Control here in Houston, Texas. Now joining me on console, I have Dr. Brian Krusch. He is the principal investigator for Artemis 2's immune biomarker study. Welcome and thanks for joining us.
Thank you very much for having me.
All right, to start off, can you tell us a little bit about your role during this mission?
Yeah.
I'm the principal investigator for the immunology biomarker study, but it has a large team of co-investigators, both in NASA and external and globally, actually. And we're very excited to get biosamples down from the Artemis 2 crew and be able to say some things about how we're physiologically adapting to deep space.
All right, so the scientific usefulness of saliva is something that most of us here on Earth usually don't think about. So how are you collecting those samples?
We're collecting both blood and saliva samples. The name of the study is biomarkers, and so biomarkers are measurable indicators of pathological processes or normal physiological adaptation. And so you go to the doctor, you go out for a blood test or any type of similar test, and we're basically doing the same thing. We're the reference laboratory, medical reference laboratory for the astronauts. And so we want to get these samples down, pre-flight samples, in-flight samples, post-flight samples, and it will tell us about how they're adapting to the spaceflight environment. We don't have a lot of the laboratory equipment that we have on station, unfortunately. It's a different type of vehicle. And so we had to do things a little bit differently. On ISS, we can collect venous blood samples, and they can be partially processed on board, frozen and stabilized for return. We first thought we wouldn't be able to get in-flight samples from the initial Artemis missions, but then we had some innovation happen at NASA, and we decided to expand some dry collection technology to enable this to happen, and it's worked really well, and we're very excited about it.
All right, show off this dry collection book for the camera. So how does this work?
This is the magic that makes it all happen. And so the crew member will, I only have one hand, let me change hands here with the microphone button. And so basically the crew members expose these pages and put it in their mouth, get it wet, and then let the pages air dry. And literally, this is it. It can go in the pocket, it can go in a bag, it can come down. And the analytes that we look at are very stable on this media for incredibly long lengths of time. We did this on board ISS for cortisol only. I'll show a quick picture of that. This is a collection on board ISS.
Cortisol levels spiking.
It was actually pioneered by a man named Dr. Mark Laudenschlager, and but we were only doing cortisol because liquid samples are better than dry samples. And so the reason we needed the book for cortisol was we needed multiple samples in a day for circadian rhythm. And so we thought for Artemis missions, this might be the solution. And so we've pioneered basically trying to do everything else that one might need to look at in astronauts off of these books. Stress hormones, markers of inflammation, latent virus DNA, and bit by bit, by changing the papers, the reconstitution methods, it all worked. And so this is it. They'll do these books before flight, during flight, after flight. We've seen them in some of the live shots from Artemis 2 on the walls of the cabin drying, so it's been really cool. We got all excited about that. And we can't wait to get the samples down and be able to say something about how we're adapting to deep space.
That's super interesting. And actually, every day or on several days on the crew's timeline, we actually see a reminder right before their sleep period to collect their saliva sample. So it's interesting now to know exactly what that was for. But let's dig a little bit more into this. So can viruses reactivate in space?
Yeah, you heard me mention latent virus DNA. And I've been here for about 25 years, and it's been an interesting arc of discovery, medically speaking. I'm an immunologist, we went from not knowing if we had an immunology problem during space flight to getting some post-flight samples from shuttle missions and realizing, wow, there's tremendous changes there. But is it just landing? We had to wait for the next study to get in-flight samples to know that, yeah, we've actually got an in-flight issue here with the immune system. And so station allowed us to characterize this over 6 months. But what we've done is try to connect the immune problem to the virus problem. And so everybody became an immunologist during COVID. We've all heard about CD4 T cells and antiviral immunity, but this is what's going on with the astronauts and the clinical risks that we're worried about. When their immune system becomes compromised, latent viruses may reactivate and cause risks during deep space missions. And these are the viruses. When you get a cold, someone gets you on an elevator, your kid's from daycare. About a week later, that cold virus is completely gone from your body. You're then immune to that cold virus, and you generally won't get that one again. Problem is there's hundreds and hundreds of cold viruses. And some of these special viruses establish what we call latency in the body. You don't clear them. They're with you for the rest of your life. A good example is chickenpox. We get that when we're young. The virus is called varicella zoster. And you don't clear that virus. It establishes latency. And every day of your life, that virus is trying to wake up and cause disease. And your cytotoxic T cells, not to get too jargony, but that's what controls the virus. So during space, if your cytotoxic T cells aren't working as well, the virus is going to wake up. It was actually NASA that pioneered finding that these viruses can be detected in saliva of stressed individuals who aren't really sick yet. It's the changes that precede disease that are associated with the stress. It's Dr. Dwayne Pearson, Dr. Satish Mehta, and so it was fascinating, but we didn't associate that with clinical illness yet in astronauts, but it was a great biomarker for clinically relevant immune problems. Later on station, we started to connect it to issues the crew were having, some of the crew, dermatitis events. We actually had a case of zoster on orbit, shingles. That's the disease that is recreated by the same virus that caused chickenpox when you're either tremendously stressed or elderly. And so we actually had that happen on station once.
So
that's
you mentioned
awful.
a little bit about
I wouldn't wish that on
reactivation of
anyone.
viruses, but
Holy
what specific
crap.
spaceflight hazards can contribute to that reactivation?
Oh, that's a great
sounds
question.
terrible.
There are so many. And so stress, physiological and psychological stress, anybody who's experienced a period of tremendous stress in their life, that's when you get your colds, that's when you get sick. Med students taking exams, bereavement, there are a lot of situations on the ground where we get stressed and we get sick. But also microgravity, just being weightless, the immune system doesn't function as well. It fascinates me to this day. If we were on station right now, we could do some somersaults and throw some M&Ms at each other, and it looks great. But in fact, the cells know something's wrong and don't function as well. And so several of the immune cells, also natural killer cells, control cancer. They don't work as well during spaceflight. Some of Dr. Richard Simpson's work. And so these are the immune changes that persist during flight. And it's stress, to answer your question, stress, microgravity, radiation. The most radiosensitive cells in the body are the immune precursors in the bone marrow.
Not
and
good.
So altered nutrition, isolation, confinement,
Not
all
good.
of these things. So space is what we call an applied experiment. It's not just one variable, but it's a whole bunch. If we were doing this in laboratory, I'd want to look at one thing at a time. But during space, we're really just characterizing what is space flight, which is the amalgamation of all these variables.
So it's a combination of a lot of different things, but looking forward, how will insights from your study benefit future missions to the moon and also onto Mars?
Well, once we collect, and I say we, it's the global spaceflight immunology community, characterized this. And once we saw some adverse clinical events in some of the astronauts that we thought were related to it, we moved on to countermeasures. And so we've already been developing the countermeasure protocol to try and fix this. Now, the happy part of the story is that on station, we've kind of already fixed this problem. They've already deployed a whole bunch of countermeasures to station. The improved aerobic and resistive exercise devices, improved nutrition, communications, and all of these things have benefited stress and they've benefited immune, in particular exercise. But most of these countermeasures don't translate well to deep space missions. So we're going to increase the stressors and probably to some degree decrease our ability to care for them halfway to Mars. So we need a countermeasure that's specific for deep space missions. And so we've already developed that international team of experts and clinicians, and so that's being tested on the ground right now. And to look for a test bed, we look for a place terrestrially that recreates that spaceflight stressor, and the best place ended up being Antarctica. Wintering over there, which is a 1-year mission, 24-hour darkness, isolation, extreme environment, is the perfect place to test these immune countermeasures for flight. And so that's happening right now with the National Science Foundation at Palmer Station. And we're excited to get those samples back and see if the countermeasure we've developed for this problem is working.
That is super interesting, and I know there's lots of different analogs for all sorts of different human spaceflight things going on. We also have CHAPEA and Hera and all sorts of things that are often going on. But what are you personally most excited to learn from this mission and this study?
I'm excited, after 30 years here, that we're beyond the Van Allen belt. I mean, I can hardly believe it. I'm so excited. Yep. And so everybody on our team is. We're excited that a way emerged to get these samples and to characterize deep space stressors.
Go ahead.
Jeremy just completed his aerobic. Please let me know when the vehicle dynamics support me getting on for resistive.
To an extent, Jordy, yeah. Guys, yeah, cortisol level spiking is a meme that the kids use, but stress will kill you. Over time, it will kill you. Yeah, that's the truth.
And Reed, we just went around the room. We are
like
all
long
good.
Term.
You can begin exercise now if you'd like.
I'll have to check again.
Okay, we will. It is pretty interesting up here. I'm sure you see in the data, but we can definitely feel the vehicle moving around when folks are exercising. It's pretty cool to just sit there and float and feel the vehicle kind of. It's not like a ship rocking in the ocean, but you definitely feel it wiggling around.
Really, Discordia, that's cool. Shout out to the National Science Foundation.
We also see it in the SAW video as well as our data, but good to hear your report on it as well.
It better be, Jack. Let me put it that way.
Hey, one last question. This is for a little later tonight, but we kind of want to do a couple deep sky long exposure photographs. If the saws are in the windows and it's possible to get the lights turned off on the SAW cameras in about an hour, we might appreciate that, but clearly not if it interrupts any sort of ops down there.
Can I take more pictures, Dad, please? No, Kelly, it's rotational motion. It's not translation.
Reed, we think that will be doable. We will double check and we'll let you know when you're done exercising.
Yeah, they have lights. I just learned that, Blark. I mean, that kind of makes sense. But yeah, the saws have lights on them, which, yeah, no, that makes sense.
Okay, great. Thank you.
So that doctor was talking about
This is Artemis Mission Control in Houston, Texas. We just heard some communication there between the ground and the crew on board the Orion spacecraft. They were discussing some exercise activities. So CSA, or Canadian Space Agency, astronaut Jeremy Hansen just completed his daily exercise. And then Reed Wiseman, NASA astronaut and commander of the Orion spacecraft, is about to begin his exercise using that flywheel exercise device on board the Orion spacecraft. Yeah, again, joining me here in Mission Control, I have Brian Krushin, principal investigator for Artemis 2's immune biomarker study. Again, you were talking a little bit about what you were most excited to learn about from this mission.
Yeah, we're just thrilled that it all came together so well technically, and that we were able to get these all this suite of analytes to come out of these books. It's more than I even mentioned. Bone markers, nutritional status markers. Dr. Scott Smith, the nutritionist, he's a part of this. And so we're going to get a really comprehensive snapshot of how we're adapting in flight just off the saliva books. So I'm excited about that, but it was also just a thrill to train the crew to do these ops, and they're so amazing. So we're enjoying it.
So you've talked a lot about the saliva books, but what about this blood collection that you're also doing? Can we talk a little bit about that?
Yeah, so saliva is a wonderful biofluid to get and analyze because it's non-invasive. I don't have to stick a needle in you to get it. It's readily available and you can collect it. And it's basically a filtrate or a distillate of blood plasma anyway. And so we've tried to shift for remote locations or or operationally constrain things to saliva where we can, but there's still some things that you really need blood sample for. And so dry blood has actually been around for a while, primarily for pediatrics. They do a heel stick on them for a variety of things. But we do have dry blood as a part of this study also. And so here's the dry blood card that will be used. But we don't have in-flight dry blood for Artemis 2. It'll be in-flight for Artemis 3 through 6, which are also a part of this study. But we're doing it pre and post for Artemis 2. And I think Reed posted a really cool picture on Instagram of him doing his dry blood collection training.
And they collect it using a little finger prick?
Yeah, this is a standard lancet that anybody would use to do a finger stick. And then
diabetes.
The collections are done over the paper like this. The thing that most people don't realize is that everybody that does this uses gravity and cheats. And so doing this in microgravity was something that we were a little bit concerned about. Would surface tension dominate, and would you be able to get a clean drop onto these? And so Dr. Doug Diak in my laboratory actually flew this hardware on the 0G parabolic aircraft and triaged these collection materials and worked out that problem so that it's ready for Artemis 3.
That is super interesting. It's been a pleasure to talk to you. So just to round it out, what's it like to see your team's ideas and science flying on the Artemis 2 mission?
I can't believe that we get to be here and do this. Look where I am right now. What a thrill. And so, no, we're really enjoying it. It's humbling to get to see astronauts around the moon collecting biosamples for us, and we want to do a really good job for them. And just today, we were working out our schedule for after the last samples are collected post-flight, the staging of the reconstitution of these papers, and analyzing all of this. And so it's a real thrill for everyone on our team.
Well, thank you so much, Brian Crucian. Again, he is the principal investigator for the immune biomarker study flying on Artemis 2. Thank you so much.
Thank you for having me.
Dude, that guy's cool. That guy is cool. Brian Crucian. That's awesome. In demo, that's really good. That looks great, man. Yeah, so what he was studying, guys, is cortisol levels on astronauts that are up on the ISS. The reason why is cortisol is, long story short, cortisol will kill you. Stress will kill you. It really screws up your body. Like, think about it, like prolonged high cortisol levels, and keep in mind, I'm not a doctor. I know about this for reasons. High cortisol levels, like I get it. The kids say, "Oh, high cortisol, your cortisol spiked." Ha ha ha. That's fine in momentary bursts. Cortisol is basically your body going into red line. Like if you picture like a car engine, like that's what it is. So heightened cortisol levels eventually is going to wear stuff out. What he specifically was looking at is cortisol's effect on T cells, so your immune system, right? That's specifically what he was checking out, because there are already things that weaken your immune system in space, like radiation. Radiation's a good thing, that the radiation's going to screw up the T cells because they're very sensitive to it, right? That's why, cancer treatment has a lot to do with radiation. It's a little more complicated than that. People that do medical, I know it's more complicated than that. I know how the ship thrusters work. Okay, this is just a very high level overview. All right. So he was specifically looking at if their isolated environment or isolated environment contain not a lot of space, a lot of work is going to screw with your immune system, because cortisol levels will attack T cells over time. I'm serious. Stress will kill you. I do know that. It will kill you over time. Like smoking. Smoking will do the same thing. You can't burn the candle at both ends. You could do that now when you're in your 20s, maybe even into your 30s. But you got to take it easy from time to time. That's the reason why I hit it hard during the week and I take the weekend off, so I can still try to give you guys like the best content that you can. Like, I don't burn the candle at both ends unless we're going to the moon, right? Unless we're going to the moon. That's a little different, But what is the safe margin of error for reentry angle? What do you do? What's the basis for that question, Velocity? Like you said, temporary is okay. I don't smoke. No, I don't smoke. Don't smoke. Smoking is bad for you. The easiest way to quit smoking is to never do it. People in my family smoke. Don't do that. Don't do it. It's terrible for you. You are filling your lungs with stuff that your lungs were not really designed to take. What your lungs like is mostly nitrogen with a little bit of oxygen sprinkled on it. That's it. That's all you should be putting in there. Don't put anything else in there. That's bad for it. Nobody likes a quitter, though. Shut up. Artorius, be quiet. Yeah, Cyborg, like I said, Cyborg, you know me. I like burning. Dude, in my 20s, we burnt the candle at both ends. But I knew good and well to dial it back a little bit, you know? Dial it back. Because stress will kill you. You are literally taking years off of your life by having high cortisol levels throughout the entire day. You need to get enough sleep. You need to get enough sleep. You have to have dedicated time to just detox and relax. It'll make you better at what you do. And the sooner you do those things, the better off you're going to be. Think about it for a second. You think I'm full of crap. Why is a doctor at NASA studying this for when we go into space? It's not like space is a high stress environment at all, right? Oh, yeah, it is. Right? Think about it. Stress will kill you. Take some time. Unplug every once in a while. Go touch grass. I think I've averaged 4 to 5 hours of sleep a night in 2026. Stop that. Don't do that, dude. That's not good. It's not good for you, man. You Cyborg, you'll be able to do it now. You'll be able to do it for another couple of years, maybe. You get up to my age, dude, it'll really screw you up. So yeah, that's cool, man. That's because that's cool that a doctor is studying that, you know, in spaceflight, because space is a stressful place. You're in a box all day. You can't go anywhere. You'd be surprised how easy it is for someone to get cabin fever being contained like that. Blitz, I work as a golf course as a groundskeeper. I touch grass every day. Blitz, you also have to get up at 4 in the morning to go tend to the grounds. Do you do it right? You got to get up at like 4, don't you? Yeah? Yeah, dude, you have to get out there before tea time. The mission proves manned spaceflight does not detract from unmanned scientific exploration. It enhances it. Koff, that's a very good point. That is a very good point. Absolutely. Is there a reason why they were able to take better photos of Stars Galaxy on the journey back as opposed to I think they were focused on the moon, Jack, to be honest with you. Velocity, going back to your... Hang on, I just want to read that. Yeah, average mom. Yeah, there you go. We could smoke brisket. That's fine. Yeah. Velocity engineer. General rule of thumb is try to make your reentry trajectory, if Kerbals or people are on board in real life, to make it as shallow as possible. That's really important. Touch grass or touch dodge? I mean, I can touch dodge. Does that help? See? I touched dodge. It wasn't him. No face shown. Ah, crap. Forgot the screen was in the way. Haters will say it's fake. Haters will say it's fake. Haters will say it's fake. Nice socks, though. Thank you. You can see it's fake by the angles of the shadows. Right. Fake as your jammy pants. What's wrong with my jammy pants? You have good energy. It's great. Thanks, Arcanon. Yeah. Try to make it fun. They're brewing. So they do exist. Huh? You can't make a Bruins joke if they don't exist. Boom. I destroyed you with facts and logic. Sorry. Sorry. It's late. We're getting to the
This is Artemis Mission Control in Houston, Texas. We are currently 6 days, 5 hours, and 5 minutes into the Artemis 2 mission. The crew on board the Orion spacecraft is currently awake, but in an off-duty period. We recently had Dr. Brian Crucian join us to talk about the immune biomarker study flying as part of Artemis 2. Saliva can tell us a lot about astronaut health, so before, during, and after their trek around the moon, the Artemis 2 astronauts are collecting saliva samples. These samples will help scientists probe how the immune system reacts to deep space so that NASA can ensure that humans, rather than viruses, thrive in space as we venture to the moon, Mars, and beyond. Let's take a look to learn a bit more about this human research study.
What can Artemis 2 astronauts' saliva tell us? Saliva can tell us a lot about astronaut health. Just one tiny sample provides a window into what's happening into a crew member's body. When Artemis 2 flies around the moon, the crew will provide saliva samples for a study called immune biomarkers, which probes how the immune system reacts to deep space travel. This research builds on studies we've done before. Astronauts aboard the International Space Station collect liquid saliva samples with tiny oral swabs that roll around in their mouths. They also provide dry samples by blotting their saliva onto special paper that's carefully preserved at room temperature and brought back to Earth for analysis. Artemis missions won't have much onboard room for a refrigerator to store liquid samples. As a result, crew members will take dry samples periodically during their mission so that researchers can see how their immune system changes over time. NASA has been using saliva samples to help understand astronauts' health for decades. During the shuttle program, they discovered that dormant viruses in our bodies, including the one that causes shingles, can reawaken in space. Researchers are unsure why this happens, but think it has something to do with how the body responds to the extreme environment of space, including changes to circadian rhythms, stress, diet, radiation exposure, and weightlessness. By knowing more about how deep space travel affects the immune system, Artemis missions will help NASA ensure that humans, rather than viruses, thrive in space as we venture onward to the Red Planet and beyond.
To the Mars planet and beyond. Yeah, that's not great that your immune system gets screwed up a little bit up there. That's not ideal. You know, probably don't want that. Probably should fix that. That's the other reason why they work out. Wait, which planet beyond Mars? I don't know. Somebody asked me that yesterday. Where would I go next? I forget who asked it. But if I was going to go somewhere, the next thing I would check out Ceres. Ceres is a dwarf planet that's right on the edge of the asteroid belt. A dwarf planet like Pluto. Pluto's still a planet. The IAU can get screwed. Okay, no, Pluto's a dwarf planet. Ceres is a dwarf planet as well. I would go to Ceres. Yeah, check it out. Or Venusian clouds. I mean, Aqualux, there's no reason why we can't do both at once. Frankly, we should do both of them. We should, an EUS
This is
dry
Artemis
workshop
Control in Houston, Texas. You're currently seeing
on an
a
SLS
live
core
view of the
with an Orion on a Venus
spacecraft,
flyby.
which was named Integrity by
Why not?
its crew as it makes its way back to Earth. Yesterday on flight day 6, the crew spent the majority of their day in a lunar flyby observation period.
And following that lunar flyby, the crew
Europa would be
officially
cool.
began their return journey back
Europa,
to Earth. And then earlier
Ganymede.
today, they had their first return trajectory correction burn, or RTC-1. That burn taking place at 7:03 p.m. Central Time, 8:03 p.m. Eastern Time, to further fine-tune its trajectory to set it up for a re-entry and splashdown on Friday, April 10th.
They ever do a journey to Mars where you stream every day? A journey to Mars would take like 8 months, Artsy. I'd probably give you updates. I
Over
probably
the past
wouldn't do
few
the whole
hours,
thing,
we've
dude.
had a couple of human research experts join us to discuss the human research that's flying as part of Artemis 2. One of those is the immune biomarkers experiment, which is exploring how the immune system reacts to spaceflight. And we also had someone with us to speak about the Archer study, which stands for Artemis Research for Crew Health and Readiness, which is evaluating how crew members perform individually and as a team throughout the mission, including how easily they can move around within the confined space of their Orion spacecraft. The crew is also collecting a standardized set of measurements spanning multiple physiological systems to provide a comprehensive snapshot of how spaceflight affects the human body as part of a third study called Artemis 2 Standard Measures. Additionally, radiation sensors were placed inside the Orion spacecraft cells to collect additional information about radiation shielding functionality, and organ-on-a-chip devices as part of the Avatar study containing astronaut cells are studying how deep space travel affects humans at a cellular level.
No, there's redundant parachutes, Bet. Orion has redundant parachutes. It can lose one. That's not a big deal. I mean, it is a big deal. You really want to know why you lost a parachute, but yeah, there's redundant chutes. Personally, I like wings. Wings don't fail. It's just me. Maybe my shuttle bias is showing. Hello, you're here for the Space Nutella? Fair. What's the probability of getting hit by a micrometeoroid or a large piece of rock during said mission? That risk always exists, Hithouse, but we've gotten pretty good at figuring out where it is and where it isn't, but it's always a risk. You basically have to make everything on the capsule ballistic proof. And even sometimes that doesn't work. MMOD hits do happen. Most of them are negligible. Some of them aren't. The probability, I'll bet you Orion's already been hit with a couple. Wings can and have failed. I'm talking about in the applications of reentry vehicles. I don't ever recall the shuttle wings falling off. How can they safely make moon bases when things hit the moon a lot and we're helpless to that? Put it in a crater? Base in a crater? Like, Bet, these are good questions, dude, for what it's worth. Like, I'm not trying to be rhetorical. I'm trying to get you to think. I always try to do that when people ask me questions. I always try to get the noodle going. So think about it, dude. Think about it. Okay. The moon. You have to worry about micrometeorite impacts. They saw 4 of them, at least, on the back transit of the moon. That's enough to be concerning, right? That's enough that we really should figure this out. That stuff's constantly impacting the moon. I mean, it's not anything we kind of didn't know, but if you're trying to build a base, that's certainly a problem, don't you think? You don't need to get rained on by rocks and blow up your moon base, right? You don't want that to happen. So what do we do to get around that? Well, I think one of the best things you could do, put the base in a crater. Right? Put the base in a crater. But even if you put it in a crater, they could bury you in the crater or worse. We'd be able to see a big one coming. It's the small stuff that's hard to track, dude. Okay, so another thing that you could do, bury your base modules. Get a space excavator up there, dig out the regolith, put the base module in, cover it with dirt, call it a day. Make a bunker. There you go. Off topic, but are you an ex-smoker? No. Not cigarettes, at least. Why do you ask? The way you hold this? No. Cigars. Is that good? Cigars? Did that make more sense? No problem, Trojan. Yeah, I know, Greg. No. I don't smoke cigars very often, for what it's worth. Which company would you have contract for your space excavator? I don't know. Maybe start with Caterpillar, Komatsu, maybe. They have experience digging holes or building equipment that does. They're probably a good place to start. Boring company, they have experience digging holes. Yep. Yeah, caveman, for sure. So, Hardcastle, what do you got? What are your thoughts about the crew inspiring the faithful through the gospel? I have no problem with it, if you really want to know. I don't have any problem with it. Someone wants to express their faith, I don't give a frick. That doesn't bother me. I don't care. I think that's kind of cool, actually. Dude, the Apollo 8 mission, when they recited Genesis, I thought that was really neat. I thought that was really inspiring, you know? How do you think NASA stream is littered with high-pitched noise? Oh, Hithouse. Yeah, sure. I've been getting asked this question all week. That's the signal lock. That's the carrier signal lock for Orion. That's what you're hearing. That's basically the dial tone. So when they go to call Orion on the loops, you got a dial tone. It's the uplink signal, if you really want to know. Specifically, it's Madrid 54. Madrid 54 has the uplink signal to integrity right now. 2.38 second delay, 350,000 kilometers away. The Madrid one is facing due south with a 20-degree elevation. It's transmitting on a 0.3 kilowatt signal on the S-band. That's that humming noise that you're hearing. It's right there. Can the crew hear that noise? No. They can cue the speakers on integrity, so no, they probably can't hear it. And even if they could, I kind of like it. Not because I'm a fan of background noise or anything. I like it because I know that means we have a connection to the capsule. That would make me sleep better at night. Just saying. Everything's good, Yoshi. But anyway, talking about Victor, saying his message on Easter and, talking about the resurrection and stuff. Dude, I I don't have any problems with that. He was very graceful in it. I do believe that if you are religious, you don't need to put it in other people's face. Seriously, if you're a religious person, we don't have any problems. But I don't believe in okay, if your religion or the way that you like things, and this goes for like atheists, it goes for anybody. If you think that your way is truly the better way, right? You should lead by example. You don't need to lead other people by telling them. All right? I firmly believe that. And that's why I don't mind what Victor said. I really don't care. He was not condescending. If anything, it was a very inspiring message. I really appreciate it. I like Victor. He has he's very, very good with his words. Very good. He's a very well spoken dude. I really appreciate it, and I like it a lot. You know, that's where I'm at, dudes. If you need to tell people that your way is better, your way probably isn't better. I don't know, but yeah, I don't really care. You know, practice whatever religion you want. I think Vic would make a good president, sure. I agree. Those CrossFit guys can get rather obnoxious. Freaking underrated comment, dude. Is someone upset with his speech? No, Wisp. I don't think anybody is, dude. Well, let's be real. It's 2026. Someone probably is somewhere. But I've heard nothing but good things about what Victor said, dude. Somebody asked me about it. That's all. Right, Ian? There you go. He shared a pivotal emotional moment and how his background made him reflect on it in a respectful way. He's a good dude, man. He's one of the good ones. Why would you want to shoot down? Why would you want to shoot down a person like that? Absolutely not. You're not keen on Genesis or Phil Collins? Yeah, that's fair. Night, Gloopy. You know, dudes, this is about as philosophical as your boy's going to get on stream. Right? I don't try to ram things down people's throats. I don't believe in doing that. But just remember, in times of division, in times of
this is space. I'm in
Good
space.
Dog, thanks for the gifted sub. Appreciate you. In times of division, it's easy to cast stones. It's very easy to do that. It's hard to preach unity and peace in times of division. It's easy to preach division in times of division. Think about that for a second. Let that one noodle. Stew on it. It's easy to say, frick that guy, I don't like him. I don't like him. He's different than me. Piss off. That's easy to do. That's the easy thing to do. All right? Especially if someone's saying it to you. I don't like you. Go away. All right, whatever. It's easy to be divisive. And that's why people do it on social media, because it gets clicks. It's easy to do that. That's the easy road. I don't believe in choosing the easy road. Ever. The easy road never ends up anywhere good. Ever. So, in a time of extreme divisiveness, Victor gets up there, expresses his faith courteously, and preaches unity with us. We shouldn't be at each other's throats. I appreciate the hell out of that, man. That's not the easy thing to do. That was the hard thing to do, and he did it, and he did it with style. And it came off amazing, and the response was great. Just remember that. Why is it easy? Because it's easy to see somebody that doesn't think the same way as you and tell them to piss off. That's easy. That's the easy thing to do. Don't take the easy road. We don't do things because they're easy. We do things because they are hard. That's right, Jack. That's why, dude, I don't really necessarily, I don't have a problem with what Vic said. I don't have a problem with it. Whatever. He's good, man. You're all good. And the other things. That's right. That accent heck, all your accents surprise you? If this capsule decade of progress teaches us anything, the exploration of space will go on whether we choose to be a part of it or not.
Integrity Houston on OE1 for email status and SAW camera LEDs.
We need to be a part of it. We need to lead it. I mean, JFK grew up in the next town over for me, dude. I know that accent. I grew up with that accent. I didn't get it. Not as bad. Not as bad, at least, but also, I know that accent really well.
Go ahead, Houston.
Jeremy, 2 heads-up items. We finished the email sync, so the hands-off email in the crew band no longer applies. Secondly, Reed had asked if we could turn off the SAW camera LEDs. There were no constraints against that, so we turned all 4 off.
Sweet. Jeff's back. Jeff Radigan up there, top left. He's the lead flight director.
Those are great items for us. Appreciate it.
JFK's from Brookline, yeah. I grew up in Newton. That's the next town over. And a long time later, let me put it that way. Freaking Outlook, bro. Little Peter Griffin there. Yeah, that's right. Jeff is the lead flight director, Rogue. This is his baby. He gotta be there. But also, it's important to get sleep. That's what I mean about detaching if you're in a job in mission control. I don't know, TJ, maybe. There you go, crew. Exactly. That Pyroline is putting in some work. Yeah, you ain't kidding, Goonie. But yeah, you guys really rarely ever hear me be philosophical. I just believe in leading by example. That's all. You see me have beef with people? The only people I have beef with are the ones that come in here and try to be like, well, space is fake, right? Like, you see me have beef with people? I don't do that. I lead by example. I walk that path every day. Because leading by example is way better than me saying up here, be a good person all the time. I just am. I don't need to tell people about it. You do have beef sticks. I ate all of them. If you fight with a vegan, is it called beef? I don't know. I mean... Yeah, maybe. When was Victor's speech? It was on Easter Sunday, Adrian. It's a good speech, dude. That one's gonna go into the history books for sure. Crush Scan, that was pretty good, man. Do people actually do that in here? I don't think I've ever seen it. No. Because I lead by example. Astro, that's another rule of streaming. You want to get into streaming? Your chat is a reflection of you. You're looking in the mirror, whether you like it or not. If your chat is a toxic piece of crap, that's because you're being a toxic piece of crap. If your chat's having a good time, it's because you're having a good time. If your chat's focused and intent on what we're watching, that's because you are. You lead by example. Yeah, this chat is pretty toxic. And then there's just 95, who just exists, I don't know, as like a, succubus for internet memes that just shows up in my chat and ruins things. And we ban a lot of toxic. Yeah, that's true. Yeah, you guys do a good job. Yep, your chat is a reflection of you. So, you hear streamers go around saying, oh, my chat sucks. Yeah, because you suck. Who let you in here? Yeah, that's a rule of streaming. If you're happy, your chat's going to be happy. If you're having a bad time, your chat's going to have a bad time. What's on the cruise schedule tomorrow? Let's see. So we got a lot of PTV exercises, which is a developmental flight test op. We do have some blank time here. They're going to do some developmental flight tests with, here, hold up, with urine, I think. Flight test without attitude requirement. They're going to do something with the urine systems tomorrow that requires reorienting the capsule. That's in the morning. This is some type of exercise flight test objective. I'll bet you it has to do with the Avatar experiments. That's probably why they're interviewing the doctors and all the people that are involved, because they're doing it again today. And they've talked about doing different types of workouts on there. I'll bet you it has to do with figuring out different ways for medical. It's medical stuff. Now, the big thing tomorrow, guys, is repress. The capsule right now is sitting at 10.4 psi internal pressure. Now, that's 0.6 atmosphere, all right? So 10.2 psi is 0.6 bar or 66 kilopascals, depending on what pressure system you use. They're going to repress to 14.7, which is 1 bar or 101 kPa. The reason why the capsule's down at 10.2 psi right now is because they are testing being able to bring the capsule down to 10.2 to equalize pressure with Starship or Blue Moon Mark II. Now, I know what the next question is. Why does Starship have a different cabin pressure? Having an internal cabin pressure at 10.2 psi is better for the suits, for the AXEMU, to get in and out of the capsule, get in and out of the landers. It's better for it because you have an airlock. It's lower pressure deltas here. They left it at 10.4 even after the suit test. Yeah, Grump, your lungs don't mind 0.6 bar. They don't care. Actually, you're pretty much good down to like 0.3 bar. Your lungs work just fine at 5 psi. They really do. They work just fine. It's the mixture that matters. You can have 5 psi as long as it's 79% nitrogen, 20% oxygen, more or less okay. Like, it's when it starts changing, that's when stuff gets bad. But if you do the prior task and you could get down to 5 psi, you have to wait for your lungs to kind of adapt to it. But yeah, you could do that. I mean, I wouldn't recommend it, but your lungs can take it. I'm 37, Huber. Figure that, whatever that means. I'm kind of on, dude, I would say Gen Y is what I am, but I am much more like, I like Gen X stuff. I don't know what that's about, but whatever. Do they have to bring up the O2 for the lower pressures? Rev, they are operating at a slightly lower or slightly higher O2 concentration. I believe they said they were up at 27% O2. The last AGA reading I heard. I like Gen X things, dude. I never hung around with kids my age when I was younger. Always older. Plus, the suits are much more comfortable and easy to move in at 10 psi. Yep. 10.11 psi is 10,000 feet in a commercial airliner. That's what they drop to if they lose pressure. Yep. Yeah, 3D. Yeah, I was born in 88 too. Yeah, so. Yeah, it's the pre-breathing with the suits, Andrew. That's correct. Yeah, like that's the thing. You don't just want to go to 5 psi. Like you don't want to do that. You have to do pre-breathing, etc., etc. You have to adjust, or else you could get the bends where nitrogen gets stuck in your bloodstreams and stuff. That's not great. I'm not the biggest expert on that, so I know that's like, well, actually this happened. Yeah, I get it. I know. All right, I'm just trying to tell people how the spaceship works, all right? Leave me alone. So that's what we have for ops tomorrow. So they're also working on the rad shelter demo, which isn't just, you know, making a fort inside of a spaceship. Let's make a tree fort in the spaceship. No, they're working on radiation shelter demo for the Orion capsule, like in case a solar storm gets near it, you know, and they don't see it coming, you can make a rad shelter to make sure that you don't, you know, have your cortisol levels spike in space. Then they're doing something with the docking cam, which is an attitude requirement for a developmental flight test objective. And then they have a manual pilot demonstration tomorrow. That should be cool. We get to see people flying Orion around again. And then that's it. And then on flight day 9, that's when this starts to get real. You have the entry study and then the entry conference. These are meetings to make sure everybody's on the same page about what's going to happen over here. Right? You have a PAO event. Some stuff for National Geographic. You have a meal during the day. You have another PAO event. OIG Don DFTO, I'm not sure what that is. I know that's OIG is Office of Investigator General, but I don't think that's what that means in this context. On flight day 9, you have the RTC-2 burn, and then on the Movisico, they've got, I don't know what that means. And then they're going to reconfigure the capsule for entry stowage at the end of flight day 9. And then sleep. And then flight day 10. You get up, pre-sleep period, and then that's on Friday, and then one last return trajectory correction, daily planning, further reconfiguring of the cabin. They're going to don their suits, right? And then reentry. I don't know what I'm going to do after this, dude. What is entry study? That's when they're going to basically get out the checklist for what they need to do for reentry and learn it better. What does it mean, ANU? Where is that? Oh, ANU is the communication. That's the communication avenue. ANU is that buzzing noise that you're hearing right now. What am I going to do? KSP? I'm going to feel like finishing a really good show. Yeah, I know play KSP, dudes, but yeah, I don't know what we're going to do. I suppose let's just enjoy where we're at right now. Do we think we even have shippable materials capable of building a moon base roof? Yes. Meteorites hitting the ground are hard enough to cause a flash of light is rather powerful. Something that could survive that would have to be pretty heavy. We aren't so Yoshi, do we have anything? I don't know. Should we send something? Yes. Should us not having anything that would work in that scenario prevent us from sending up a moon base? No. Send up a moon base and figure it out as you go. Build redundancy into your plan if you're not sure. Right? Like, it's not, oh, well, I don't know how to solve this problem. How are we going to solve this problem? We could sit down here and think about it, or we could get up there and fix it. I played No Man's Sky Master. I not a lot, though. Like, maybe 1 or 2 sittings. Maybe I missed it, but do you know why they kept integrity at a lower pressure for a few days? Test docking functionality and pressure equalization with landers. I mean, guys, you got to remember, if Starship does what SpaceX wants, that's 100 tons to the lunar surface. 100 tons. That means you could have 20-ton sheets of lead. And just put that down and put a base underneath it. With 100-ton capacity, you could build whatever the hell you want on the moon. What is that WB-57 aircraft? The WB-57 is a highly modified version of an old Martin B-57 Canberra bomber. The RB-57, the WB-57 is derived from a modified version of the B-57 called an RB-57, which was a reconnaissance aircraft that the Air Force used in the 50s, 60s, and the 70s. They eventually phased them out because that bomber is basically from the Korean War era, and NASA got some and actually refurbished them, and they used them as high-altitude reconnaissance planes, particularly for imaging launches, amongst other things. The lunar regolith would be a good radiation shield. We're not, but Pi, we're not talking about radiation. We're talking about MMOD, right? Yeah, no, you're not wrong, right? But we're talking about MMOD. Any update on the WB-57 that had the gear failure? It's in refurbishment. Jared talked about it in a press conference, dude. I forget which one.
This is Artemis Mission Control in Houston, Texas. We are currently 6 days, 5 hours, and 39 minutes and counting into the Artemis 2 mission following a liftoff from NASA's Kennedy Space Center in Florida on Wednesday, April 1st at 5:35 p.m. Central, 6:35 p.m. Eastern Time. The crew on board the Orion spacecraft, which includes NASA astronaut Reed Wiseman serving as the commander, NASA astronaut.
Integrity, I've got AGA readings for you.
Here we go. Cabin readings. We were talking about this. Listen.
We are ready to copy.
Okay, CO2 is 1.1, O2 is 27, cabin temperature is 74.8, pressure is 10.35, and I think we would be ready to go to the reduced fan settings if you could do that for us.
We will put that in work.
Nice. That's not Kelsey. That's Tess Caswell. She's the Capcom right now. Yeah, CO2 is going down. It was at 1.6 before. 27% O2. Right on the money for 10.2 psi. That's what you want. Let's say there was an ISS on the moon. How high would it seat? How high would it seat from the moon? I mean, Night Skull, you could put it wherever you want. Dude, you could put it...
This is Artemis Mission Control. You just heard the crew, namely CSA, or Canadian Space Agency astronaut Jeremy Hansen, called down with some AGA readings. That stands for Anomaly Gas Analyzer, which is a portable laser-based instrument that detects trace contaminants and also provides updates on levels such as carbon dioxide in the cabin of the Orion spacecraft. They provide these readings periodically throughout the day and throughout the entirety of the mission. The console position here in Mission Control that monitors these readings is ECOM, which is the Emergency Environmental and Consumables Manager. And they are responsible for the internal thermal control systems, air and water supply, and purification systems, and they also manage emergency response.
74 is actually that it was the highest temp we've seen is 77 coming off the AGA. OIG Dawn DFTO is getting out the pumpkin suits and getting them ready for reentry. Got it. What is the one thing fact that annoys you the most about moon conspiracy theorists? Hang on, let me see what Crafty said before you. Is the moon's SOI too small to support the lunar equivalent of geostationary? Earth will pull you out of lunar geo. In terms of ISS orbits, guys, you can put the ISS in any orbit that you want, but you have to take into account that the moon has precession and it has non-uniform gravitational pull. You could put something in a 20-mile by 20-mile orbit and be like flying, like skimming the top of the Mare if you really want to. But the moon will pull you in, and you need thrusters. It'll pull you in. You won't. That orbit is not stable, even on the moon. It'll pull you in, and you'll crash. So you have to find the balance between finding an orbit that's easily accessible, right, but also doesn't crash. Because you're going to need to use your thrusters to stay in that type of orbit. That's why Gateway exists. Gateway is that compromise.
The crew on board the Orion spacecraft is currently winding down for their day, although they spent most of the day in an off-duty period, so they were free to do as they pleased. So the crew is wrapping up some exercise using that flywheel exercise device, and then they will be moving into their daily private medical conference with the medical teams on the ground, and these are daily conferences throughout the mission, and then they will move into their private flight director conference. So they also meet daily with the flight director and mission control to provide an update on vehicle status and answer any questions or comments they may have for the remainder of the mission, along with some of their upcoming activities. And then once those 2 private conferences are complete with the crew, they will be heading into their pre-sleep period. This is an approximately 2.5-hour block of time during which the crew typically eats their dinner, and they also prepare for sleep by completing any hygiene activities and winding down for the day. Today, during dinner, some of the options for the crew include tomato basil soup, lasagna with meat, Italian vegetables,
as opposed
chicken
to German
strips
vegetables?
and salsa, and maple cream cookies.
Maple cream cookies. All right, now we're talking. Yeah, Italian vegetables as opposed to German vegetables or Spanish vegetables. No, like, that's fine. So anyway, Bet, you asked, what did you ask over there? What is the one thing that annoys you the most about moon conspiracy theorists? They don't really use their brain. My thing about moon conspiracy theorists is that they can think. They can think. They're clearly capable of...
The Space Food Systems Laboratory here in Houston.
They're clearly capable of coming up with complex, abstract things. But the thing about them is that they seem to think that they know more than everybody else and have not bothered to learn basic things about physics. Almost like they completely wrote off the entire